May 11th, and I'm your moderator, Tim Ventura. I want to thank everybody for joining us on today's call, along with everybody watching us on YouTube. So today, Brendan McNamara will present the Race to Infinity, Interstellar Propulsion. Russell Anderson is going to be discussing the history of John Searl and the Searl effect. Isaiah Ritchey will present on his SEG Replication project. And Bob Greenyer is going to be talking about exotic vacuum objects. We're also going to be hearing updates from our lab partners and finishing off the event with open discussion. So I am really excited. I want to give a shout out to all the new attendees joining us today. We have had a lot of interest and a lot of signups for our mailing list, resulting from media attention from Drew Arigma and Charlie Bueller's work at Exodus Technologies. So that was originally published in the debrief, and it was picked up, and various versions of that have either been republished or rewritten by Next Big Future, Futurism, Yahoo News, Interesting Engineering, Popular Mechanics, Boy Genius Report, as well as Newsbice India, Tech News Taiwan, IFL Science, MSN, Wired News, and Earth.com. It is all over the place. And I am really excited. The work that they are doing is worth the attention, and it is absolutely worth checking out. So, for everybody who's new, I want to give you kind of a brief update, very quick overview. APEC started back in the pandemic, actually. Mark Sokol, Jeremiah Pop, and Jeremy Riss basically had this idea. They said, well, we're stuck, but we want to do a conference about these technologies. Why don't we do this over Zoom? And they got in touch with me because I'd done work in this area in the past. And so together, the four of us basically just started this Ad-Hoc conference. We didn't think it would last. We thought it would be kind of a one-time thing, but it started to grow. And we have had well over 100 speakers, many of whom have spoken 2 or 3 times. I believe this is our 60th webinar event. So it just continues to grow and get better and better. Pretty much every pivotal technology or path of research in this area has been covered many times from multiple different angles, as well as lots of stuff on the UAP phenomena. So our conference draws from a legacy of several communities that kind of came before us. I wanted to mention those briefly. One of those was the High Frequency Gravitational Wave Conference in 2003. That was a giant conference. That was something that Bob Baker basically came up with. Dr. Ning Lee was involved with that. And that kind of evolved into the ISNPS STAFE conference. STAFE is something I used to travel down to Albuquerque to cover. You had a lot of people there. Again, the gravitational research people, as well as fusion propulsion and a lot of other, exploratory technologies. After that, Tony Robertson came up with the IAS SPES SPECIF conference. That kind of built on STAFE and again, absolutely massive, continued to kind of expand what STAFE had started. And we also draw from Estes Park. That's James Woodward's conference. So James joins us regularly, as well as Curtis Horn. We've had Hal Fern, some of the folks from that. And we've also drawn from Sarfatti science seminars. Jack Sarfatti has come on several times talking about his weightless warp drive, metamaterials, and things along those lines. So those are kind of the conference communities. The other thing that we draw from that is truly, truly exciting is a massive body of builders, makers, and people who are doing hands-on work. A lot of those are just in their garage, and that is, it's wonderful for them to join us and bring what they have and share and exchange ideas and information on how they can continue to experiment with new propulsion technologies. So that's a little bit about our conference. The reason I mention that is I have been updating the APEC website all week long. Every page on that website has artist renderings on it now, and we're really proud to showcase the artists who have helped us here. It's tremendous vision in space art. I've added a search feature to it, which should be very helpful. That's on the events page. There's also information about those past conferences, more info about our team. Everything that you would probably want to know about APEC is now on the website. And what I'm hoping to add, actually, this dovetails into my next piece, is 2 more sections. I realized that, we have had hundreds of presentations. We've had some really amazing moments at APEC. Several of them have been newsworthy. For instance, Roger Scheuer made headlines worldwide at APEC when he talked about progress with his research. So that's something that I need to put links in. I'm hoping to have that done in the near future. I'm just going to have kind of top moments in APEC history. Obviously, I can't list them all, but I will try and get some of the ones that are really worth watching and digging into. So that's one thing. There are a couple other bits and pieces that I need to add as well. I also want to add a documentary section. Now, in terms of documentaries, I am hoping to visit Charlie and Drew down in Florida. I may end up visiting Mark in New Jersey at his lab. I want to get detailed footage and try and capture more about what they're doing there. This week, I will be visiting Jared Yates for the Graviflyer, and he's down in Oregon. And then at the end of the month, I will be going to the SCU conference to hopefully capture more about the UAP phenomena. So I'm going to be putting all of this up on the Alt Propulsion channel. And I don't have a true plan there yet, but I am hoping to make some kind of documentaries about this as well. I want to try and get you guys the absolute most information that you can have on these topics, and that'll help your own research and help fill in any gaps in terms of knowledge. So that's what I have for today. Still working on the footage from Asilomar last month. Lots of updates on the website, prepping for travel, and just lots and lots of stuff. So I would say check out the new Alt Propulsion website if you can. Lots of new material there. And I want to launch right into Brendan McNamara, who's going to be talking about the race to infinity, interstellar propulsion. He's going to be running us through a list of propulsion types. So I'm going to add him in. Brendan, welcome, sir.
Hey, good morning, everybody. I expect you were up late last night as well, watching the beautiful light shows. I feel like it's auspicious timing, the list of accomplishments and where the media is at on all this. You just listed off, plus all that. It just feels like a convergence of sorts. So
yeah. Well, it's a community effort. Like I mean, and you've probably heard me say this, but I try and APEC is not me. It's not Mark. It's not any of it's all of us together, right? That's the whole idea. So, and so, yeah, it's wonderful to have that media attention, because what that does is it draws attention to this area. I mean, like, in the case of Charlie and Drew, they have been slaving over this for years. It's good for them to finally get recognition for their hard work and achievements.
Absolutely. So I'm hoping to highlight some of that and kind of bring it all together, sort of from a 10,000 foot elevation of all these different tangents happening. And it doesn't all specifically relate to propulsion, but we're going to find that it's possible that moving physical objects across all that space and time might be a lot harder to do than moving data and experience itself. And so it's interstellar. You could replace the phrase interstellar propulsion with interstellar journeying. But so, here we go. I've got a pre-record that I did just in the nick of time, literally. And I'm going to play that for you.
Yeah. So for this one, again, what we're going to, if you hit the present button, I'll try and walk you through it. And then it will make you choose, if you're going to play this through your browser, choose the window that it's in your browser. And I think that'll do it. So.
Okay. Let me see.
Oh, look at that. You've got a lab assistant.
Yeah. And signs of intelligent life. Hold on. I've got to share that screen. And can you guys see that?
Tomato.
Okay. Yep. I see your screen. There we go. Look at that. Yeah, looks great, man. Okay, well, why don't I do this? I'm going to take myself out, and you and your assistant will do a presentation for us. Oh, Brendan, I should mention it's not playing sound. So you know what? You might
Hold
have
on.
to reshare that screen. Share
Okay.
screen. Yeah,
Okay.
and
There's a
also
special thing for the playing sound.
yeah,
Okay.
Zoom has the same issue.
Okay. I was wondering about that.
No worries,
So
man.
let me hit share screen, share entire screen. To share audio, share a tab instead, is what it says.
Okay, so maybe is there that's in a browser tab, so maybe you can share a
It's
tab.
actually in it's on local file on my PC.
Maybe
So
drag that file into the browser and then you can play it there.
do you think Firefox can play MP4?
Yeah,
Oh
should be
boy.
able to.
Okay. Okay. Never tried that before. Oh boy. What is this? Got a little bit of a technical hitch.
Yeah,
Oh,
for StreamYard, usually we recommend Google Chrome. That's
okay. So Chrome tab. Oh, it wants to be in a Chrome tab. Wonderful. Yeah. Okay. I better open up a new Chrome browser window then.
well, so what you may have to log out and log back in.
Well, let's just see if this works.
Because it's not because
it doesn't want to do it from a Chrome tab.
Okay, so Brendan, you're going to need to quit StreamYard and log back into StreamYard in Google Chrome.
Okay, well, I'm in Google Chrome on this one. I'm just saying it's telling me that it wants to be in it wants to be shared to make the audio work. It wants to be shared from a Chrome tab, which Firefox is more than willing to do, but Chrome doesn't want to share the audio. So
I mean, do you want to narrate over it or?
Well, I pre-recorded it so that you wouldn't. You see how I'm crawling. I've got a human infestation here. And so hold on a second. So it'll only work through sharing a Chrome tab, the audio that is, or
yeah.
Okay. Thanks. Okay. Why doesn't that work? Okay. Is there a possibility to we should have already gotten this up to YouTube. Is there a possibility to delay for 20, 30 minutes?
No,
Okay.
you know, my thought would be, is there a way to run through this as a presentation? I mean, you have a slide deck, right?
Yeah, I'll do it from. I can do it from scratch. I mixed in a bunch of videos and stuff though. So, man, I expected StreamYard to be more fully featured than this. But let me see. Why don't I? Yeah, let's do that. Shouldn't let myself get last minute. Okay, let's do this from scratch then.
Yeah, no worries, man. No worries. Yeah. So, I mean, if you're able to upload, maybe just upload the slide deck or just share. You could share the video. I mean, that was fine, and you could talk over it.
Okay.
Or, I mean.
Okay, if I can share the screen and I've got the slide deck, or I'll share the video and try to narrate in the meantime. How about that? Pick a lane and stick to it. Okay. And share.
Yeah, no worries. We're mellow. We're mellow.
Hyper mellow. Okay. It just occurred to me I might have to run really quick. I have to run really quick and literally take something off the back burner. I was expecting to let go while I let this go. Just really quick. 1 second. Okay, so we'll make this work. So I have to turn that up. Okay, so I'm an ecologist. I'm a computer technician. I'm a farmer and a carpenter and a few other things. And I've always been obsessed with interstellar travel and aliens. And I've just always wanted to meet aliens in my life at some point during the course of my life. Although that's extremely difficult for various reasons, and we're going to be able to see why. And we have the challenges of interstellar travel, which are quite immense. And in a nutshell, space is big. How big is it? Well, it's so big that we don't really bother to measure the space itself. We measure light and time, which is more like the amount of time that it takes light to get across it at 186,000 miles per second, which we call light speed. That's a measurement we call a light year. So that all said, it takes about 4.396 light years. Well, it takes over 4 years for the light from the nearest star to get to us, which is insanely long distance. And that is a distance that would take about 30,000 years for our best rocket to reach. So we clearly need a better way to propel ourselves through space. So we have some conventional approaches which have been tried and are being developed, among which are ionic and plasma propulsion. These are powered by nuclear sources such as fission and fusion, as well as solar sails, which are mirrors that catch a ride on a sunbeam or a laser using the photonic pressure of the sun or some other source of light. Although those are very unrealistic because at least for moving people through that gap, because of the massive difference between the necessary size of the mirror and what you end up getting to move in terms of your craft. We also have antimatter photon explosion propulsion has been suggested as a way of if we can manage to harness antimatter and send that out the back of the craft and create massive explosions that generate a force against like a bell behind the craft or a pusher plate. And that is a way of moving through. Although these are all still relatively slow, we still have the time problem of not being able to possibly get through a single journey as human beings in the course of our own lives. So we have generation ships that if humans won't make the trip, we can breed and basically keep a civilization alive on the ship, moving between place to place like a colony in the form of a ship. Cryogenic freezing, which is very popular in space travel movies and sci-fi, where we put people to sleep to make the journey, put them on ice, in other words. And that's one way to do this. Genetic arcs, which is the idea of basically putting everything, all the data, all the DNA and the raw materials on a ship and sending them to the other side of the galaxy, and to print everything necessary on the other side from just raw material. And that's considered more feasible for some reason than warp drive, although I'd second guess that. We also have the potential for robotic probes, which is to send only automated machines, and they would have to be very advanced AI in order to accomplish their goals on the other side and be able to just survive and long enough to get a message back to us. We're basically relying entirely on the intelligence that we imbue them with to do so, as well as the concept of von Neumann probes, which is machines that make more copies of themselves and more copies, and those copies make copies in order to slowly, but relatively quickly, conquer the galaxy. Although none of these are very good because they don't solve the problem of how do we get there in a single human lifetime. And also, none of them can really get through the gap because light speed is impossible conventionally to reach. And there's reasons for that. That's as you get faster and faster, you need more energy to move your mass forward. And there's an asymptotic curve as you attempt to approach the infinite there. So that's exceedingly difficult. I have to bring it. Drawback. So we have the potential for warp drives and wormholes, which essentially move a ship faster than light by moving space-time instead. And that gets us relatively near instantaneous travel relative to a static reference point. And some examples of this are the Star Trek antimatter warp drive, which is fictional, as well as the Alcubierre Drive, which is a theoretical spin on that fictional concept where he made that make sense with Einstein's field equations, as well as Salvatore Pais's FTL drive and Jack Sarfatti's low power warp drive. Those are a little bit more realistic and bring it within the bounds of human engineering, whereas Alcubierre left it in pretty rough territory as far as the energy requirements. And we also have wormholes. And this is basically the other side of the same coin because both involve a perturbation in space-time and literally engineering the space-time metric. But this punches a hole through space-time by bridging two entangled points, facilitates instantaneous travel, or the destination and the origin become the same, essentially. Some examples are Stargate, A Wrinkle in Time, the Spore Drive from Star Trek Discovery, and we have some people working on this in the form of counterportation, which is we'll mention later. Now, Alcubierre did us a great service in 1994 by developing this concept, his Alcubierre Drive, and that utilizes space-time compression and expansion to enable faster than light travel with a few hurdles behind it. This creates a warp bubble that bends space-time around it, removing it from the effects of inertia. Theoretically, it operates within general relativity laws, avoiding relativistic time dilation, but it requires this insanely high negative energy or mass, which hasn't been officially discovered or demonstrated in the lab. Although recent research suggests the possible methods to circumvent or eliminate this need for negative energy, and that the energy requirement is very high for it. Now, Sal Pais put this concept out that the Pais effect controls charged matter with vibration and spin for fusion containment. And it has a UFO-like craft with a kind of a pointy front that uses microwave emitters on xenon gas to convert that to plasma, and that plasma is made asymmetrical or non-equilibrium through precise application of frequencies that are accelerating or decelerated to achieve harmonies in that medium. And it achieves high enough energy densities for space-time warpage thereby, and they're warping space-time or the polarized vacuum if you're using the Hell-Puthoff framework. The propulsion mimics observed UFO phenomena, theorizing the space-time voids based on Casimir properties for movement. So Sal emphasizes that his approach is a new perspective on established physics for technological breakthroughs, or as he says, it's new engineering, not new physics. And it's not new physics, it's new interpretations on old physics. He's very fond of saying. So that he's become quite popular, and his patents have kind of broken the internet, and a lot of people are speculating what those are for, why the Navy has put those out and made those available. We come to Jack Sarfatti's low power warp drive, which is also the talk of the town on the internets. He accomplishes this through metamaterials that offer refractive index changes of the speed of light c by changing electric permittivity and magnetic permeability, aka epsilon and mu. The refractive index, although he's got a more direct way of affecting that. This permits space-time metric engineering with much lower power requirement by mostly front-loading the work into optical metamaterials and sort of taking the energy. And the drive itself uses less energy at the time, because a lot of that energy, space-time information tension, is put into the materials to do the work. And this predicts red shifting from high gravity on the leading edge and blue shifting from negative gravity on the trailing edge of light, resulting from space-time modification on either end of the craft. And this is possible thing that we can look for in actual UAP as we move forward. He's put out that prediction to a couple of people. Examples like UAPX, Galileo Project. Those guys can keep their eyes peeled. And I think that I've come across a piece of footage that actually has something like that when I increase the contrast. Some blue shifting and red shifting. It's really interesting. Get a hold of me later if you want to see that. So the red on the front is also adjacent to gravity, which is positive curvature, space contraction, time expansion. The blue is anti-gravity, negative curvature, space expansion, and time contraction. And those are on adjacent sides of the same craft. We get to multiple other warp drive concept models. These are the ones, bringing down that energy requirement, making it more feasible, more of an engineering problem, as they say. The Natario warp drive lowers exotic matter and energy requirements by simplifying the bubble geometry of your warp bubble. We also have the warp drive from Maxwell's equations via Todd Desiato. He's a regular contributor up in here, and his work is top notch. Quantized inertia, while it's not officially a warp drive, Mike McCulloch has developed a way to isolate parts of the universe from the rest of the universe. In other words, neutralizing inertia, or greatly reducing the effects of inertia, which is one way to allow for light speed travel by getting around that light speed cop. We also have a spherical warp bubble hypothesized by Yuri Urashenko to get away from the event horizon of a black hole, as well as Casimir property warp drive by Fernando Loop, and the framework of polarizable vacuum engineering by H. Puthoff, also known as Hal Puthoff. That's very interesting. I might explain a few other things that we've observed with some of these models. Next screen, Brendan. Interesting. So, continuing that list, Sonny White put out some work about nanoscribe metamaterials fostering Casimir cavities that collectively warp spacetime. And that's very interesting. These are basically 3D nano printed structures that whose special property creates Casimir voids, but imagining a whole surface that's basically covered with these, and how those could add up to macro effect of space-time warpage, which is extremely interesting. And another paper, I think in the same vein, about AI designing those structures for optimal space-time warpage and Casimir pocket creation, which is sounds a whole lot like a self-generating, almost living kind of craft, which is quite exciting. And we are all familiar, or not, with T. Townsend Brown, who developed the B-field Brown effect, aka asymmetric capacitance. So if, as Hal Puthoff conjectures, space-time curvature is a result of energy density variation, the Byfield Brown effect may be a low-level warp drive, in the same sense that full faster-than-light warp is a scaled-up Byfield Brown effect drive. So they're mirrors of each other in a sense, or refractions. They're just different scales of the same effect. In other words, it's using electrostatics and energy density to manufacture space-time variations. We also have the development of this thing called Warp Factory, which is, I just saw a Popular Mechanics article about, which is showing off the ability to take these pieces of math and turn them into interesting visualizations in real-time 3D, basically taking all of this theoretical work and putting it into a much more engineering context. And already that's been out not even a month, and there's somebody's already made a version of a warp drive that completely eliminates, I think, the energy discrepancies. Forget how they put that exactly, but that's pretty amazing. And that's meeting all the energy requirements using a stable matter shell, which is pretty far out. So we're making progress there. One could say we're moving at warp speed. I have to, pardon the dad joke. You see, I'm qualified. Now we come to wormholes great and small, which means essentially there's this thing called the ER equals EPR conjecture by Susskind and Maldacena. Einstein and Rosen showed in 1935 that two black holes at significant distance can be connected by a tunnel through space-time, aka a wormhole, especially at regions of intensely warped space and high energy like black holes. But in a little bit later, much later, Susskind and Maldacena, Leonard Susskind, Maldacena, proposed that this is essentially the same as two entangled particles, and that particles at the quantum scale could be connected through micro wormholes the same way that you've got black holes connected through macro wormholes. And it turns out that modeling wormholes turns out to be a super useful application for quantum computers. We're actively looking for applications for those. And that the complex nanocircuitry in conventional and quantum computers and or the human mind could be entangled with micro wormholes to move data faster than light across space and time. Pretty exciting stuff there. We get into the implications of faster than light travel, which is essentially time travel, forward and backward. People are usually familiar with the forward time travel, but faster than light brings in reverse time travel, which also brings in the possibility of inter-universal branch jumping, directly or indirectly. So Eroshenko wrote a piece about this in his Escape from a Singularity of a Black Hole with a Spherical Warp Drive. And also there's a video here from Veritasium about this concept that's pretty in-depth and very, very cool to look at. Basically, that the ability to move between types of space-time affords you the ability to get past these things. It insinuates, FTL insinuates potential reverse time travel, because traveling faster than light takes you past that 45-degree null geodesic that light takes through space-time. And other Earths, alternate timelines of our own, which are living simultaneously in the multiverse, according to many worlds theory, popularized by Sean Carroll and others. It's very unlikely to find any exact matches for this planet out there in other space times. The atmosphere and the biomes of other terrestrial worlds could literally attack us. So one solution for travel to other Earths and possible explanation for alleged humanoid visitors is that they're journeying to us from other Earths, and we could journey to other Earths from here using these properties of space-time once we get to FTL, which is very interesting. Imagine going to another version of Earth where the dinosaurs didn't die out and Trodons evolved into advanced humanoids. But imagine them coming here, and what those reactions would be like. You'd be less likely to get just attacked and annihilated by the dust and spores, and bacteria and chemistry of that atmosphere if you went there. Much better for colonization. So the same tech that will allow us to go to other solar systems might let us visit any and all the other alternate timelines of our own, as far back as you want to go in the branching. And if you want more on this, I've done a few talks with Daniel Davis on YouTube about this multiverse branching and faster than light and time travel. Now we get to some truly odd solutions like mental travel, which is a little bit more straightforward than you might have heard. And that's basically transcendental meditation on steroids, assisted by entangled micro wormholes and or altered states of consciousness and electron spin resonance changes generated in the molecular circuitry of the biological brain. Some examples might be the Dune Navigators, Tesseracts from A Wrinkle in Time, astral projection, remote viewing, these kinds of things that have been described by various people, and according to some have some backing, maybe even research in the US government. So a little bit more realistic than previously thought, although definitely need more objective verification. And next, we also have quantum computer simulations, which above and beyond normal simulations, digital simulations, through the combination of generative AI, quantum computation, and possibly photons from destination systems, going back through that network, allows us to project realistic, possibly accurate simulations of alien worlds, just as good as the real thing. And that given that quantum computation depends on superposition, pulling from many worlds, the reality of these simulations may be purely academic, in the sense that as you're doing quantum simulations, especially on quantum physical phenomena, you're not doing simulation so much as actually doing the physical thing, performing the actual event, and examining physical processes as they actually exist. And we have the potential of entangled communication, projection of more than just trading emails over the galactic information superhighway, sharing multidimensional broadband experiences and visual acoustic data, visual or acoustic data through a network of entangled gravity waves. And so is it possible that visiting ETs are doing something like all three of these? We may find out. More on mental travel and altered states. So Terence McKenna talked about the effect of given psychedelic molecules fitting like a disc into a jukebox of nanomolecular circuitry of the brain, changing electron spin resonance, bringing us some closer alignment with other states of consciousness. And also we have the example of Jeremy Narby in the Cosmic Serpent talked about ayahuasca shamans drawing cellular processes that they were able to visualize, and basically they were drawing things from their experiences, and without prior knowledge of biology or subcellular processes. And Jeremy showed these to a biologist friend of his, and said these are organelles. These are splitting chromosomes undergoing mitosis and that kind of thing. We also have Bernardo Kastrup, Donald Hoffman, Rupert Sheldrake, Chris Langan, Roger Penrose, all idealists or adjacent to idealism, hypothesizing that consciousness is primary, not space-time. And as well as Stuart Hameroff, who talks a lot about the microtubules in neurons. And he's got a presentation where he mentions some work that shows that microtubules act like light receptors and possess quantum properties that may have implications on the nature of consciousness and how it renders. And then in religious texts, you have in the Jewish tradition something called Kefetzat Haderach, which is these rabbis that were said to be able to project their consciousness into other locations, as well as in the Quran mention of Te'al Ard, which means earth underfoot, which moves the traveler, or rather moves the earth, and that seems to insinuate some sort of warping, as well as lots of accounts of Indian yogis projecting into multiple places at once and being seen in multiple places at once, the same person. And that's really interesting. And in the CIA, they were playing with remote viewing experiments and came to some success. It's some very interesting stories about submarines being seen. In Dune, you have the navigators, the Bene Gesserit, the Kwisatz Haderach, all the one that can be many places at once. That sounds like reference to some sort of warping. As well as it turns out that Frank Herbert himself was partially inspired by magic mushrooms in the creation of the concept of the spice in Dune and the mental travel there. And this is something that Paul Stamets has confirmed on an episode of Joe Rogan and other places. Although he says that Frank didn't tell his kids or anybody else at the time because it was still kind of faux pas and highly illegal, or at least much more illegal. And so through all of this, there's a little bit of question about, are these things real? How do we objectively verify mental travel experiences? Well, we could develop frameworks and techniques to objectively verify these things between researchers, and or record it through a brain computer interface, which now we have much more so, and at least that's become a reality that we're facing now. I think there was a paralysis victim that had the ability to move things in a computer. So if that's possible, is it also possible to take dreams and record them through a computer? So simulations as travel becomes a lot less of a projection if you're involving quantum computers. We already have hyper realistic 3D VR simulations. We have generative AI visualizations, images, and soon to be video. We can use these to do hypothetical world branching through speculative biology and speculative evolution of different worlds. We have procedural generation of world conditions, which that occurs in a lot of video games now, like Space Engine, No Man's Sky, Subnautica. These are very popular. There's a whole exobiology niche of video gaming that's emerged in the online scene now. It's very bringing about new types of experiences on the fly. And so put all these things together, we could have AI that generates realistic experiences from your real-time input and puts you into different worlds, basically. Now, you add to that the possibility of Neuralink or some kind of brain-computer interface providing the input and the feedback to the system, and you can have the possibility of experiencing these worlds yourself if you can link those up, interpreting alien languages, that kind of thing. And quantum computers superposition the problem going through many worlds, like we said. And so that, I would say, increases the chances that out there and somewhere in infinity, it's pulling a real result that's plausible or possibly even accurate. And the line between the simulated and the real definitely becomes a lot more blurry then. As well as prior to full-on quantum computing, which we don't have at scale just yet, we have analog computing and language processors, which are doing computations differently by instead of just pure ones and zeros, they're doing calculations on fractions of one that are in RAM, in I think, yeah, in ROMs or in RAM, forget which exactly, but they're able to do, it's not an abacus, not going that far back, but they're doing, it's much better at generating random data and random numbers that we can use to do these kinds of things, as well as language processors, which are dedicated. So thus far we've been using AI to do AI. We've been using graphical processors through NVIDIA and the like to do these things, but now we have actual processors, and Grok is using that. We have the possibility of black hole simulations, which I think that Hawking hypothesized that you could have a spinning black hole that gathers information on its surface in the form of like software hair, similar to a hard drive, as a factor of information conservation in the universe. That as the black hole destroys the matter and energy, or doesn't destroy the energy, but it destroys the form of the matter around it, that information and energy could be stored. We might be in a black hole simulation, and there might be smaller simulations within this, and they all kind of link up. It's very, very interesting possibility. And as we develop more of this ability to change the space-time metric through various materials, these other guys are working on, one of the outlets could be not just propulsion, but the ability to manufacture simulations on a gravity well. So when we experience the different these different things, we have to ask who are the observers and who's doing the observing, and do the different simulating or the simulated worlds connect possibly. When we see quote unquote visitors from other worlds, are they people running the simulation? Are they living in the simulation? And where do those cross over? That's the question that I have to ask. Where does it connect, and how real is it exactly?
Band-Aid. I want a Band-Aid.
So yeah. I have to. Can you get him a Band-Aid really quick, please?
Where's the Band-Aid?
Up there. Can you please? So we have the potential for an entangled internet of experience, which is that matter is exceedingly difficult to move across space-time, whereas data is extremely easy, as we've seen. And please, thanks. Up there. And as a facet of that,
we have the ability to create data structures and share those data structures and connect them through these digital experiences. And entangled communication might not be possible yet officially, but it might be soon. And just look at the simulations of wormholes that we're doing on quantum computers. One outlet here is what Raymond Chow is doing on gravity wave communications, which isn't officially entanglement by itself, but he's using entanglement to take electronic communications and move them through gravity waves and vice versa, which could be leading to lossless high bandwidth packages that goes through planets and across solar systems and stuff. So we could be looking at holographic experiences. The counterportation, as I mentioned beforehand, which is using micro wormholes to transport information through quantum computers, from the previous examples on wormholes. And so more than just email, remote projection of 3D avatars into each other's locality and meeting digitally on a central server space, similar to, you call your friends up and you meet up on Call of Duty or Battlefield or one of these, Halo and stuff like that. But you could have these dense, graphically dense, acoustically dense, maybe even with digitized feelings, just high bandwidth experiences that we're all sharing. So the universe could be teeming with these signals carrying high resolution holographic experiences. We just haven't turned that on yet. And is that what the psychedelic experience represents to an extent? Is the influence of other advanced species possibly leaving tracers on our world that allow us to connect, and or when we develop more high bandwidth computing interfaces and quantum computing to a greater degree, we might be able to do these things. So other players in the game just waiting for us to log on basically and join the party. It feels somewhat like that's where we're getting, much more so, to a point where our ability to simulate and our ability to project our consciousness leads to the conclusion that it's just kind of one big wibbly wobbly timey-wimey soup of experience that we're all sharing, and just we have the illusion of being the only ones playing right now, that we've been NPCs up until this point. And that the visitors we experience might be holographic avatars experiencing our own world remotely. The next generation of the internet might be some kind of deep communal experience shared with other intelligences on a visceral level. So when you turn on your computer, you get to experience other worlds. And just look at the jump in the broadband signal and the resulting taking up of that space as we got, moved from 56K out to the first cable modems and out to DSL and higher amounts of bandwidth. Humans we find ways to use that extra gap. We fill the gap. New computer technology comes out and people are like, how will we ever even use this? We'll use it. And this is the next step, because our simulations have already gotten so advanced. How much more advanced can they get? We're almost sort of peaked out. So, the next simulations are going to involve procedural AI and LLMs and all this other stuff. But beyond that, could actually be pulling from other sources in the cosmos. And that's it for now. I appreciate y'all listening to this despite the technical interruptions, and thank you very much.
Awesome, Brendan. That was awesome, man. That was awesome. So I'm going to bring Drew and David, and I'll bring Russell in here too. Guys, put your hands together and give Mr. Brendan McNamara an enormous applause. That was like an off-road challenge for presentations. So I want to thank you. I want to thank you. pushing through. I don't know if I could have done that. I have a daughter, and she's not quite as busy as the boys are, but you did great, man. You did great. So
Got to hand it to the kids on that one. They pulled through.
Now, you know what? APEC it is real, it is raw, it is live, and that is one of the reasons that we get material when it comes out instead of being, slick, polished presentations that are like a year in production and everything has made headlines already. So that's kind of where we're at.
Sometimes you can do a slick, polished presentation, but it breaks like 5 seconds before you have to play it.
Oh, there you go. There you go.
It is in this case.
Yeah, with the StreamYard has a lot of advantages. It likes to show PDFs and browser tabs. Those are kind of the two things that it prefers to show. You can do other stuff, but it's a little tricky. Zoom has some benefits, but it's also got its collection of drawbacks. So it's just technology, right? It's just the usual tech stuff. But again, I can't thank you enough. It was awesome having you present that. You did that with open mic a couple of weeks ago as well. And, I think the boys weren't there then, but it just adds to the novelty of it. So that's awesome. Okay. So let me do this. I'm going to take everybody out. Brendan, thank you again, man. Absolutely. Thank you so much. I'm going to go to Russell Anderson because we're just about at the top of the hour. Okay. And Russell, welcome, sir.
Hey, Tim. How you doing, my man? I haven't seen you
pretty
in
good.
ages.
We're 2 minutes early. Do you need a sec or how are you doing?
I'm good. I'm just finishing up a cheeseburger.
Oh, no, that's cool. Hey, you know what? This is like, trust me, this is like casual Saturday. So I was out doing...
hadn't had anything to eat all day, so I was starving. It's like I couldn't go on the show without having something to eat.
So you're down in Florida, right? Are you in Florida? Or are you still okay? Did you see the Northern Lights, or was that too far south?
No, we're like subtropical, so the Earth's magnetic field is much stronger down here because we're closer to the equator.
Okay.
So no Northern Lights for us.
So I went out last night. Just like because again we got a couple of minutes. Mark Sokol called me. He's like, "You gotta go out and get photos." I'm like, "Okay." So I take the camera out, and I had the perfect position. I didn't see anything. What looked kind of like wispy clouds, and I was just too much city light, I guess. So I went out to the country. And again, I look up and I see these wispy kind of striated clouds. And I'm like, well, they look like clouds, but I was like, I've never really seen clouds look like that.
What color? Were they green?
No, so to the naked eye, they were white. That's the part that got me. I swear to God, they were just white, wispy. It looked like just kind of, like light marine layer, just a little bit different shaped. And then when I put the camera on them, the camera picked up the green and the pink. So I don't know. I mean, I've always heard, like you see photos of the Northern Lights, it's always green and pink and blue and all that, right?
Yeah, I've seen the Northern Lights. They're like beautiful, mostly green with maybe some red thrown in, but just alpha and beta particles from the sun.
Yeah.
And they come in at the poles because that's where the Earth's magnetic field is weakest.
So I think that I was right under where this event hit us. I guess that was what my brother was out taking photos too, and I think he kind of mentioned that in one of his Facebook posts. If you want, I could here. Look, you know what? I'll put up a couple of photos for you. Again, we got a minute here. I'll torture the audience.
Actually, it's 4:00 right now. That's what I got.
Oh, do you have a sec? I can come back.
Yeah, I sure do. Yeah, absolutely.
Okay. Well, we'll do that. I'll show everybody real quick. I'm kind of pumped about this. Okay, so yeah, here. These are my photos. This one is not the best. I had to stitch together a bunch.
That's the Northern Lights. Yep, that's what they look like. Yep.
Yeah, and that's the pole. So they're not actually over the polar region. So up in the Seattle area, you're actually able to see.
Yeah, well, in intense solar storms like we're having, they come down to more southerly latitudes.
Yeah. And that's actually White Rock, British Columbia. So I was shooting just over the border. This is later at night though, and you can see there's a lot of city light from Vancouver that's kind of blocking them out. So those are mine. And then my brother, who I keep telling people he is a much better photographer than I am, he picked up that one. See, but he actually knows how to use a camera. I just kind of, point and push the button. So we got some good photos, and supposedly there's going to be more happening this evening. So I guess we'll see.
Well, I hope it doesn't take out the internet, because it's rumored to possibly that to happen, because it's one of the most intense solar storms, the high solar maximum.
Yeah, we'll find out. Well, so Russell, you've got two presentations. Let me see. You've got the I can't even read them. You've got your Kofi, and then you've got the Spintronics. Which one do you want me to put up first?
Why don't we put up the Spintronics?
Okay. And I should mention to people, so you have worked with Searl in terms of the Searl effect, right? I can't go through the whole history of this, but there are only 2 or 3 people in the world who have any expertise or knowledge. You are one of them, right? And I
Correct.
mean, so again, I cannot thank you enough for joining us and walking us through this. You've worked with John Searl.
Why don't we do this one first, the artificial gravity, electromagnetic propulsion, because that's what it is. And that's a nice graphic of the SEG Searl effect generator, which we now call the Spintronic generator, since Professor Searl copyrighted his name in 2014. So we just call it the Spintronic generator, which is the effect that we're seeing.
Well, let me do this. I'm going to take myself out, and there are back and forth buttons for slides right on it. You can click right through. Just let me know.
Great.
And I'll put the next one up when you're ready. Thank you again, man.
Okay, well, let me see if I can control this myself. Yes, I can. Okay. Inverse gravity vehicles, that's the vehicle that resulted from Professor Searl's technology. The original generator or converter itself was not supposed to be a flying machine. It was just supposed to be a unique kind of electrical generator. Well, when they started it up in a field, it was first built at British Rewinds and Repairs in London. When they started it up in an open field with a diesel generator to get things going, because the fields weren't correct. If the fields are absolutely true on your plates and runners, which are the rings and rollers, you don't have to run anything or do anything. It's really interesting the way this thing works. And it started putting out far more voltage than anybody expected, and very high voltage, smell of ozone. And then it got really started spinning really fast, and lifted up, got up to about maybe 30-40 feet in height, and a pink halo surrounded it. And then radio receivers, TV receivers around the area would go on of their own accord, full volume. So that's some kind of electromagnetic induction effect there. And then after the device developed a pink halo around it, it took off for parts unknown, straight up. So that's really was quite a surprise. After 5 more generators were lost in that manner, they said, well, if it wants to fly, this thing wants to fly. Professor Searl and his team said, let's give it a body so we can control it. And the obvious shape of the body is a saucer body. So that's the cover of the DVD, the John Searl story. Very soon, we hope to get that site back up and running and sell some more DVDs, and also direct downloads for anyone who wants to purchase and find out about this technology. Anyway, I got started back in the day, way back in the day, in the 1980s in electrogravitics, and I built Thomas Townsend Brown's saucers. He's the guy on the right. I built his flying saucers right from the patent. That's patent number 2949550. And I built them and flew them around a custom tower and rotor apparatus. And they worked even better than what was stated and what was claimed in the patent. So they're just a simple capacitor, parallel plate capacitor. And the whole idea with these things is to store as much charge as possible. You store the charge, that's what makes them go. Store the charge with as little leakage as possible. Now, let's see. Yeah, I've been lecturing for many years, since 1990. Nikola Tesla Club, Tesla Tesla Tech in first Colorado Springs, then Albuquerque, New Mexico. And I've been all over talking about Searl technology and how we want to get it funded and back up and running for good and all. And then I've been demonstrating anti-gravity electrogravitic systems, my own large beam ship models that are based on Thomas Townsend Brown's patent number 2949550, which was granted August 16th, 1960. And let's see. There's supposed to be a video there, but I don't think that the videos are going to be working on this presentation. They don't really work on SteamYard. I don't know why. And there's one of my 6-foot diameter beam ships, and they just take off and go with very low power, maybe only about 60 watts, maybe 40,000 volts at 1.5 milliamps. And and here I am in Albuquerque, New Mexico, back in 2010, when we were there lecturing with Professor Searl. And I built and presented along to support Professor Searl's lectures this 1-to-1 scale model of the Searl levity disk or inverse gravity vehicle, all out of polystyrene. And that's actual size of the P11 and P12 series craft that were flown from Warminster and stored in Archangel, Russia, because there was no place to house it for safety back in the United States. And there's some Searl inverse gravity vehicles flying around the Golden Gate Bridge in beautiful city of San Francisco. Yeah, and here I am with Professor Searl back in 2010 in Albuquerque, New Mexico. Sat down and talked with him for over 3 hours. That was my first face-to-face meeting with him. And he invited me on the team back in 2007. He said, "We like your work. We like your knowledge of our technology, of my technology. We'd like you on our team." So, of course, who was I to refuse? That was my dream made reality. And here I am at my old home base in Pennsylvania on the right-hand side with a C-57D Starship from the 1956 MGM movie Forbidden Planet. Forbidden Planet featured a spacecraft, a starship, faster than light, that looked exactly like, almost exactly like the Searl inverse gravity vehicle or levity disk. And Professor Searl is just an amazing man, amazing mind that is able to work on many levels simultaneously. And he would have a problem that would seemingly be intractable, and he'd go to sleep and wake up with the answer. It's just amazing. Lesage's theory of gravitation. Yeah, gravitation is just a converging flux of ether, or the background of space fabric, converging into the center of a body of mass and comes into the Earth. And when it gets near the Earth's surface, is right along the plumb line. Right along the plumb line to the center of the Earth is the vector we call gravitation. So all forces act in pairs. Gravitation is a push as well as a pull to the center of mass of a body, any body. And here we were in China back in 2013, a little over 10 and a half years ago, presenting Searl technology, our working mock-up, working demo unit. I'm sitting right behind it, and some of our Chinese helpers from our Chinese contingent, which we had. I don't think we have that anymore, unfortunately. But yeah, we demonstrated for the people of Beijing the Searl technology in working models. Yeah, and here are some photos of Professor Searl. Professor Searl is a young boy, upper right-hand corner. Albert Einstein, Nikola Tesla. Paul A. La Violette, I think, is there. Yep. Thomas Townsend Brown. And some photos of the levity disk. So the early team back in the 1960s, early 70s, working on various size models, both static and flying. There's a photo of a model flying over Warminster from the top and from the bottom. The top is always very bright when they're operating. They're very bright on top and like a dark mirror on the bottom, Professor Searl said, which is really interesting. It shows the conversion of ether or space fabric. And the field strength of ether is really off the charts. It's more energy than we can possibly imagine, something like 10 to the 97th grams per cubic centimeter equivalent mass energy. So basically 1 cup of vacuum has the field strength, and energy density to boil off all the Earth's oceans, which is quite staggering indeed. That's the magnitude of power that the Searl effect generator and the inverse gravity vehicle to control it in flight is converting. More than enough power to send this thing off. And Professor Searl said it would have no problem going up to the speed of light. But I'm thinking, since it has no inertia, no inertial mass at those voltages, which is about 10 to the 12, 10 to the 13 volts, the speed of light shouldn't be a problem, because the faster you go in these things, you don't get heavier. The device doesn't get heavier and heavier and heavier because inertial mass has been canceled. In fact, Dr. Gabriel Lippmann stated that inertial mass is not based on amount of material in a small space or in any space. It's just solely based on net charge, something no one expected and something we are not taught. And he later won the Nobel Prize for something completely unrelated. So if a body has a net negative charge, it's going to have less inertia. If a body has a net positive charge, it's going to have more inertia. And he called this the inertia of static electricity. And the SEG, the Searl effect generator, spintronic generator, is the first electrostatic generator which consists solely of permanent magnets. Now, the law of the squares is a mathematical system that Professor Searl, it came to him in a series of two oddly recurring dreams that happened twice a year from age 4.5 to age 10. The same two dreams that happened twice a year. Well, 2 squared, he learned later, is a very important number and very important concept in mathematics. Well, 2 squares 4. Well, these squares have 4 verticals, 4 horizontals, and 4 diagonals. If you have the numbers in these squares, these matrices, if you have them sequential, the outputs are all different. The sums of the verticals, horizontals, and diagonals are all different. But if you randomize the numbers, and I saw Professor Searl, I stood behind Professor Searl on stage and watched him do this right in front of me. If you randomize those numbers, the outputs are all uniform, 34, 34, 34, all the way around the verticals, horizontals, and diagonals. So that is basically a graphical representation of the coherence, of the cohering, the way nature does, of the random energy of the ether. And the history of magic or Latin squares dates back thousands of years to the pyramids of ancient Egypt, possibly further back to the first Chinese dynasties, which is in fact true. In fact, the Chinese people, as I found out when we went to China a little over 10.5 years ago, they still use magic squares for cutting and trimming bonsai trees to the correct mathematical ratios of the nature of nature. By understanding these natural laws, one can argue that the universe exists according to precise mathematical laws. The law of the squares, or magic squares, is not a new technology, but an old, ancient technology that's been reborn after Professor Searl, at a young age, developed it independently and discovered his numbered matrix has 3 dimensions, 3-dimensional properties that can model the quantum energy states of mass. And there are 3 groups of squares. Group 1, 2, and 3, and there can be no others. Group 1 squares consist of all odd numbers. All even numbers that are divisible by 4 are in group 2. All the rest of the even numbers not divisible by 4 are in group 3. And we use group 2 square for the to make the generators. And basically, group 1 oscillates, group 2 square rotates, and number 3 square oscillates except for the center cross, which rotates. Now, here are some more representations of what we see in this device and similar devices in its class. So group 1 squares oscillating, or rotating rather. Group 2 is oscillating, and group 3 rotating and oscillating. It oscillates except for the center cross, which rotates. And then the law of the squares tells us, and we have tables, complete tables, on how much material of each material tells us how much material and the ratios of those materials in whatever space you want to fill with SEG, or spintronic generator. Yeah, it's a complete numerical system that is almost like, it's a computer. It's a computer without the hardware. It's really, really interesting the way that goes together. And so we have tables of data for whatever size generator we want to build so we can build it correctly. And we're going to be building you have to have at least 4 chemical elements, which includes an insulator of some thermoplastic material. The insulator keeps a charge from building up and then dissipating, and building up and dissipating. And what goes through the generator, the current that goes through the generator, no matter what the voltage is, the current never exceeds 1.5 milliamperes. And the current is not normal fermion current, it's boson current. A boson current just consists of 2 electrons or an electron pair, a Cooper pair, or electrons they get to a certain distance, a very close distance, they're not allowed to bump around and create heat. They simply spiral around each other, and they follow the lines of magnetic force to the surface of the plates and runners, and they gain energy with each stage or each incremental distance through the materials until a certain point they're leaving the materials at high energy. They're leaving the materials and the rim of the generator in radial fashion at almost the speed of light, relativistic speeds. So notice here on the left-hand side square, you have the numbers sequential. You get all different outputs for the verticals, horizontals, and diagonals. But when you randomize those numbers, as I watched Professor Searl do, those numbers all come out uniform, 34, 34, 34 for the verticals, horizontals, and diagonals. And the law of the squares is based on supersymmetry. And like light, magnetism is broken down into its spectrum components, then utilized to generate a resonant magnetic wave. A resonant magnetic wave. That's kind of important. Let me go on ahead. What happens when you bring a runner to a plate is that composite moving magnetic waveform is generated like a sine wave. But it's more than that. It's almost like an Archimedes water screw. So look at the bottom right. You see you have a sine wave and a cosine waveform. And the sine wave is on the plate. The cosine wave is on the runner. So notice at the center line at the block walls of each plate and runner where there is no magnetic field, where north converts into south and vice versa, those fields, those vectors are at right angles. You have to have that or it won't work. So that's very important. And those magnetic waves consist of magnetic bubbles called maxills that are most powerful near the edges and least powerful and smaller near the center of each plate and runner, or each ring and roller. The plates are the stator. The rollers are a rotor, a segmented rotor. You could think of it like that. And nominal voltage this thing puts out is about 100,000 volts. Again, at 1.5 milliamps. And that is way more voltage than anyone expected. Of course, with no load on it, well, actually, it pours out a load into a corona surrounding it, and the higher the voltage, the less air pressure is around this whole system. And if unrestrained, it will continue to pour out power into a corona surrounding the device, and the voltage just goes to insane levels. Current still stays at 1.5 milliamps, and it just takes off. The combined field from the earth and the device just pushes it away. Obviously, the earth can't move out of the way, so the device moves out of the way. And because of this field, a highly negative field at the rim and highly positive at the center, the device is basically repelled by the rim from the earth. So the center is positive. So all electrons from the environment or from space itself, from the vacuum itself, think of the vacuum as pre-electrons, all that goes into the center ring, the centermost area of the center ring, because that's the most positive, and electrons being negative tend to seek out the most positive source in the area. So it takes the device takes one electron from the neodymium or whatever rare earth you're using in the matrix, and one electron from the environment, and those link up to become a Cooper pair and are utilized by the device. Well, what is the Searl effect? The Searl effect is based on a unique process of magnetization. Oh, are you driving in? Oh, okay. Can we do a switch later?
What?
So I can get something to eat, because I wanted to go to the store to get something to eat.
All right.
All right, thanks. Yeah, it's my grandson. But anyway, sorry, I'll get back to the program. The Searl effect is based on a unique process of magnetization where specific waveforms are imprinted onto the materials. The materials are magnetized in a way that is not practiced in today's industry, nor is John Searl's method taught in conventional electronic engineering schools. When those materials are in motion, the waveforms begin to interact and produce electricity. In addition to producing electricity, the SEG gets very, very cold and generates a negative charge within its vicinity. So the more load you put on it, the faster this thing runs and the colder and lighter it gets. And the less atmospheric pressure there is in the device, until it's riding in a vacuum, sitting in its own self-made vacuum. Higher the voltage, the stronger the vacuum. And studies show that negative charges kill bacteria and viruses and also make wounds heal much faster. That's also been shown. You can see those videos on YouTube where electricity heals wounds much, much faster. So one of these generators needs to be in every hospital burn ward and operating theater, because it's like a negative ion generator on steroids, basically. Professor Searl was in an explosion, lab explosion, and the whole right side of his face was badly burned. But because he was asked to be taken home because they had dressed him up like a mummy, within days, a couple of days, everything was almost completely healed. First, the pain goes away, and then rapid healing takes place. So there's no time to form scar tissue. Scar tissue occurs with slow healing and infections. But this device, it's like a negative ion generator on steroids, kills bacteria, cleans the air as it runs. So it needs to be in every home for a healthy environment. And you can run anything on it, depending on your peripheral coil windings, which are pickup coils. You can power anything you want at any voltage you want. And you're just generating electricity in the normal way by cutting lines of magnetic force at right angles to a conductor. But in this case, you have cold current, boson pairs, Cooper pairs, like two figure skaters that have locked arms together and spinning around each other rapidly. That's the type of power we're dealing with. And it's negative power in this device. Not our positive AC power. Our AC is positive polarity. And stop. It's my cat. Positive polarity. This is negative polarity. So it makes a healthy environment, and devices and systems don't lose electrons over time. They with this system. So everything is going to last a lot longer. And this is a layered version, which was never built. A layered version of the system. The systems that were built were homogeneous systems. In other words, mixed together with turbulent flow in an argon environment, argon gas environment. You have to do everything with in an argon environment because we're pressing powders to make these devices. When you press powders that are that small, or you're using powders that are that small, especially rare earths, they oxidize very, very rapidly. And you don't want any oxygen to get to these things before you press them, sinter them, magnetize them, and then coat them with a very light layer of a nickel plating or something similar to preclude oxidation of these plates and runners. And there's the sine wave on the plate, cosine on the runner. When you bring a runner to a plate, you make a combined field, a composite field, which is a rotating field, which consists of this sine wave that really, if you're looking at it in 3 dimensions instead of 2, looks like an Archimedes water screw, a combined rotating wave, and the runners are just carried along in the troughs of that rotating wave. It's pretty simple when you think about it. And toroidal fields in nature, they're found all over nature. Toroid is like a donut, but a spinning donut, also a vortex. So think of the toroid going around the device. It consists of basically 3 or 4 rotating fields, a rotating electrical field, which is an electrostatic field, negative at the periphery, positive at the very center, a rotating magnetic field, which is a dynamagnetic field, a magnetostatic field, and another electrical field, which is a moving electrical field, which generates very, very little current, only about 1.5 milliamps. So that is not enough current to deflect a compass needle. So because of the high voltages in this system, you want to have optical controls in this system. Basically, instead of electrical, everything running on electricity, you want light signals, although you can run it on electricity if you want. But you get better fail-safes with light-activated systems like fiber optics. Yeah, there you see toroids all over nature. I'm a musician, so I know the treble clef and the bass clef, which is the G clef and the F clef. They follow that same pattern of spiral nature, which is everything. Victor Schauberger's repulsine device depends on the same things the Searl effect depends on. The way nature operates, implosion and falling temperature, not explosion and heat energy. Nature doesn't work like that. So the Searl system is consistent and congruent with the laws of nature, and so is not destructive. Nothing is being broken apart. No atoms are being broken apart. No molecules are being broken apart. Instead, we have integration at the hubs, at the center, and you could call it disintegration or elimination of electrons high speed from the rim. It's really interesting, and we see this all over in nature. The Fibonacci spiral of increasing curvature, that's the way electrons from the environment come into the center of the device and link up with a free electron, and neodymium or any other rare earth. There's plenty, well, actually 2, which is more than enough, free electrons on its outer 4F and 5F band shells. And those electrons are highly mobile and ready to go. They're ready to power our society and whatever else we want. So you see these vortexes and vortices all over in nature, tornado about to form, whirlpool, hurricane, and of course a spiral galaxy, not unlike billions and trillions of galaxies that are out there, like our Milky Way galaxy that we reside in. And you have an interesting vortexian pattern is seen all over nature, even our fingerprint, call it the fingerprint of God, our DNA, a double helix, and a light wave. Matter, energy, and that's a photon. That's a model of a photon. A photon can be thought of as a smeared particle. It's a wave as well as a particle, a wavicle. And that's Searl gyrocell. We call it a gyrocell in its basic form. A single plate, which is a ring, and 12 runners. All you need is one runner and one plate to demonstrate the effect. And the runners in the actual device, the runners don't touch the plate at all. They do in the demo device, but in the actual device, there is a Hall effect because of the magnetic fields and the materials that are used in it. So the runners fly around the plate. They orbit and rotate around the plate. And all you need is one runner and one plate. And that's in our project plan. The first milestone is one runner going around the plate. That is it. So it's the first electrostatic generator that consists solely of permanent magnets in the form of cylindrical bars and annular rings. And in the flying unit, you have 3 sets of these, 3 concentric sets of plates and runners, or rings and rollers. And there's a proposed layered version, which Professor Searl said would be a little more difficult to build, but it might work even better than the homogeneous mixture version. And I saw a video, I have a video of Professor Searl experimenting with those magnets in 1980s and early 90s. I got a VHS tape bought from our late team member, John Thomas, which was a 4-hour Searl lecture from, I guess, Munich, Germany, 1989. And at that lecture, he received from Munich University an honorary doctorate in, I think it was mathematical structures and engineering. So the collector is the neodymium element layer, collector of electrons and source of electrons, just like a reservoir is a source of water for a town or a municipality. The neodymium is a reservoir of electrons, and nature replaces those electrons readily. So an endless source of electrons is in any rare earth, and we use neodymium number 60 on the periodic table. Then we have a gate, a dielectric layer of a thermoplastic material, and Professor Searl was using nylon 6,6. And then notice that all the elements that are used in this device are very, very highly negatively charged on the triboelectric series of elements. And nylon 66 certainly has a negative charge. And we can also make this nylon electret material, and we can do the same thing in the homogeneous mixture version. Basically, we have nylon pellets and we melt them, bring them to Curie point, and then we zap them with a negatively charged Van de Graaff. Well, most Van de Graaffs are positively charged unless we feed in electrons from a high voltage source onto the belt. So that's what we'll do, is spray electrons onto the belt, and then negative charges are fed into the thermoplastic material. When it cools, it maintains that charge and becomes an electrical dipole, and it's the electrical equivalent of a permanent magnet. So instead of a magnet, it's an electret. Electrets are very, very important in free energy work. And then you have an accelerator of a magnetized iron layer, and the magnetics are only on the surface of the plates and runners. And then you have an emitter of copper or aluminum, and you have to have a paramagnetic layer or paramagnetic element in the matrix, and that's very important. And there's our mock-up, which I have here down in Florida, running. Runs pretty well, extremely well. It's very, very simple. You just put a voltage about 6 volts over the runners and the plate, and off they go. 6 volts at 500 milliamps to get those heavy magnets moving. And the Barrett report shows if you put probes on the center of a plate and the periphery of a plate, or the center of a runner, periphery of a runner, you can register anywhere from 5 to 12 volts. So these plates and runners are, think of them as spin batteries. They're permanent batteries. And then when you spin the runners, the effect of that voltage is enhanced markedly, but the current never exceeds 1.5 milliamperes. But the voltages can go to insane levels. And there's a proposed model of a layered version. See, the nominal spintronic generator or Searl effect generator consists of 3 concentric plates or rings and 3 concentric runners. The innermost plate has to have at least 12 runners if you want to generate power. That's very important. Running in the lab. Yeah, a field of ions is generated that spreads outward, as well as reduced atmospheric pressure. The higher the voltage, the less the pressure. The air is just pushed away from the rim. At higher voltage, everything is pushed away. It goes cryogenic, and the earth pushes the device away. Anything that approaches the rim at those insane voltages, takeoff voltage, which is about 4 Kelvin at some 10 to the 12 volts at 1.5 milliamps, anything that approaches the rim is pushed away. Anything that's less than the mass of the device, the combined mass of the device, is pushed away from the rim, turned away from the rim. First it's attracted, then violently repelled, becomes physically impossible to bring anything near the rim. That's what we call a force field. And anything greater than the mass of the device is repelled. So this thing, if it's going in deep space at relativistic velocities or above the speed of light, it can't hit anything, micrometeoroids and even cosmic rays. Well, cosmic rays would be sucked in to the center of the device if they're a negative polarity and used by the device. And anything else is just pushed away by the positive or negative polarity of the rim. And that's what the magnetic fields should look like. On the plates and runners, they should look like wagon wheel spokes. They're basically gears, helical magnetic gears. They're not straight up and down. They have a helical cut. And there's all kinds of advantages to helical cut gears. Out of magnetic fields. That's very important because this thing is a magnetic bearing. It's on a magnetic bearing, and it is basically a magnetic motor in rotary form, a magnetic induction motor. And 10 years ago, down here in Florida, in Fort Lauderdale, actually Oakland Park, which is the next town over from Fort Lauderdale, we built small models, working models with neodymium magnets of linear and then rotary motors, magnetic motors that worked. They're based on the Paradigm motor and another motor, which escapes me right now, the V-gate motor. They were based on that, and they worked really great. They worked extremely well. So we'll be using some prototypes, making some prototypes on the V-gate magnetic waveform, as well as the traditional Searl effect magnetic waveform. That has milestones, and so we can hit the ground running when we get funding, and we're seeking funding. Anybody out there, sending out a call to all who are qualified investors who have the wherewithal to support this work, please seek us out. We need your help so we can duplicate this work here in Florida and replicate the work that was done back in the day, 30, 40, 50, 50 years ago in England, 60 years ago, and longer, 70 years ago in the early 50s. And here's a glass SEG operational prototype in 1989, consisting of regular, ordinary ferrite magnets, not law of the squares magnets, just ordinary ferrite magnets, just to show that you can get continuous rotation. And it has cams and levers in the center that once you set this thing in motion, it will just keep on going. Professor Searl built that in Germany back in 1989. And here's basically what's happening with this system. You have time-varying magnetic fields, but they violate Lenz's law. When you get a change in the magnetic field, there's no magnetic torque trying to slow the system down and heat it up. That's total violation of Lenz's law. That's important. No other generator has this geometry. That's in violation of Lenz's law and other cherished physical laws. Like, of course, in the flying version, Newton's third and first laws of motion, and the conservation of energy law is clearly broken in this system. And there's Hamel's device, Hameltech, creates electrostatics just like in a thunderstorm with air rushing down through these cones that are in opposing magnets, opposing magnetic systems. There's Hamel's flying saucer, Hameltech. Look at the book, The Granite Man and the Butterfly, for information on Hameltech. It's another working flying disc model. There's some alien technology that utilizes two inner tubes of ferrofluids to generate insane voltages for flight. This device, this craft, is also a flying electrostatic generator. Notice the separation between the upper hull and lower hull. The flight means are basically very similar, if not identical, to Thomas Townsend Brown's flight means and Professor John Searl's flight means. Laws of nature, as far as we know, work the same all over the universe. And there's some more alien craft taken in front of a hill somewhere in Switzerland. It's a drone craft, maybe 5 meters, and then a 7-meter man craft on top. Now, there's a depiction of the craft, of the flying craft known as a levity disc first back in the day, and now known as an inverse gravity vehicle, because we are now certain that gravity is reversed in this device. They put the device, basically, when it's in flight, can do insane flips and reversals of direction, instant starts and stops, at many times the speed of sound with no sonic boom, of course. Basically, and again, just like Gabriel Lippmann discovered, inertia is canceled by high energy electrostatics. So the device has no inertia. It runs cryogenic, it runs cold. There's no consumption of oxygen. There's no heat energy. There's no vibration. There's no noise. It's a perfect flying system. There's no limit to the speed as far as we know. And you can see an enlarged Searl effect generator inside the framework of the levity disc or inverse gravity vehicle, enlarged for clarity. And the shells, just like the Demo 1, the 20-footer, which is the last model built, are clear. So you can see the inner workings. And then you have 64 flight cells at the rim adjacent to the generator with a load cell, which is basically a pin, a very sharp needle or a pin that puts a load on the atmosphere to put the device into a superconductive state for flight. This is a superconducting, high temperature superconducting device, about 4 Kelvin, 256 degrees below zero at flight voltage. And because of the high energy electrostatics, this device polarizes the ether, polarizes the vacuum. So you have ahead of the device a positive polarity field. Well, positive polarities are attractive on matter. And just under the device and behind the device, a negative polarity field. Negative polarity fields are repulsive on matter. So you have basically a wave in space. And this device is a wave rider that rides this wave of electrically modified space-time. The ether is not a physical thing. We can only get it electrically, according to Sir Oliver Lodge. And there's the P-11 flying in Warminster, England. It's about maybe 30 feet up in the air. No noise, no fuel, no heat, no vibration. This is the system we should have been using to get into space since the early 60s. Not the German rockets, which were basically borrowed from Robert Goddard's liquid fuel rocket patents. The Saturn V is basically a glorified V2 rocket. But this device does not produce deafening noise or any noise. This device does not use any fuel. This device utilizes the ferromagnetic spins and electron spins at the heart of matter, basically, to create safely a very, very high voltage field, negative at the periphery, positive at the center or hub. And off it goes with no inertia. Pilots, when they used to see these things, Professor invited pilots to come see these things fly at the Sunday afternoon flight demos in Warminster. And the pilots would say, no way am I getting that thing, I'd be squashed. But they put a small vial of some radioactive material that was so fragile that it would break with the slightest load. When they took it up and whipped it around, did all its maneuvers and brought it back down, the vial was still intact. They put accelerometers inside, and they found that in the center of the device where the flight deck is, there's 1/2 G onboard gravitation. 1/2 G onboard gravitation. So again, this device is electromagnetically creating artificial gravity. So there's your unifying field in Einstein's completed unified field theory for gravitation and electricities, or an Einheit-Lichtenfeld theory, which was published January 29th in Annalen der Physik, a Prussian science journal, in High German, and then published January 12th, 1929, republished in the New York Times with great fanfare. And gravitation and electromagnetism are utilized and put into the same equation, put into a unifying equation. And yet that is not taught in our schools. I wonder why. And there I am, putting finishing touches on a model that is a 1/1 scale model, the P-11. Now the P-11 weighed 4.5 tons, 4.5 tons. And most of that weight was in the generator. The generator those magnets are extremely heavy. And it's a very large generator, about 8 or 9 feet in diameter. And 64 struts make up the structure of the craft, and 64 flight cells for control. You're controlling the device from outside. There I am again. There's Professor Searl, 1932. Well, he died December 4th of, December 4th of 2018. The patent for the spintronic generator came out January 16th. It was published by the USPTO January 16th of 2018. So Professor Searl got to live to see his patent realized. So, and our company Spintronics Inc. owns that patent, and no one has challenged that patent. So we're free to go. Any investors that invest in Spintronics so we can make these devices, both the generators and the flying devices, is protected. Yep, there it is, about maybe 25, 30 feet up in the air in that same field in Warminster, which you can go to, P-11 craft. That was, I believe, July 4th of 1969. And there's a P-11 size craft. I believe that is a P-11, about 10, 11 foot diameter with a radio controlled walkway. And they were controlled on 12-meter band ham radio. And they were controlled at various ground stations, people that had ham radio that were part of the team with a special code with a 12-meter band military surplus ham radio. That was the only frequency that could get through the force field. There's the stairway. The stairway comes down from the center, and so the passengers won't accidentally touch the hull, because the hull is a capacitor. You touch that hull at that voltage, you're dead. You do not want to touch that. And the legs are like kneeling, hydraulically powered kneeling landing legs, because you don't want it too close to the earth, because if you switch on the drive suddenly, it'll take up a chunk of sod that will basically stick to the bottom center of the craft. Remember, high energy electrostatics is identical to a gravitational field. Yeah, these were actual flying craft. And there it is, ready to fly with the kneeling legs extended, so you don't take up a chunk of sod upon lifting off suddenly. There's the Demo 1 21-footer, 7-meter craft, which was the final one built. That was the last one built. The ring at the outside is where the generator goes, the SEG Searl effect generator or spintronic generator, as is now patented. And 64 flight cells, 64 struts, 64 flight cells in between each strut. And this was built on land of the late Alfred Fleetwood in Berkshire, England. And there it is, looking from the bottom. And this was very, very heavy as well, but it was made deliberately out of the softest material available, ordinary plywood. And that was to silence detractors, among them many scientists who said such a device would never support its own structure, support its own weight, but it did. It's a split beam construction. It's called a split beam construction. And there's a flight cell made of wood being installed, and it was completed. And I believe this was flown from Berkshire. Clear shells on the periphery on either side to show that there was no trickery involved, and each surface, upper and lower, are electrically isolated, so you can change the polarity. And there's, let's see, Professor Searl, Gordon Goodfellow, and William T. Sherwood with his wife Rhoda. William T. Sherwood was on hand and for the video that was taken of the Adamski type craft in Silver Springs, Maryland in 1965. It's called the Rotifer UFO. Very important video. Well, it was taken with Super 8 film at that point. You can find that on YouTube. Building the Demo 1 craft. That was the last craft built in 1972-73. And there's Demo 1 about, I guess about a half a mile up, being photographed by the P-12. So P-11 being photographed by the P-12 in flight. Notice how small the land and the trees are in the distance. That's in flight. So 12-ton device up in the air like it's weighing nothing at all. And some graphics that our team did a while ago, back in 2010. And as inverse gravity rim detail, you have the thrust cell, cold flame barrier at the rim. Here's the SEG, and the flight cells for control are at the periphery of the SEG. They fire a hard rubber pin at the roller just passing, and just like touching a gyro, that portion of the craft is forced to drop at a certain angle. And if that angle is maintained, the craft flies off rapidly in that direction. And there's a closer view of the inner workings of this flight control system. It's very low tech. There's comb-shaped electrodes for capturing electricity and a switch for turning it off or on to send energy out to electrical energy out to the rim needle or discharge pin. It's a flight cell. They have four flight cells, 4 flight cell modes: flight cell open, flight cell closed, flight cell open and locked, flight cell closed and locked for your control. And there's the Searl effect generator. and you have 4 switches that control where you want the electricity to go. This is an electrogravitic craft, and of course my expertise is in electrogravitics. This is right up my alley. And there's a proposed maybe 30-foot manned fighter craft. Very pleasing to the eye craft, almost like a diatom, like a microscopic organism. Yeah, that's a SEG inside enlarged for clarity. The team back in the day. Try to go a little faster. Flying in Warminster, England in July 4th, 1969, the press did reams of flight footage and coverage every week. BBC One came out, Southern Television, Anglia also. Since the early 1990s, BBC One wanted all kinds of crazy money for the flight footage. And then by the early 2000s, they wouldn't even admit that any footage was taken, which insults a lot of people that are my age, early 60s, that remember the BBC shows. William T. Sherwood, who's a Facebook friend, remembers the flight footage and the BBC One TV shows on the work. So you can't fool people. So no noise, no pollution, no heat, no vibration, no consumption of Earth's oxygen, no need to carry fuel, no runways, no launch pads. We are the tomorrow people, and that's all of you. The decision makers, tomorrow's transportation today. Well, it should have been yesterday's transportation, but can't hold off these discoveries forever. Now is the time. This is Professor Searl's time now. And you can see the action of the flight cells in controlling the angle of flight. And I have in my presentation a series of 6 slides of the craft flying over Warminster, the same field in Warminster, and the action of the flight cells in controlling the craft to maintain a stable hover. All kinds of newspaper coverage, TV coverage. Yet in this country, in America, nobody knows about it. But a lot of people know about it in England and Europe and across Asia. But in this country, there was some kind of news blackout on the device. Yep, day trips to the moon. Why not? The control mechanism. And those should be repeating slides. But for some reason in SteamYard, they don't repeat. Yeah. Team back in the day. Very interesting. And there's the toroidal field, the aforementioned toroidal field, very important. This is consistent with nature. You have a toroidal field because of the electromagnetic polarity of the generator. The device, the generator was not supposed to fly. It was just supposed to be a unique kind of electrical generator. But off it goes. Yeah, the man who saved tomorrow, Professor John Roy Robert Searl. Before the Searl device powers our world, and then after. Nice clean water to drink and clean air to breathe. This device cleans the air as it flies. If you have one running in your home, it cleans the air in your home. Much healthier environment. Flying hotel you could have. Yeah. Plywood starships. Yep. C-57D copies the profile, but we don't want to have a dome above or below because it would be outside of the vacuum envelope. The device in flight is in its own self-generated vacuum, don't forget. Yep. Flight devices, SEG at the bottom, Searl effect generator at the bottom, spintronic generator. Yep. They were building them in Hollywood. And that's supposed to be a film that's on my presentations. If you go to Tesla Tech on YouTube, you can see that film also. Yeah, The Gift to Mankind. That was it. And I don't know if we have time to take a look at the spintronic slides. What do you think?
We probably don't, Russell. We might be able to come back to those. I mean, we could come back to those absolutely like next month if you want, or we might be able to do them like in open discussion time later. But
yeah, whatever works.
I might have to drag you back in here next month. But
okay.
Well,
Yeah.
so if this was your, so the thing that I should offer to the audience, again, we have a lot of new folks. The Searl effect generator is incredibly difficult to build, and Isaiah Ritchey will be talking about that next. This is one of the, like, I don't know, the cornerstone. ideas, archetypes
Yeah,
in,
well, it's
in
not difficult to
anti-gravity.
build. It's not difficult to build if you know how. And we have pressed plates and runners down here in Fort Lauderdale, Florida, based on, well, the exact design. And of course, the plates weren't sintered, so they fell apart. But we have runners, we have plates, and we have all this equipment in storage down in Fort Lauderdale area, waiting for when we get funding to
Okay.
go into a lab. So we're chomping at the bit. We just need people to step up to the plate and fund us.
Yeah. Yeah.
We have a
Well,
budget. We have a budget. We have a project plan for which is our roadmap for success, and we're ready to go.
Yeah, no, it's super exciting. It's super exciting. I'm so pleased that you were able to discuss this. Again, there aren't many people who have this knowledge or expertise on the Searl effect anymore, and you are one of the very few people out there. And I mean, this has so much cultural significance in terms of anti-gravity stuff. So it's wonderful to be able to kind of show this to the audience and help them understand.
Yeah, well, I'm glad I could come on your show. Thank you so much
Oh
for
yeah.
inviting
Well,
me on and sharing this knowledge and this
let me do
technique.
that. I want to. So I'm going to bring. Let me bring the guys on real quick. Let's put our hands together and give Mr. Russell Anderson a giant applause.
Wunderbar.
Russell, thank you so much. It was absolutely wonderful having you on. You ran through a tremendous amount of stuff. It is worth mentioning there have been several replications that have been completed for this. None of them followed the instructions. They all made significant differences, but they all showed anomalous results. And I think that that's important to point
The
out.
Roshan and Godin Morningstar device,
Yeah,
definitely.
Yep.
Yeah,
And
the weight
Roshan
loss,
Godin
the
had
magnetic wall.
self-spin,
Yep.
Morningstar had weight loss, and all of them changed Searl's original design, and they did that for construction reasons, right? They just weren't able to do it. So I have Isaiah Ritchey here. So let me do this, Russell. Let me take everybody out except for Isaiah, and we will go to him next. Again, Russell, thank you so much. I think I'm going to have Russell back to run through the Spintronics stuff as well. Isaiah, thank you, man. Thank you. So you are actually a Searl builder, and you have tremendous expertise. So you have a presentation for us. I don't think it's uploaded. I can upload it if you want.
Yeah, let me get it.
If you click the present button, the only
There it
difference is let me see. Oh, there it is. Add to stage. Yeah, there we go.
Cool.
Okay. And
Excellent.
yeah. Yeah, well, I would say, we're a couple minutes ahead, but I would say if you want to take it away, go for it. And thank you so
Absolutely.
much. I should just mention, I've known Russell for like 25 years now. I just met you last year, but I have been absolutely blown away by the level of knowledge and attention to detail and expertise when it comes to the Searl effect. I mean, these are not easy devices to build. And one of the things that makes your work unique is you were actually following the instructions, right? Like so many
Yeah.
other people have cheated when they tried to build these, and they're like, it doesn't do what it's supposed to. Well, yeah, you didn't actually build an SEG. So
Thank you very much. Hey everybody. So my name is Isaiah Ritchey. I'm 43 years old, and so just a few things about myself. I was born in the Willamette Valley of Oregon. I graduated high school with an GED and immediately became an apprentice with a general contractor. I'm married to the most loving and supportive woman ever. And right now I'm just a general contractor in the Willamette Valley of Oregon, working all over the place. So let's see. My early teenage years, became interested in topics of free energy, anti-gravity, all that genre of things. I followed a lot of Jean Louis Naughton's websites, did some experiments myself, and when I was 14, I helped to build a Tesla coil with the assistance of a friend, and worked with a few other magnetic devices. I had a lot of interest at that time in the topic, free energy, that kind of thing. Eventually, in my teenage years, I just gave up on the whole thing. But when I was in my late 20s, I started having like a urging in my spirit to just get back into venting, which I believe was God pushing me to do this. And So one morning in January of 2008, I had a dream showing me of these interlinking arms of energy and stuff. And I had no idea what was going on in the world with free energy and all sorts of things, because I just hadn't paid attention to it for a long time. So I got back online and started looking around and immediately found a device I thought looked fairly simple to build, even if it was going to be a model. And that was John Searl. He had made basically a reemergence back in 2007. I was fascinated with the project and how it worked, how it was just, everything was all held together magnetically. It just had this wonderful harmony to it. It wasn't real mechanical, parts didn't wear out. It just had like a symmetry and a harmony to it, which I was very fascinated by. So within a few months, I just started looking into it with the information I could find online and building a very basic device, trying to do something like you see on the images here. And lo and behold, I found some images that looked exactly like the dream I had seen of the energy field. So what began in 2008, making tons and tons of mistakes and lots of successes, has now become and matured into my life's work. So I'll go forward on this. Next slide. So the Searl effect generator, it basically is composed of 4 layers, in which the rollers also have the same type of layers. You have a center layer being a rare earth element, neodymium, and then an insulator, dielectric, which I'm using Teflon, and then John used it too, and then the magnetic layer, and then copper. Each one of these layers, I've learned, needs to be the exact same weight, within 1/10 of a gram each, and a scale just right to meet the circumference of the rollers. I've done all the math to figure out what those ratios are, right down to 1/10 of a gram. Using the law of the squares, determines the weight of the rollers for each layer. And the math, if you understand it right, is fairly simple. Each layer, the neodymium all the way up to the copper, gets a specific weight, and each weight needs to be within 1/10 of a gram accuracy. I've learned how to do that, and it takes time and effort, but you do hundreds and hundreds and hundreds of these parts. You learn what not to do and what to do to get that gram rating right. So next slide. So here's images I found online. The law of squares represents quantities of each material. Like in this slide, it shows the inner core being 4, and then the magnetic layer being 10, and the, let's see, that one's incorrect. The neodymium's 13, and Teflon layer's 4, and the, oh, is it Teflon layer's 4? It's so small here. And then the copper layer is 10. And I comprise this image below showing the magnetic gearing. So in my system, I haven't gotten to the point yet where I'm doing the AC DC magnetizing yet. I've done a few experiments with DC magnetizing and had some interesting results with that. Bending the magnetic waves in the roller rings, and it's been fairly interesting. But with a design I'm going, which is similar to Roshan and Godin, with one of the experiments I'm doing is using many sprockets inside the rollers and the stator segment rings. So that's what this lower diagram shows, is sprockets in the rollers. Here's a picture of the sprockets connecting to each other with north on the top, south on the bottom. Now the roller has basically 2 fields on it, one going north on top, south on bottom, or flipped around. And then you have perpendicular fields, thus the sprockets that I've been putting into the roller segments. So you have fields going this way and fields going this way, perpendicular magnetic fields. This is an image I found because I had a dream. John Searl explained that it's a magnetic matrix to me. So I just want to show this, and it's something to do with the magnetizing is like this. Here back in 2008, I was machining the Teflon part for the rollers. And this is my first roller. I used nylon at this point for the insulator set of Teflon. And then ceramic magnets for that magnetic layer, and then obviously copper. And here I was just testing out the very first electromagnets to pulse, basically a demo unit. Here I was testing the eddy currents on the stator copper band, and it worked fairly well, even on just a standard roller magnet with standard magnets inside. Nothing fancy yet at that point. Here's some of I made up to 12 of these rollers. They're just standard magnets. Nothing back then. There was nothing different about them. Just run the mill. The ceramic magnets I ground myself with the lathe and the grinder to get the circumference right. This is my first unit back in 2009 I made. And the only thing interesting I found about this unit, even though it's just normal magnets, one side, typically the bottom side, would be a little bit warmer, and the top side will always be cooler. And I held this to many people. I'd even let it stand up on end when it was not rotating, and people would hold it, and definitely you had one side was warmer than the other consistently. It was kind of odd, and I never measured, unfortunately, but I let lots of people handle it, and they'd always say the same thing: is one side was warmer than the other. Here's one of the electromagnets, the very first versions. This was a micro version I made in 2014. I just did it because I wanted to emulate Tony Stark's arc reactor. Some of the weights were right, and others for the rollers obviously were not. I just matched the weights for the main stator unit. Now, this was when I first started changing the field on magnets, and you'll see the bare neodymium magnets on the stator there above, the above image. Those were magnetic rings you could get off of eBay or Amazon. So I got them because they were cheap to experiment with. And then this lower image is some forms that I used to impress magnetic fields onto these, and thereby shaping and changing the shape of the field within the magnetic ring while keeping it magnetized. And it did present waves, and it looked like almost whiffs of smoke when I would rotate it. And I think I showed the device. Oh yeah, this little green gizmo here would rotate it at about 1 RPM. And with the film on top of it, you could see that it did indeed change, create a flux line on the magnetic field. And this above steel and copper is the device the magnet ring was inside of. And I sent it to a buddy down in California, Russ Grease, and he did all the magnetizing for me, and we did about 20 different examples, and each one had some interesting results in it. And so that's just a slide of the magnetic viewing film over the ring as it rotated. And so you can vaguely see a squiggle in there. Some had a real sharp line, others were completely flat, depending on the voltage we used. Here's one of the stator units I still have today, and that was being machined out on my lathe. And that's the magnetic layer that I machined down to get the weights all matching right within 1 gram on these. So this is not the final weight, but getting close to the final weight on the stator unit, the copper band. So it's one of the scales I have, one of 4, to get the weight down to within 1/10 of a gram accuracy. So you use 800 grit, 1500 grit, and 3000 grit, and then a nice polish to just work on it and work on it and work on it until you finally got that exact weight just right. So here's one of the rings being worked on, getting the copper to be 7 grams, 7.000, and it just takes time and effort, but it is doable. I've gone to the route of getting it manufactured in China, and they can get them pretty close, but to fine tune them just like a tuning fork, you need to stick it on a machine of your own and just do all the fine tuning myself. So that's what I'll be up to soon. This is some of the circumference values I was putting together back in 2017 and one of the finished stators. That version I still have, I just don't use it. The inner core, the weight was done wrong. When I finally machined it, realized one of the calcs was wrong. So a lot of machining experience, but otherwise it really became nothing. So in 2018, one of the first segments for the rollers was done. Now on this one, I was experimenting with nickel 200, and then Teflon, and then a magnetic layer, and then the copper. The next is the finished, I think it's the version 4 and of the stator SEG unit. This one's finished, so all the weights are within 1 gram of each other. Now this is a nickel core, and then solid Teflon, magnetic layer, and then copper. And this has no special magnetizing. This was just put together to be testing motor ability. Here's when I started conceptualizing putting perpendicular fields, watching more of Searl's videos and understanding kind of what he was talking about without the special magnetizing equipment. I just haven't got that knowledge yet at that point. I'm still working on it right now. But my idea was to put perpendicular magnetic fields along with having a north and south through a ring magnet on for one of the rollers, but also having what I was going for at that time and still would like to do it is 34 points of magnetism around each ring. And then, you get 8 rings total, makes one roller. Here in 2021, I finished assembling all of the 12 rollers with all the parts they need. And the magnets came pre-assembled from China, so I didn't need to work on those, but I was just putting this together to basically test the motor function, not the actual Searl effect in this, because there's no special magnetizing on these. Image below is a custom-built capacitor bank, and the top is a pull-out drawer with the 10,000 volt, 10,000 amp capacitors, and I used for some small experimenting with magnetizing, which had some interesting results. And that's in the shop here now with me. So this, I began with Jared's help, Jared Yates, and designing magnetizing coils, and we were just basically just playing around with designs and figuring out what to do, what not to do, because I've looked and looked, and maybe there are books out there, but I've never come across one that really describes how to build a decent magnetizing coil. There's plenty of companies that can do it out there, but I was looking for something very unique and couldn't find anything what I was looking for, and especially trying to get perpendicular fields on ring magnets. So this is just one of the magnetizers on top, and this is basically below is an assortment of most of them. Here's 4 of my units I put together. The one at the bottom was version 2, and then the one with the Teflon is version 6, I think. I'm losing count on this. And then the far top is version 3 is the far top, and then version 4 was next, and then version 5, which is being worked on right now, which I have pictures of soon. This is one of the magnets me and Jared worked on, and we ended up magnetizing about 6 rollers with all this design work on it. So what you're seeing is a colorized version of magnetic film, which I have that here. And you can get this on Amazon, but the colors represent the strengths in the fields on the magnets. So with these tests, we were able to put 6 equal points of magnetism onto the magnet and 6 dead zones, basically. So the fields would go, you'd be strong and they drop, and they'd be strong and they drop. It would deviate the compass, and it would do the exact same performance we would see like at Searl Magnetics. They had their rings magnetized, and it would jet forward and stop and jet forward and stop on a sheet of metal, and mine did the exact same thing. So basically it's like a magnetic gear of sorts. So we put a number of rollers together and put them on the test run. Didn't see anything too abnormal, except at certain RPMs they would try to float off the surface. So that's one of the things that we found occurred far too often, is that they would start to levitate. And I'll continue on here. So this is version 2 and version 3. Now this was about almost a year ago now that was on version 2, and I'm presently beginning work soon on version 7, 6 and 7. Version 3 is still up and running, and it can get up, those rollers can get up to about 200 RPM. It looks pretty, but it doesn't have any kind of unusual effects because it is just standard bought magnets, no special patterns yet. but I'll be getting to those soon. Version 2 is up on my wall looking pretty, and it could only maybe do 50, 60 RPM. It was just the very basic model. As for version 3, it could get up to about 200 RPM. This was the first, it's an unmagnetized magnet, uncoated, 34% neodymium, and then the rest is iron and boron. I got that manufactured for myself, and then ground it on the lathe to get the weight correct. So this was my first trial run with using something with neodymium in it that was uncoated, and I still am using that today in one of the SEGs. So this is version 5, because the version 4 never went anywhere. So version 5 is the magnets are 104. I think it's 104% larger in capacity. Much greater power levels can be put on this one. And one of the errors I made in this device, which I'm working on right now to fix, I want to try an experiment using radially facing stator magnets. And so instead of the fields being north and south, and then south and north on the rollers, I wanted to do like north this way and then south this way. Conceptually, it seemed like it would work great, except where the joints were in the magnets, the rollers would quickly stop and get snagged up. So one of the things I learned was just don't do that type of field arrangement. So I have magnets right now that I'm about to put together in the next few days. That'll be the standard north up, south down, and the rollers be south up, north down. So it'll be tested on this version 5 assembly with the electromagnets, and these I run them. They don't get hot, they don't overheat. The only issue that I've found with this system is that the rollers want to float off. They hit a point where, which I've heard from Roshan and Godin, they experience the same thing. Sergey just made a video a few months ago, in that they experienced is when the unit would start to go cold, is that it would get really quiet. And that is one phenomenon that I have experienced, is that at a certain point, you can physically hear that the roller gets real quiet and it starts to float off the surface. But the issue is those electromagnets were so sinking close to the roller, it would hit them. So I worked with that system for a while. It looks great. It functions well, but it can only hit a certain speed until the roller wants to float off the surface. So, which leads to my next version. So, okay, let me continue here. So this is the version 5 looking good. I haven't changed out the stator magnets yet to the traditional style magnets, but that's soon coming. Now, the next picture underneath is a platform I built completely from scratch, and I bought a CNC motor along with a rotary indexer and had it put together at a shop for me so that I can mount each roller magnet underneath the CNC motor and precisely rotate it at however many holes I want to put in, whether it's 1 hole per ring or up to 17 holes with the 1/8 inch wide sprocket magnets I've been putting in there. So that pre-drills a hole, and then I come into a water immersed tank and then finish it off very, very slowly because this just sprays a steady stream of coolant onto it to keep it from sparking and starting fires, which they do. Those neodymium magnets love to start on fire if you're grinding them. And they don't smell good either, I can tell you that. So this is a system I built from scratch. The above is a more closer view of the ring magnets being drilled for sprockets. So I start the hole there, get the point pre-drilled, and then go underwater and finish it off. And the brass tube is spraying coolant water onto it. And so it keeps everything under control, and everything's very, very precise in the way it rotates. So everything's very dialed in. I can get however many holes I want to do. My ultimate goal would want to use smaller sprocket magnets and put 34 points. But the ideal thing for me would be to actually magnetize those points on, not having to use inserts like Roshan and Godin did. The below segment is version 6, SEG version 6 that I'm working on presently. And It's one of 6 stator magnets. And so basically I'm putting in a program to match the magnetic field on the rollers so that when the rollers go over, they are also interacting with the sprocket magnets on each stator. So what you see here in this bottom image is me manually putting in those holes. I'm doing this for experiments only. Eventually I want to have a company do this for me that is far, far, far more precise. Ideally, I would love to have these just magnetized into it with no sprocket magnets whatsoever. That would be a dream come true. And I think it is possible. I just got to figure out how to do it. So yeah, that's all underwater. I do that. That took, I think for all 6 segments in those holes was about almost 40 hours of work. A lot of evenings working late. So this was an earlier design. This is my first magnet using the sprockets to see if it could even be done. And it's this ring right here. It has 17 equal points on it, or mostly equal, because it was all done by hand before I had the machine set up. 17 points of magnetism. And each one has a 0.125 by 0.125 inch neodymium magnet glued into it to represent points. So you have perpendicular fields. This is the design you could see with the segment rolling across green film, magnetic viewing film that's green. And you can see it leaves a, people can zoom in there, but it leaves a really clean line. And within that line is tiny little squiggle marks, which you see in the bottom image of those magnets leaving a loop effect. One of the experiments I'm going to be trying soon is flipping the polarities to see if you actually get the up and down, up and down, up and down, which it might do that. I'll just have to experiment and see. So that's one of the segments. I'm eventually going to be doing 6 rollers, and each layer on each roller will have this pattern on it. So with what I've come up with is varying strengths from, so you have basically a not to the naked eye of looking at it, you have a wave field, even though that squiggly line is an up and down. The strengths represent a wave. And so what you see on this this Gauss reading, we put together, me and Jared, I gave him the strengths and values, and then he jotted down on this chart, I think it was Google Sheets, he put down basically what it looks like on a graph. And starting at the top, you have the N55, and it goes all the way down to an N38, and then loops back up. So basically, as the roller segment rotates, you're having the strength of field going out perpendicular. You're having it going up and down and up and down, and these things are rotating thousands of times, hundreds of times a second. And yes, so this is just one segment of 8. Ideally, I like to do all 12 rollers in time, which I eventually will, just to see what effect it generates. So this I did, and this is the 17-point sprocket magnet. I went through with the rotary divider and a Gauss meter and measured every 5 degrees. I took a measurement, and this basically plotted out the course for those sprockets to see which ones were strong, which ones were weak, what it actually looked like using Gauss readings. So I took all those measurements. You can see on the far left-hand corner, or far left-hand side, all those numbers, computed them all out and put it into a radar view. And that's what it came up with how magnetically the roller looks with a Gauss meter. Okay, so this is something new I'm coming up with. And it's this here. And what you're looking at is a part out of one of the rollers. On the left side, that is it is 99.9% pure neodymium mixed with a small amount of resin. And it's my idea, we talked with Jared about this, to basically make an electret with this. And while these are curing, I may have to add another element with it, but do more further testing. I made a custom-made Van de Graaff generator just for this purpose, is that while these are curing together, that you electrify it. And so you make this into, not only is it, neodymium, it's compressed, it has a tiny bit of resin as a binder and a sealer. This I made last year, and it has zero degradation, none at all. It's been perfectly preserved. So it would electrify it with static electricity to basically form an electrode. What I'm going to be doing is making a ton more of these to fit the rollers. So each one of these rollers will have this charged, positively charged, and then the main neodymium element inside the stator will also be the exact same thing of using a tiny bit of resin along with a mass quantity of pure neodymium compressed. And so the resin goes within all the mixture, coating it and also binding it together and protecting it from oxygen. Jared and me believe that it may have to run the experiments, but it is a way to create an electret with it. The version that you see on the right side is just a unmagnetized blank of neodymium magnet. Has no coating, there's no magnetic field on it. I got these just for test samples, not for magnetizing, of course, but because they have around 33 or 34% neodymium in them, to test them and see how the rollers respond with any cooling effects, any weight loss, which eventually will rig up a system to test for weight loss. Right now, I'm just focusing on the motorability and getting the rollers up to 500 plus RPM and watching for cooling effects. This is the press that I'm using to press the neodymium, these parts together with. So you just put in a drop or two of resin and then compress it inside the Teflon ring. And then while it's drying on top of that piece of acrylic, you would set it inside of the Van de Graaff generator. That's a closer look up of it being compressed. Let's see. I believe one of my slides does show the Van de Graaff. I'll get to that soon. So this is an image I finished up last night. And the pattern on the stators is the pattern I'm doing on my stator magnets. And I found a drawing online of this, something that it looked like John Searl had worked on. And so I've just gone to do it manually, putting sprocket magnets in these positions, obviously on north on top, south on the bottom. And then you have the top is the stator magnet pattern. The middle point is the rollers from the strengths going up and down, then back up as they rotate. So you can see the roller is one full revolution, or the circumference of the roller is basically strength in 8 layers all put together. So the top one's a stator magnet pattern. The middle is the roller's magnetic pattern. And then I superimpose them all together so you can see the roller on top of the stator and roller magnetic pattern overlay. So I finished that up last night, and that's what I'm gearing up to do. Now, these rollers here, if you count them, they have 16 points, not 17. I'm doing this to try different numbers. I've already built the 17, which I might eventually do a roller with 17 points. Might do one with 1 and then one with 6 and 12, but the numbers are important. I just don't want to just try random numbers. So this one is one with 16 points on it. So my apologies, I didn't show the Van de Graaff generator, but I'll bring it over here so you all can see it. I have it sitting right over there. So what's next for me in the next, between now and 2025? What I'm working on is finishing up version 6, the stator for version 6, with the new sprocket magnets, test for cooling and possible weight loss. Use the new 99.9% neodymium with a resin binder for the core pieces. Complete one full roller with the sprocket magnets and test for how far up the RPM can go. Test for cooling and possible weight loss, and then begin construction of the all-new version 7, which right now it's just theoretical, and weight loss and values as described by John Searl, test for cooling and possible weight loss. I have the math done on version 7 for the stator and the rollers. So everything will be done according to the law of the squares, using them to make the rollers exactly precise again. And then the stator will follow them also. I'm going to be doing a little bit smaller on the rollers, and this the stator a little bit smaller. And this is another thing I'm exploring is Dr. Paul Brown's device and replicate the magnetizing process. I've located one of the companies that is actually 20 minutes from me that made some of the magnetizing components for him back in the 80s, which was interesting to find out. And then my bigger goal be next year is begin construction of the second ring SEG along with 22 rollers, probably still using the sprockets, but it all depends on the success I have with them and their performance, how they behave. What I'm ultimately looking for is that they don't fly off, and that's the big problem I have with the pulse electromagnets, is that they would fly away. They would hit the electromagnets and then just cause a chain reaction and hit all the other rollers, and they would just come to a stop because they would be trying at a certain RPM to float off the surface and get smacked. So let's see here. And then, begin construction of the second ring and the rollers. I have suppliers in China that can make my components very, very precise and very close to the values that I need. So all I have to do is very carefully fine tune each component just a little bit to get it within that same gram rating for precision that I need it to be manufactured. So let me go get that Van de Graaff generator because it actually adds a little more something I want to add to this. So this is the one I built from scratch. This has obviously you have the dome. It's only a 6-inch dome, and I get about 3-inch sparks out, which is exactly what I need. And it's obviously way too overpowered for what I need. This part here will be the charging platform where the neodymium discs, step back here, the neodymium discs, these guys, I'll cast them and then set them inside. So it's charged with static electricity and have it timed so that it keeps the field here charged continually until they dry. I'm getting slow dry resin, so maybe 32 to 36 hours until full cure. So they're just saturated in that high voltage field for a very, very long time. This took a lot of work. Now, the one thing I discovered about this that I found very interesting that parallels this work with Teflon is that this Van de Graaff generator would not charge up the positive energy needed to produce a spark unless I used Teflon, a Teflon roller in the top. I was using a Teflon roller for the rubber band in the Van de Graaff generator to try charging it, and it would kill it every time. I would have the wrong voltages, and there would be nothing accumulating in the top dome. But when I switched and had a Teflon roller in the top and put a nylon roller in the bottom, the thing went wild. It started affecting the TV. Parts all around the tables were electrified. It was a shocking experience to get it to work so well. My apologies. I thought I had a picture of it here loaded on these slides, and it doesn't appear that it did load. I'll go back through. Maybe I overtalked it. No, it's not there. That's weird. I did have it on there. Okay, so there is the one version I'm working on, which is a carousel, and I'll just briefly take this over here and show you guys. I took pictures of it and put it on a slideshow, and for whatever reason, it didn't come. So this is the system for controlling it, RPM. It's all controlled by batteries. I don't have it directly wired in. So this one of these will read RPMs, battery charge, and also monitoring temperature of this. And this is the carousel. And you have the rollers inside. So I can mount any of my SEG units inside here and then test it for RPM. If you look, let's see, there's a camera. If you look here, it has magnets, kind of like Roshan and Godin did, but their rollers were mounted. I didn't want that. I wanted these rollers to be free to orbit where they wanted to go, not where I would determine them. It's something me and Jared have come to believe, is that there is a secondary magnetic wave that when these things are rotating around, then in spite of one going one direction, the magnetic wave is also traveling another. So I wanted these to be free to maneuver and oscillate and vibrate as they're orbiting around, as you can see here doing that. So I built this carousel with the magnets here. And so they basically gently push the rollers around. So far, I've been able to get these standard magnets. These ones do about 200 RPM. These are the old ones. I got new ring magnets here. They're quite a bit more powerful, and I've gotten up to 460 RPM on them. Now, this is an old version with only N32 magnets. They're considerably weak compared to the ones that I have now. I have N52 with all the sprockets. So my hope and goal for this device is when I put the new unit in here, I'm trying to shoot for 550 to 600 RPM and watch as the rollers, float. But the one thing I've noticed on those is about 450 RPM, the rollers do lose their sound. And it's quite amazing to hear that the sound just goes down, I would say, by about 1/3 to 40%. 30 to 40% loses its sound as the velocity increases. So that is the stator unit. It's one of the originals that I'm not using for tests anymore. Be testing version 6 probably by next week. It'll be coming through. I'm going to be wrapped up and be able to put it on here, spin it up, and actually test for the first time true real readings and get these things floating on the surface. This will be the first time ever using sprocket magnets with this new stator, and I'll get a roller assembled with sprocket magnets in it. So it'll be the first time to actually get it up and running, which will be probably a matter of just weeks now. So that is it for my presentation, and it went a little faster than I thought. But thank you for having me on here, and I'd just like to thank again the Lord God for guiding me and introducing me to all the people around here, who just hooking me up with people I need to be. It has been my life story with this work. I've had so many times where literally one time I walked into a building and I was thinking about positively charged elements like the neodymium. I walked into this building in Portland and they're giving a lecture about positively charged elements. There's been many, many, many times, and Jared is one of these people that I have ran into so many roadblocks with questions and obstacles and can't figure things out. At one point before I met Jared, I was actually seriously just thinking of giving this whole thing up because the things there were so many things about it I didn't understand. And I prayed one day, and 2 weeks later, I was literally sitting right across from Jared at a wedding event. And we hit it off and we've been great friends ever since. I also like to thank my wonderful wife for all her support in this and everything she's given me and her insights. So that's it for me right now. Thank you for having me on here again.
Yeah, well, Isaiah, thank you. So let me bring the guys on. First things first. And we still have Russell with us. Maybe we can get you guys to chat. I think that's everybody that we have. Let's put our hands together and give Mr. Isaiah Ritchey enormous applause. We're pushing forward with the builders today, so which is really exciting. But that's my summer project too, is builder stuff. In fact, I probably won't have time to see you this time, but if I come back down to Jared's in the future, maybe come down and get some photos of your stuff and do an interview and all that.
Anytime.
So, yeah. And then you and Russell are probably familiar with each other's work, right? To some degree.
Oh yeah, absolutely.
Yeah. Well, and I know Russell's been a mainstay for. Russell's muted.
Yeah, Isaiah, I'm not familiar with your work, but I love your work. Your work is just top notch.
Thank you very much.
We need more young people like yourself doing this.
I appreciate that a lot. I've listened to your YouTube videos countless times, Russell, and the ones you've done decades ago, I've listened over and over and over.
Yeah.
Yeah, well, it shows in your work. You've really absorbed the material. And I wish you all the best of luck in reproducing this device. And, it's incredibly simple, but infuriatingly complex, as you can see.
Tell me about it, right?
Yeah. But you're looking for elements to go into it that are negative, highly negative on the triboelectric series. Basically, what you want is almost like in radioactive materials, a critical mass of neutrons. In this case, you want a critical mass of electrons. So you want negative charges, basically negative charges flying all around, negative charges coming out of the ether, negative charges forming Cooper pairs and boson pairs, and incredibly high voltages. When you're dealing with the ether, electrostatics is everything. The ether is non-physical, so you can only affect it electrically.
Agreed. Thank you.
Yeah. The Searl is, I mean, again, I can't stress, for me, it's cultural importance, right? But like when I first got into this, you've got T.T. Brown, this was before, I mean, you had like when I first started getting into this area in the 90s, you had Eugene Pogklenoff. This was really kind of before Ningley and all that stuff. So you had Pogklenoff with the rotating superconductor, and that was really new and nobody knew anything about it yet. And then the two that people did know about were T.T. Brown, right? And I know, Russell, you've built tons and tons and tons of T.T. Brown stuff.
Yeah, built and flown since 1990. That was 34 and a half years ago. And the time just goes by so fast. And I'm getting old. I'll be 63 at the end of the month. So we need more young people like Isaiah involved.
Yeah. And that's the other giant one. And I remember I had somebody gave me a VHS. It might have been you. I don't know where I got this. I got a VHS tape with a Searl presentation on it. And that was that's giant, right? Searl is, and one of the things that gets me is like, it goes above and beyond the design itself. It's like he helped to define, when people think anti-gravity, right? It's like wheels within wheels and the whole 9 yards. Like a lot of that goes right back to Searl. So he helped define that, like that archetype for, okay, well, we've got an anti-gravity drive. What's it going to look like? Like their mind goes back to Searl. It's been around that long and it's that important, So
yeah, wheels within wheels, like Ezekiel in the Bible. Ezekiel saw the wheel within a wheel. And this is basically a very, very, all those UFOs that we see and they're filmed by regular folks and the military are nothing more than flying electrostatic generators. This propulsion flight means it's fundamentally electrostatic. But when you talk about the generators, you don't have to supply anything external, any fuel. The only thing external comes from the environment around you. And that field strength is just off the charts. The ether is non-physical. It's Lorentz invariant in non-material ether. So this is our source of gravitation. This is our source, and electrostatics is our source of inertia or no inertia. In the case of the Searl and Brown devices, and so basically, we can build our UFOs. We can build our starships. All we have to do is just get some people together, get some money together. That's the main thing, is the funding. And get like-minded people together, get them together for 3-4 years and watch some amazing things happen, and
yeah. Well, and then collecting these anomalies too. And Isaiah, you mentioned some of those, right? It's like warmer on one side than the other. So even with yours, you've seen a ton of anomalies, right?
That's very important because that temperature change is indicative of an ether conversion.
Yeah.
That was interesting. That was the very first unit, and it was always like that. It was always warmer on one side and cooler on the other, no matter whether it was spinning or sitting. There was always a temperature difference.
That's very important. That's highly significant. So I love your work. You're on the right track.
Thank you.
Yeah.
I appreciate that.
What were some of the other? Could you run through some of the other anomalies that you've seen with these?
So lately, it's with the certain RPM. I've witnessed this many times, and I was like, maybe it's just me, and it's just the RPM, and they're about to fling off. But when I listened to that interview with Sergey Godin, that got put on YouTube about a month and a half ago, he would say the same thing: is the rollers would get quiet. The whole system would quiet down at a certain RPM, and then it would start to get cold. I was like, oh, that's what I'm hearing too, or no pun intended, but that's what I'm observing, is that at a certain RPM, about the 450 range RPM, the sound just goes down.
Of course, yeah. And one of the most striking characteristics of genuine UFOs is their utter silence.
Well, so then there was what was the other big one? I'm trying to remember his name.
And there was a guy in Russia, the Black Sea, Mr. Delphin. He had all those videos, which are still on YouTube, fortunately, and he had an incredible setup, and he worked on it for a very long time. But one of his very last videos, he bought a solid chunk of neodymium, and I emailed him about this before he's gone. He's completely gone now, but he bought a solid chunk of neodymium for his machine and put it in there and spun it up at about 450 RPM. And within about a minute and a half, 2 minutes, it not just got cold, it went below freezing to negative 17.5 C. It got real cold. Then he stopped the unit and wiped frost off of it. And my jaw I had to get it off the floor. I was shocked. Like, that's more confirmation what Searl was saying, is when this was operating, it would get cold. It wouldn't warm up. It was incredible.
Yeah.
Shows it's following the principles of energy or anti-energy from the late Colonel Thomas Bearden. T.E. Bearden talks about energy and Tesla technology, Tesla scalar electromagnetics. Everything works in reverse. And it shows gravitation and inertia to be fundamentally electrical. And you have the falling temperature gradient and implosion. That's straight from Victor Schauberger. Of course, he produced anti-gravity devices too.
Yeah. So Russell, then going back to, and again, for folks who aren't familiar with it, so Sergei Godin and V.V. Roshan, and I believe this was the 90s, mid to late 90s. They did the experiment, the Godin-Roshan experiment. You alluded to that a moment ago. So what I remember reading about theirs, again, they changed the design. One of the problems they had was they weren't sure how to magnetize it. So if I remember correctly, they drilled holes in the magnets and inserted cord.
Not in the magnets, actually, and they were nylon runners, and they drilled holes in the nylon runners and put in actual magnets. That basically made the magnetic Max cell. No, it is. They were trying to copy that design, but instead of magnetizing it that way, which we came up with a methodology for doing that with a robotic arm and a print head. Basically, they put in little magnets, which is kind of ingenious, and it worked.
Yeah. Now, so from what I understand, and this goes back to their paper, and so folks can look this up online. But again, the Godin and Roshan experiment, they saw self-spin over a certain RPM, where
over a very low RPM, like around 500 to 600, between 500 and 600 RPM, which is not very fast at all.
And then I believe they also saw it running cold, right?
Yes, it ran cold. Pressure drop, a candle flame would go out if placed in the middle. That's total Searl effect. Magnetic walls, that's Searl effect. And then weight loss, the thing lost most of its weight at a low RPM.
So then the other one was the Morningstar energy box, and that was Paul Murad and John Brennan's
device. Yeah, Morningstar.
Yeah,
that's Roshan Godin.
And I talked with Paul about that several times. The issue that they had was, again, the machining was not easy for them to do. And they changed the design considerably. They made several changes, but they saw transient weight loss. And again, the challenge they had was, because this was a big, heavy device, and it wasn't perfectly machined, so it was bouncing around, right? So what he had said was they had this on a set of 4 different scales, and then they had to average out the weight of those scales. And that was one of their challenges. And he said that they had several considerable instances of weight loss. And if I remember correctly, in many of those, they weren't sure if that could have just been an error, right? It was shifting from one scale to another, and they weren't calibrating correctly. But he said that they did have one major event of weight loss happen when it got to a certain RPM, and they were able to check all of the scales, and they all had the same reading. So,
And it was a low RPM. The actual Searl device operates a far faster than that. And then you get full weight loss and beyond. Not only weight loss, but inertial loss, a loss of inertial mass. That's very important.
now, if I remember correctly, and again, there are lots of little, and Isaiah, you would probably know as well as anybody, there are lots of little gotchas. Like, for instance, I remember reading, Russell, you talked about pressing the neodymium. You can buy neodymium that's already machined, but if you try and machine it yourself, you were saying you have to use argon.
You have to do it in an argon environment. What we do is we have powders at like 425 mesh, 435 mesh, and all the powders are consistent size. We want jagged edges on the powders, not round, not square, but jagged edges on the powders, and have them all very, very, basically to the point as if they were released in oxygen, they'd flash into flame, basically, especially the neodymium. So you want to have everything very, very as fine a powder as you can get, and then combine it in a turbulent flow of argon, and then press it in the molds with maybe 200 tons of pressure. You're aiming for around 7 grams per cubic centimeter of density.
Yep.
Pretty cool. Yeah, that's very important. You want as dense and heavy magnets as you can get. The denser, heavier magnets work better. And then, you want to coat, if possible, coat everything. I like your idea, Isaiah, of having everything, well, the neodymium, especially in resin, to protect it from oxygen. And, they're still great. That's really important. That's a great manufacturing technique. But yeah, Paul Brown also did everything in argon. That's very important. You want to do everything in argon, especially for the neodymium.
That is right. That's another. And you know what? I'll have to put this online sometime. I have, and in fact, I think several. This is around, right? But yeah, Paul Brown built an SEG in the mid 1980s, and he's no longer with us. But I have photos of his SEG. And I have, I believe, some notes that he had written about it.
I would love to see those photos if you could pass them on at some time.
Yeah, let me find those.
I would love to see those.
Our former company president, Phil Tauber Jr., was part of NewCell and part of Paul Brown's company. And he joined up with Paul Brown basically to fund the work. And after he started the SEG, the wiring associated with it just burnt up, because there was far too much power going in to the wiring than the wiring could handle, because this is a device about the size of a large, thick telephone book, and it was producing, they figured, something around 1 megawatt at low RPM.
Yes,
1.2 million watts. It was insane.
Yeah, exactly. It's totally insane. Yeah, that's totally insane. Think about what we could do with that much power in a small space.
That
was to power whole communities off the grid.
That was in Brown's notes. Yeah.
83 American homes is 1.2 million watts could power about 80, because an average American home uses 12 to 15,000 watts.
Exactly.
You could run about 83 American homes with that one unit.
Yeah.
Yeah, and I remember reading that in his notes. I remember reading that he hadn't anticipated the energy output, and it literally melted the device down.
Yeah, it always produces more energy out than they anticipated, even from the very first ones that were built in 1946. The nominal voltage was about 100,000 volts, and then it just kept increasing.
Yeah. So the other thing for me that's interesting, and I think it's important to mention this, is, again, like APEC brings people together, right? But you and Isaiah haven't worked together in the past. Paul Brown was working independently. Godin and Roshan were working independently. And for me, it's important to look at, these are all independent replications where they're working from the same notes, but they're not working together, and they're seeing the same anomalies.
They're seeing anomalous things. That's very important. And the most important anomalous thing is that the device violates Lenz's law. That's a hallowed law of electromagnetic power generation for generators and motors. It violates Lenz's law, and that's huge. That's huge. And the fact that it also produces cold instead of heat. Now, in Lenz's law, you get heat. You get the opposite in this. So it's totally consistent with the principles of an energy as delineated in Tom Bearden's works on Tesla scalar electromagnetics.
Yeah, yeah, and that's something that I know, like, Bill Alec has been studying that. David
Yes.
Chester has been digging into Tom Bearden's work lately, so,
Yeah,
it's
I've been reading Tom Bearden's work since the mid 80s, and it is right on the money, in my opinion. And he wrote a lot about Floyd Sweet's anti-gravity work, about
yeah.
Russian scalar interferometry, Tesla scalar interferometry, all these incredible things, anti-gravity, force fields. Basically we have everything we need to have Star Trek type technology right now. We just need to get
I
people
talked
together
to
in one place to build it all.
I spent many hours on the phone with Tom Bearden, but as Bill has mentioned this, he held back a lot. He always held back a
Oh,
lot,
yes.
and so, but I
For
do remember him
safety, for safety.
I believe it.
yeah, so,
Look at how much power you produce.
and my feeling was too, just from talking with him, that he put more. This was just me, but he put more in writing than he said, and so yeah, it's easier to learn from him reading his work as opposed to looking at his interviews and stuff.
I
But
have a lot of his books and video presentations, and a lot of them are on YouTube now. Everything's online now. Also, I recommend Otis T. Carr's Utron, Ralph Ring. I first met Ralph Ring in Holland at the Global Breakthrough Energy Movement First Conference. Breakfasted with him and his wife every morning.
Lucky you.
Yeah, it was incredible. He actually rode in a manned version faster than the mind of man can conceive, much faster than light, almost like a kind of teleportation. So you can see that these type of craft can easily go to other planets and stars in a reasonable time and economy. When you're flying through space, you're not getting any heavier with increasing speed. There's no time dilation. So you could take a jaunt in a Searl craft to Alpha Proxima Centauri, take a couple weeks, month flight, to Proxima Centauri 4, and then come back, and everyone on Earth will be no older than you, but actually you will be slightly younger, because time has passed a little faster, because instead of you're living in 1G on Earth, inside the craft there's 1/2 G onboard gravity.
yeah. Now,
So,
Russell, do you know if is Ralph still with us? Or is he-
no, he died. He died a couple
Okay.
years ago, unfortunately.
See, and
No.
that's one of the challenges in this community is like, and one of the things that I hope our conference can do is help preserve the history of this. I mean, if nothing else, it gives people more to work with in the future. But yeah, we've lost so many people, and not just here, but I mean anything relating to warp drives, field effect propulsion, inertial propulsion. So many people have passed, and it's just the heyday of that type of engineering was quite a while ago. So
Well, that's why we hope to bring in as many young people like Isaiah as possible to come back into the fold and help us out. And Isaiah, I would love to have you on our team, with the new effort. That'd be awesome. And we're down here in Central Florida. Our company president is in Central Florida. Spintronics is located in North Palm Beach. And our late president, Phil Tubbert Jr., lived in Fort Lauderdale. And his son lives in North Palm Beach, and that's where Spintronics is based now. So
yeah,
working
well,
here
and
in
then
Florida.
and Isaiah is working with Jared too, and Jared's in Oregon. And again, Isaiah, I would love to at some point. I would love to come down and try and get some footage for you. If you're open to it.
Completely. Yeah.
Yeah, so yeah, I think that there is a new generation that is coming up, and I think that like they're able to benefit from a lot of the history that's still here, but there's also new stuff, right? Especially in terms of like AI and computer modeling and things like that.
Well,
There are
there's all
these
kinds of incredible new discoveries in material science now,
yeah,
and all kinds of incredible papers out over the last 10, 12, 14 years on spintronics. And this is going to be, they say spintronics is going to be more of a revolution than electronics. And it's where instead of taking advantage of an electron's charge, you're taking advantage of an electron's spin, something that's
okay.
far more powerful and far more incredible. Computers running on spintronics are going to be quantum leaps ahead of the computers we're using now.
Yeah. Well, gentlemen, again, thank you, Isaiah, so much, and Russell, thank you again as well. Bob Greenyer is here now. Bob is going to walk us through EVOs. So thank you again. Absolutely wonderful. I would love to have both of you back on in the future. For the time being, I'm going to bid you farewell. And let me see. If you guys are still here, I'll bring you in for open discussion. But I want to go to Bob Greenyer. Bob, welcome, sir. Oops, sorry.
It's a very, very great pleasure to be here and to share some of our work since we last met.
Yeah. Well, you and I, you know what? I did a StreamYard with you on, I think it was Bernie Conkin's channel, right? Not too long ago. You were in Japan then. So
that was quite some time ago that I was in Japan. That was, I guess, April last year. I was visiting Dr. Takaaki Matsumoto, who sadly passed away. But I'm going to actually be going there at the end of this month as well, because the family are handing over the papers of the great scientist who really pioneered ball lightning as a means of nuclear transmutation work.
See, you've got your traveling legs. I haven't been traveling that much. I'm going from, so my next trip here is Seattle to Portland, and I'm like, how am I going to do? You know, like
you'll be fine.
Like, you know, please. I'm taking a train though. I didn't have the energy for the aircraft after getting waylaid in the airport for a day last time. I was like, I'll take the train. What could possibly go wrong?
I think that's probably quite common. So Phil Dubois has come down here to do some mass spectrometry tests. I'm here in Santa Cruz in California with Alan Goldwater in his Magic Sound Lab, as you can see, speakers and sound treated room here. And he was coming via Chicago, and his plane was 3 hours delayed, and so he missed coming the day he was meant to be here. And then they didn't send his bag in time, so he had to wait for a bag with all the parts for the thunderstorm generator to be sent down. But anyway, it's all good. We're doing tests, and I've stepped away from the tests to share some of our experiences and thoughts with regard to.
Yeah. So do you have now? Did you have like a PDF that you wanted to upload, or did you?
I have. I've got a presentation. If I can share a screen, that would be great.
And you're a pro with StreamYard, so
I don't know whether I'm a pro, but we can see what we can do here.
Well, Bernie is the pro. I lean on Bernie. Like every now and then I'll call him, Bernie, help me.
So maybe he can help. So maybe I can see what I can do here. If I play, I probably want to play this in a window.
He's kind of like Batman. I throw up the Bernie. Yeah, I throw up the Bernie signal, and he'll just kind of appear out of. It's like a genie. There's a poof of smoke, and there's Bernie. He's like,
okay. So I mean, I'm ready to fire away. What I'm going to do for you today, as I'm going to talk about, I'm essentially going to add some bits into my ICCF 25 presentation that I gave last year.
Let me see. I don't see. Oh, well, I guess just put it up when you're ready. I don't see it yet, but
yeah, I've not shared my screen yet. So let's try and do that.
Well, yeah. Well, why don't I take myself out and let me thank you again in advance, because, you know, and you've presented before. We have about an hour today, but I mean, you have spoken for like 2-3 hours easily. You know?
Well, I'll try and hit the hour mark, but I've got some really nice stuff. I reanalyzed, and this will be at the end of the presentation. I reanalyzed, if you can remember that very famous sample that John Hutchison showed in many of these videos. Yeah. I think you've actually seen it. It kind of has. I think it's from a drive shaft or a crankshaft or something. It's very thick, about that diameter, and it has like a stair step around it. That was.
I've held that. I've held that.
I've held it too. So we're joined by at least that piece of metal. Yeah. And John Hutchison. And that was analyzed by George Hathaway back in the day, I think in the 1980s or 90s. It was also analyzed by the Max Planck Institute and by Ken Shoulders and by other authors and researchers. I actually visited at the end of 2022 George Hathaway in Toronto, and he gave me some fragments of that. And last year I actually analyzed that, and I've just got one image to share now. I'm going to do a much broader presentation on that.
Let me take myself out.
Okay, let me see if I can share the screen first. Share screen. is the easiest with 2 monitors. I've got that. Screen sharing works best on a good. Okay. All right. Share screen. Now what? Window, entire screen. Let's do that. There we go. Right. Can you see that?
There we go. Decoding EVOs. Yeah.
Yes.
Thank you again, sir.
Okay, so let's do this. Right, so my name is Bob Greenyer. I'm a volunteer with the Martin Fleischmann Memorial Project, and thank you for joining me this 11th of May 2024, and for Tim Ventura to allow me to speak at his APEC conference here. So what you're looking at on the screen here is one of the most famous samples by John Hutchison, a resident here about 4 or 5 hours north of me here in California, where I am at Santa Cruz today. And it is the sample where a steel knife sank or teleported into a block of aluminium. And then what he did was he shaved that off, and he revealed the fact that this was embedded into the sample. Now, why this interests me, I've actually currently got a section of this on loan from its author, and we've done various tests on it. I'm going to do a few more tests on it before I send it back in the later this month. But anyway, it has the steel here. This is steel. This is on a Dynalight microscope. And then this is the aluminium. The tool marks here are where he used a planing tool to remove the aluminium from the top and reveal the section between the steel and the aluminium. The thing that really interests me here is this division here all the way around the steel. And it looks like it's chewed away at the aluminium and not so much at the steel. And this is consistent with our understanding of exotic vacuum objects. So I have, in other presentations I've presented, I believe that exotic vacuum objects formed a skin around the iron here. And it basically, they're like little micro machines that caused it to be able to move into the aluminium, turning it to a kind of jelly, but on this perimeter. And it just moved in and swept the material around it. Of course, with the electromagnetics involved and the standing waves, maybe it did this so instantaneously, it looked like it maybe teleported in. So the structures themselves tend to produce elements, and the elements that they seem to produce most of is carbon. And I've argued in the past that this is because if they are effectively denaturing the matter into prima materia or a quark gluon soup or something like that, when the matter reforms, it could form to a proton, but that becomes hydrogen, that becomes a gas. If it forms helium, that becomes a gas, or alpha particles. If it forms beryllium, that decays very quickly to alpha particles, and that becomes helium gas. So the first element that it can synthesize, which is effectively an alpha conjugate nuclei, alpha conjugate being one of the, if not the best packing density of matter that the universe provides, in ordinary dense matter, is carbon. And so I believe that's why you see a lot of carbon. Of course, when carbon's there, it has lots of different allotropes, and it's got a high melting point, boiling point rather. And so it's very stable. And so this is why I believe you get carbon forming. And so, you know, some might argue that somehow John Hutchison cast this piece of metal into this other piece of metal. But given the fact that we have seen fluidization of metal below its melting point in indium exposed to Amasa gas in Japan in 2019, and other kind of similar processes going on in ceramics and metals, I think that there is a better than zero odds that this is actually as a result of exotic vacuum objects. It was these kind of things going on, and this is a scanning electron microscope of a different part of that knife. It was these kind of things, in fact, that interested the militaries around the world, and also Ken Shoulders was brought in, and it was in, I think, about 1982, and after about 4 or 5 years, he came out with the EV, A Tale of Discovery, which you can download from our Facebook page. And this was his journey towards kind of basically understanding these structures. Okay. Now, my understanding has taken me on a journey where I came across a Russian scientist. I unfortunately never had a chance to meet him, but I'm going to dedicate my talk today to one Vladimirovich Dubovik. He died April 27th, 2024, after suffering some dementia and neural decline these last couple of years. He was born in March 27th, 1938. He graduated from the Moscow Physics Institute approximately in 1962, and it was him that discovered the toroidal moment as part of his PhD thesis, which he published in 1967. The toroidal moment was only verified in the West 30 years later in 1997, and right now it's starting to be understood, and we're going to be touching on this. Now, what we are looking at here is a frantic, desperate attempt in 2000, I believe, 18, in January or February 2018, of Vladimirovich Dubovik trying to explain to the people in the Moscow Friendship University, and I've actually presented in this university, I believe in 2015, in February 2015, I gave a presentation on the work of the MFMP, for which I volunteer. There's a meeting, an emergency meeting between all of the people involved in this field most actively in this room where I had an opportunity to present earlier. And it was about the death of Yuri, who ran the conferences for over 25 years in Russia. And he had died, and they blamed it on this strange radiation. And he is describing at this point, as far as I understand it, how if you mess around with this type of radiation, it can actually extract the life force in a beam from your body. And he believes that this is what killed Yuri Bajatov. And so they ceased working until they understood strange radiation a little bit better. Okay, so I'm going to go over mostly some aspects of my presentation that I gave at the International Conference on Cold Fusion, or the ICMNS conference in Szczecin in Poland, in number 25 in Poland last year. And I'm going to add some extra slides in there from other presentations since, and I've got some absolutely totally brand new stuff, really killer, at the end here for you to consider. Okay, so this is Martin Fleischmann, who you may know from the cold fusion label attached to him with regard to what I believe is the same process going on in all of these different systems. This is an experiment by Henk Uren, one of our open researchers in the Netherlands. And this here, this helical beam coming out is, in my understanding, a coherent matter wave that comes out of a particular part of one of these ball lightning-like structures when they decay, or their substructures. Okay, and we've actually proven that with a scanning electron microscopy recently, and the specific place at which it comes out of these decaying structures. And so this is from Martin Fleischmann's interview in Infinite Energy in 1996. He says, "As I told you when we were talking before, we had about 4 projects which we were working towards. One was to do with gravitation. One was actually to do with the behavior of electrons in metals. We actually started to collect equipment together to investigate the behavior of electrons in metals." Okay, so the metal-electron bond is very, very interesting. Okay, it's not like a covalent bond or an ionic bond or a polar bond. It's really it's a different kind of species of electron interaction. And it's one that these exotic vacuum objects seems to interact with. Okay, so you can see here some traces that were caught in a David Boutlier experiment from Canada, and that there are these things orbiting, pairs of things orbiting around each other. Here is another experiment from Henk Uren, and using the 14.5 stops of a Sony A1, we were able to look into a plasma ball at the bottom of the chamber. Okay, and we were to see that within the plasma ball, there was 2 spots, and within the 2 spots you have more 2 spots, and they happen to be at a particular angle. Okay, so what you see as a little flash in the tank here is actually a much more complicated structure going on. What is that structure? Well, hopefully we'll find out. Now, these beams, they seem to have a forward-looking vector that influences matter in their forward direction. So if you look at this trace here, it's coming up here, but it bends around another trace. It then comes along here, and as it comes along here, it bends another trace around it. Okay, and then the one that's bent around it influences it, and it comes back, and then it bends in the other direction. And then as it's tracing into this direction, before it hits this point up here, it affects the path of another trace. These things are not caring about the cathode, which is down where you see this bright spot here, and they're not caring about the anode here. They only care about each other. And this is something that Ken Shoulders talked about. But they have this highly focused beam that projects out in front of the structure, which I would argue is a gravitational wave beam. And they have this non-radiating boundary, this specific boundary in which they can have no effect on their same kind of structures. But when something or ordinary matter comes within that boundary, if it possibly can, then it has extreme effects. Okay. So where did all this start? Well, what Ken Shoulders did was he went back to the work of Winston Bostick as one of his references, and the book of Lafferty as well, from work done in the 1930s onwards at Bell Labs and so forth. But what Winston Bostick was doing, he was working on Project Sherwood at Lawrence Livermore Laboratory and a couple of other labs, Los Alamos and so forth here. And he was trying to convert the hydrogen bomb into domestic fusion. Now, if you actually see some hydrogen nuclear detonations, you will see that they have this specific structure. And I've talked about this recently, this magnetohydrodynamic structure. And sometimes there are a couple of experiments where one in particular where they used a tactical nuclear weapon test. This was to be launched from artillery shell. They actually saw a plasma toroid, literally extremely clearly in there. Okay, so there was an understanding at this time that these were some kind of plasma toroids and so forth. So in order to make this controllable, he went into the lab and he was firing from, and I'm going to show you here. This is a ceramic gun. Where he has 2 deuterated titanium electrodes, and he puts, say, 10,000 amps through them in a very short time frame. It produces a plasma which contains the deuterium ions, the titanium ions, and it has the current going round with the magnetic loop around that. And there is a so-called magnetic reconnection here, so you get a self-contained pinch in a torus. And then he fired at least 2 of these from opposite sides of the chamber, and they would form toroids that would then spin around their center of mass. And he called these things plasmoid. There is someone that says oid is a certain type of spiral in Jewish law. I haven't verified that, but this would be a plasma spiral type thing. Effectively would be the translation of that. Anyway, so he was saying by 1957, he was publishing this in mainstream journals and newspapers even. He was proposing that this could be the basis for the structure of all matter from the subatomic to the formation of galaxies. So in that respect, he was not too unlike Kelvin, but he was having something that was more visceral for people to connect with. And then he said that he proposed that aspects of his findings could lead to ultra-fast propulsion of up to 450,000 miles an hour. To put that in context, if you were already traveling at 450,000 miles an hour, that would get you to Mars in 13 days. In 13 days. Of course, you would need to accelerate to that, and you would have to decelerate, so maybe 4 months or whatever. But just using this approach, you might expect to reach that in 14 days. Okay, so I don't know whether you're going to be able to hear this, and someone might like to say, but I will share these, and I've talked about this in the past. But anyway, when Shoulders, in his EV, A Tale of Discovery, there's a link to it there, his 1987 conclusion says, by some irony of fate, we may have folded back upon ourselves and now have accidentally discovered that the EV is an ideal monopole oscillator. This oscillator is the perfect generator for vector and scalar potential waves without contamination for E and B fields. These waves can be thought of as longitudinal waves in the vacuum. They are largely undetectable by standard electro or magnetic detecting means, but are readily accessible to the monopole world. There appears to be an incredibly large number of useful phenomena yet to arise from using the potential effects that are not immediately accessible to the force of electro and magnetic fields. This phase-determined, force-free world will certainly be another chapter somewhere in the future. And, my friends, I think we are entering that chapter. Now, as I said, it took a long time for the West to catch up, but here in Nature Materials in 2016, electromagnetic toroidal excitations in matter and free space, this description largely matches this. And you can see here at the end, the last sentence is, the physical significance and detectability of these potentials are not established and are being actively discussed in the literature. So here we go, 2016. This is 1987. It almost appears like these things are moving on a glacial pace. This is the overall structure of a non-radiating configuration. What do I mean by that? Well, when you have, it says, a toroidal dipole. So we're going to be talking about the toroidal moment, the toroidal dipole here, which will be present effectively in a two of those plasmoids coming together. And I'll show you that in a minute. Represented by a solenoid with oscillating poloidal currents. This is the oscillating poloidal currents. An electric dipole here, representing by a pair of opposite charges oscillating on the same frequency as its currents. Then basically the electromagnetic waves that are combined from this end up cancelling at a distance. So there is zero electromagnetic waves detectable or emitted out of this, but the vector and scalar potentials still exist. So this is the same thing, 87, 97, 2007, 2017, you know, another 30 years. Okay. So sometimes it takes a lot of people to catch up, a lot of time to catch up. But anyway, when you'll see later is actually that when you have a fractal toroidal structure, then you don't actually need this oscillating dipole. The actual toroidal moments cancel and you get a non-radiating boundary. I'm going to play Tom Bearden here, but maybe you will not hear him.
There's one other thing we must say about that. There is emerging in the last few years, it has emerged in orthodox science at an advanced level. What I would say is the very beginning, but it's moving pretty fast. Theory of force-free fields. And these are getting very close to what Tesla is doing. They haven't added the anti-wave back in yet, but they're getting close. At least they're eliminating the overall force and doing something else with the electromagnetics that remains.
So could you hear that? Just let me know in the chat if you can hear. That would be helpful. Okay, so did you hear that? Because that will be useful later on. Okay, so in the Lion reactor here, the sadly departed Neil Crichton Gould, he gave me this reactor because the project were keeping individuals that were wanting to share their work. If they didn't want to be open about who they were, we were maintaining their anonymity. He shared this. It was based initially on an experimental proposal I made in 2013, and he ran it. It's got nickel and diamonds in here and deuterium and so forth. Okay, you heard it barely. Okay, all right, I can maybe fix that. Let me see. Okay, so on that, we found structures that did look like galaxies. This is a 2-order structure, and this is a 3-order structure. This is right rotation with a hole. This is left rotation with a lump. So that tells you something about what's going on. Here is a 4-order structure with right rotation. And here is a 5-order structure with right rotation. So the idea that Bostic had that potentially there was the ability to form, galaxies, you're seeing something again similar to what he had, but these are frozen, not in photographs of plasma moving in a chamber, but in actual solid material. So my journey of connecting with first hydrodynamic structures and then magnetohydrodynamic structures really started in 2017 here in Mumbai in Suhas Ralkar's lab, and I videoed in an ultrasound chamber cavitation bubble structures. And in there, I saw this particular structure here. It has a wave function on it, but within it, on regular spaces, it has helical waves coming in and merging into the overall structure. So I thought that was very interesting, parked it in my brain. And then as things became more, and that's actually the video of the effect going on there. So I'll just turn off the audio there. These are the cavitation structures merging and joining into each other. But effectively, they are the same thing as these kind of Kelvin type smoke rings. And this is by... Oh, what? This is alien scientist Jeremy's video image here with a laser cutting through it. So you can see the same kind of structure going on. And this is a screen grab from part of this video here, where you can see this overall sort of, it's kind of like a heart shape with this beam coming in. Now, what you can see here is everywhere where you're seeing this white, that is because bubbles have formed in the fluid because of depressurization of that part of the fluid, which means the bubbles are coming out, they're expanding, and then they become reflective to the light that I was shining from the side. This means somehow in this entire area, there is some depressurization and compression going on in the center of this structure. It was very weird for me to see this, okay? Because this is almost like a flat structure. It's like two discs that are rotating around, okay? One kind of on top of each other, just like Bostic had shown. And it's propagating in this direction. Moreover, it produces a depressurized beam, which is some sort of vector that comes out of the back. It disrupts the water at a distance. And when this gets disrupted, periodically you see this stuff shooting into the back of it, okay? And you can often see these things merging in this video up here. Okay, so we've actually seen on this particular sample, which we received in the effects of Neil Crichton Gold, exotic vacuum object impact structures on the end of this communication device, a Marconi style spark discharge type or a spark discharge type radio transmitter. And so this would be, you can see how old it is because it has no plastics involved in the installation. This is just a cotton thread. And it was amazing to find on this thing that was probably late 1800s, the same signatures of spark EVO production. So to the best of my knowledge, this is the earliest device ever shown showing this type of effect. So basically, EVOs are formed by essentially charge separation. You can do that by abrupt dielectric barrier discharge. Tesla used an air gap for a disruptive discharge. This is what Ken Shoulders did, but also what John Hutchison did. Adamenko used a dielectric ceramic barrier, and this has been 100% verified by the US nuclear fusion program. The device was transferred from Kiev in 2015, verified up to 2017, and then is in Brookhaven National Laboratory as part of the US fusion program. So 100% this works. Shear turbulence and helical injection into charge separated fluid. So basically wherever you get these things, and we've looked at various things, Tornado, Windhex by Frank Polivka, our Ultra experiments, which we've done some work on this weekend, Klimov's inflow plasma vortex. There's a European group that is doing something similar with that kind of technology, and the global environmental energy technology of Paul Pantone. You can get this, and we've shown this and replicated what we showed with HHO or a Mars gas on tungsten rod, HHO and an angle through carbon tube by Stankovic in 2019. And Klimov's plasmatron, which was this was formerly secret research, but because Stankovic showed this in 2019, Klimov revealed that work, which we published on our website. And then the Plasmac Colloq model of ball lightning and the protosphere. All of these things, and including the Usharenko effect, I'm looking over my monitor there. Essentially, what you need is an impact of over 5 electron volts for hydrogen isotopes to do this. And as I'll show you later, it takes 2,000 to 4,000 times more energy to create the effect with elements beyond lithium. Okay, so what do we see when you do the charge separation? This is in a Shakhparov experiment, creating topological monopoles. And this is a Mobius strip and I'll say why that's important in a second. But you have positive vortices and anti-vortices, and you have negative anti-vortices and vortices propagating in alternate directions with the high current shock pulse that's going into this Mobius strip. And this leads to the topological monopole, and you'll see the effect in a minute. Interestingly, the same thing is represented on this ancient brass body breastplate from Finland that I took in the museum there in Helsinki last year. Exactly and correctly represented with the flux tube going between the two. Okay, so why did they know that hundreds of years before Christ? This is the effect. You seem to get a projection out in some cases. I would argue that this is the yang. The yang is always brighter because it does matter disassembly. And the yin is darker, but it's still bright because it's doing matter assembly and it extracts energy at a distance. And this is a zero albedo feature. So these are the kind of things that Dubovik was warning against, in my view, where you could give someone cancer with a beam this way, or you could actually stop their heart like Ninel Kuligina did with telekinesis type powers. And you can go and look at it. She stopped the heart of a frog, but she then restarted the heart of a frog. And then one of the researchers came in and said, "Oh, can you do it to me?" And she stopped his heart. And I would believe that she was essentially channeling the energy using this and essentially restarting the heart of the frog by and I would argue that this is chi energy, and we'll get into why that is. Okay, so what is going on in this Mobius strip? This is a Mobius strip. This is a simulation of the Mobius strip on a Tesla graphics card back in the early 2010s. What you have actually is what's called a phase singularity. So here, this is a sort of Penrose staircase, kind of Escher type drawing, and you're going round one way or going down the other way, but you're actually not going up or down. You're effectively staying with the same point. And that's what's called a phase singularity. And two structures that are well known have a phase singularity. One is the Mobius strip done, and the other one is the vortex soliton. And what we are looking at is vortex solitons, but also vortex solitons fractally joining into clusters of vortex solitons. So what is the fractal toroidal moment? So Dubovik established the toroidal moment. What is the fractal toroidal moment? Well, we established what that is. But basically, building on the work of Yakov Zeldovich in 1957, Vladimirovich Dubovik, he established the toroidal moment. And essentially, if you have a magnetic moment coming from this electric current, like you could imagine is in your initial discharge in the plasma guns of what's his name? Bostick, Winston Bostick. If you have at least two of those, which he did, and you have them coming in opposite directions, you end up by producing a toroidal moment. This could not be known to either, or at least it wasn't understood to be known, and he never talked about it within his lifetime to Winston Bostick. It was not known to John Hutchison. It was not known to Ken Shoulders, although Ken Shoulders was getting close as to the implications of what it was without understanding the mass behind it. Okay, so then if you get that toroidal moment structure and you put that in a loop, you end up with a hypertoroidal. This is what it's called in the West. They call it a supertoroidal in Russia, but I call it a fractal toroidal because there's hypermarkets and there's hyper this and there's hyper that and there's super and whatever, but fractal intuitively to me explain the phenomena. I actually, in 2017, there is a subsequent to calling it the fractal toroidal moment, I realized that in 2017, a Russian author in a mainstream journal, I think it was Nature or Science or whatever, they actually called these fractal toroidal structures, they actually called them a fractal current structure. So there's due credit to be given there. Okay, so this was on the Lion device here. And it has this disruption beam that comes down, and it's twisting and fluidizing and twisting this copper oxide here at a temperature well below its melting point. It has a hole in the middle where the matter seems to have collapsed. Here's a much bigger structure. And essentially, this is from Science in 2011. So Science journal, major peer-reviewed journal. This is predicted toroidal moment structure where you have a oxygen atom in the center, and then you have copper and copper and copper and copper, and you get one current loop here and a counter current loop there, and that produces this toroidal moment that comes out here. So this is copper oxide here, and so is this, and so is this. So this is theory published in a mainstream journal. This is the physical manifestation, and you only need two, as presented here, to produce the most basic form of a toroidal moment, and that is what Bostic was doing. To try and convert real fusion in a hydrogen bomb into domestic energy source. Okay, so here it is blown up, and on this basis, in January, in a dream 2018, I came up with this toroidal structure with these vortical kind of driving forces going on with the vortex and the vortex and the anti-vortex structure, and that this would pull something into a point. Not coming out the other side like has been drawn by other people. It is a point. It is a phase singularity. Now you might get a beam coming out the other side, but it's not a symmetrical structure. Okay, you might even get something coming in this side, but it's not this coming out that way, right? And this is it on the HHO on the tungsten that I did in 2019. It's the decompression of the ether at this point is so strong that it's converting, in my view, the tungsten to this strontium here and this cloud, this diamond film here. Remember, carbon is the thing that this system likes to produce most. It's been observed by many authors, Takaaki Matsumoto, by S.V. Adamenko, by Mikhail Solin in their respective patents and proven works. And so this is a carbon film here, and in here, in the vortex and the anti-vortex, show it that it's one on top of the other. You get all of this typical stellar synthesis almost instantaneously produced by HHO. That is a charge-separated material burning in a plasma in a vortex, producing a magnetohydrodynamic structure that is then producing this fractal toroidal moment that is leading to the destructive disruption beam. Okay, so here's a whole bunch of different things arranged here on the paper. This is the hydrodynamic structure I showed you earlier. This is the hydrodynamic structure interacting with the aluminium, and it produces the Om shape, which is what the Sanskrit and the first religion would tell you is the way to create things. It's the most important thing. And here is a ball lightning produced in a Hank Urine experiment, which I imaged, where it impacted onto a fused quartz, and you've got the caduceus beam. This is where the disruption beam comes down, or arguably goes back in. This is on a piece of aluminium foil. On one side, you have lighter element, boron, made by extracting oxygen effectively from the aluminium. And over here, you have, with this spiral galaxy structure here, you have calcium synthesized, which some isotopes of calcium are oxygen plus aluminium. There's no boron on this side, and there's no calcium on this side. This is the yang, it's breaking matter apart. This is the yin, it's assembling matter. It is exactly and precisely the yin-yang, which is how another belief structure believes that everything is made, and so on. Okay, so this is the Sothic triangle. The Sothic triangle is always associated with the Ankh, and the Ankh is this part across here, and everything below the loop, the sort of top of the Ankh, which was changed in the Christian cross, that is, according to the Egyptians, the secret to all hidden technology, and it is, by the way, the structure of a topological monopole. Okay, so how did I arrive the fractal toroidal structure? Well, this is indium foil exposed to cavitation structures with very similar structures observed in Matsumoto. But I found at least 3 different quantization levels. In fact, I found 4, but let's start at the n-2. You have a yang force here. This is an outie. You have a yin force here. This is an innie. And those, if you rotate those 90 degrees orthogonally to that, and you can produce this structure, which is viewed from the side. You can see the apple core going through the torus here. This is from the top. This is a D4D structure here. This is a D4D structure here. And this here, if you rotate this 90 degrees, it goes around here. This has 48 subdivisions, which we later found out is likely the maximum that you can have in one of these structures. This is all on a Hutchison aluminium sample that was produced in 2007. Okay, so this is the fractal toroidal structure that I produced. It is exactly and precisely a wheel within a wheel within a wheel, a wheel within a wheel within a wheel. Okay, and these bind together with their toroidal moment. I initially thought it was their electric and magnetic fields, but I believe it's now the toroidal moment. And it's self-similar, so you can imagine that the third orthogonal direction in the XYZ axis, when you get down to this point, is effectively the same as the overall structure. And I argued at the time that I published this on 17th of February 2020 that this probably is the structure of the physical vacuum, and this would lead to all kinds of things like teleportation and faster light travel. I will go into those at a later time. Okay. So I don't know whether this will play, but you should be able to see the video. There's two concepts here to be able to understand this. One. So, of course, everyone knows that as you pull in from the center, if you've been on a roundabout, your angular velocity goes up and so on. But anyway, okay, so using those two principles, if we have a phase singularity at the center here, now bearing in mind in these fractal toroidal structures, the matter does not go through there, it gets cohered, it gets phase synchronized, and it becomes effectively a Bose-Einstein condensate. So if you can imagine these electrons are coming in here, they're not electrons, they're coins. But if they were electrons, they have Pauli exclusion principle. So as they come into the phase singularity, if they get closer than 180 degrees out of phase, they will push it forward and they will end up 180 degrees out of phase, then leading to a Cooper pairs and a condensate. So this effectively would lead to essentially unlimited amounts of electrons to go into a defined radius. And this was, I think it's Perevostikov in 2009, showed that this, when you did the maths on this, it produced a rotor with an intense magnetic core that then is equivalent to the predicted Dirac monopole. Anyway, it looks like this. We've shown that our model, which I will show you in 3D in a minute, actually produces better results than Aalto's mathematical model, whatever they did for their topological monopole. But you have the spin down section, the spin horizontal, and the spin up. And the actual monopole location is effectively at this point, okay? So this is theoretical. They actually showed this in 2015, but we've actually physically applied these things in our experiments. So the D4D ratio was first mentioned here by Bostic and Nardi in kind of like some of the conclusion research that was published here in Physical Review A in 1980. And here you can see these spoked structures, impact marks, which they say are large D4D rings with spokes under the surface. So that's actually impregnating into the surface and leaving this mark. Well, it's a bit similar to John Archibald Wheeler's Geon, which has a gravitational azimuth through the center. This is where I'm arguing that the gravitational beam travels through. And here is a coherent matter structure that they thought. They got very excited on the 28th of April 2021 announcing this, but we had already published some things a lot more interesting in my view. But anyway, thanks to Nick Moore for sending me this. So here are some impact marks of ball lightning. I'm going to show you in a minute how we produced these structures. And they are found on the anode sheath here in Henk-Uren's Vega experiment. And if I click this, you'll actually find that the overall fractal toroidal structure lines up with one of the impact marks, which has a copper core. And you can see it here. This is a 6-order structure. This is a 4-order structure. This is a multi-order structure. They have these fuzzy edges to them. I'll talk about those in the future, but anyway, we'll come to it. So here we go. And I'm just going to zoom into this structure, and you'll see the non-radiating boundary. or you won't. Didn't show that. I don't know why I didn't show that. Maybe I don't have it on this video. Sorry, that's annoying. Okay. Okay. All right. Well, anyway, you'll see it later on. Okay. Obviously wasn't on this video, but essentially you have this core structure that I just showed you, and it has this non-radiating boundary around the outside, which is a spherical, and this is why you get these craft which are going to be spherical, and that's the only choice that nature gives you if you're going to do it correctly. Anyway, having predicted this 2D section and then predicted the 3D section from deriving it from a John Hutchison sample, and you know, these are what Tom Bearden was calling a monopole. We then found the collapse wave functions that come out of these things, which are always calcium oxide. Calcium is the highest pure alpha conjugate nuclei, and oxygen, of course, is quad alpha. So you have dec alpha and quad alpha coming together. Both calcium and oxygen in basically all their forms, and calcium oxide, are paramagnetic. So they can live within these highly magnetic structures. The copper here and the carbon orbit around the outside because both copper and carbon are diamagnetic. Okay, so these are various structures. This is 36. This, if it would be a full circle, would be 48, just like the structure. And you can see that this one has a substructure of 6. This has a substructure of 3. This likely has a substructure of 2, which is the minimum. This looks like it's a truncated hexagon. This is a substructure of 6 going on here. So I sent the time I found these subsequent to this image here, which I found on the train home from the SEM, looking at a very large 8K image. And I go, you're kidding me, it's there. Anyway, a few days later, I shared this, and this. The Russian community had already seen this. They'd already seen this. But I shared this, and immediately they threw in the towel, and they started sharing this work, which was done in the classified Soviet energetics program here. And I shared it. It's called The Bagel Game. You can go and look at the translation at remoteview.icu. And they described exactly and precisely how I had described this fractal toroidal structure would be bound together, although it's not, in my view, correct. And they also said that this is probably a structure of the universe. And in fact, that in that paper, I learned for the first time that the fractal toroidal structure is the only fractal structure that would fill all of space-time and leave no gaps or branches. So there's only one possible structure that can fill all of space-time with no gaps and branches, and it is a fractal toroidal structure. Okay. So in a ball lightning, in an experiment by Henk Uren again, 2 iron plates spaced with some copper pipes with some zinc to get some pyroelectric and piezoelectric things going along with their oxides. It produced a ball lightning. We have it on video where this experiment is going on, and like that, in a slap of the hand, this ball lightning makes this section of this copper pipe disappear, but you always find the most interesting things on the boundary. And on the boundary, we found a 2-order structure with a sort of a spiral coming in, a 3-order structure with a spiral coming in, a 4-order structure with no spiral coming in. Okay, so with 2 or 3, you see a spiral. A 4. I explained this in detail, how this occurs and why the 4-order spiral sub n-1 structure does not produce a spiral. This starts to produce a focused beam that comes out of here. 5 produces a focused beam. 6 is absolutely optimal. It produces a very, very self-contained structure, and I believe this is why nature likes to produce hexagons everywhere, and you're going to see that at the end of this presentation. And here in this structure, this is 8, and when you've got 8, you can start to see substructures within inside. Okay, so 6 is absolutely optimal. I didn't actually find a 7, which is interesting. So if you look here, this is a 2-order structure, and what happens when you've got 2 is these disruption beams that I showed you at the beginning coming out of the stuff on the work of Neil Crichton Gold. They puncture through the non-radiating boundary. This is the non-radiating boundary. So it produces a spiral, like a spiral galaxy. So you get 2-arm spiral galaxies, you get 3-arm spiral galaxies. But when you start to get 4, you still maybe get a spiral. But after that, it really starts to become a ring galaxy. Okay, so it works on every scale, but when the reason is I don't show it in this presentation, but you can go and see it in another presentation I call Flower of Life. When you have a 4-order structure with 4-order structures, the disruption beams, which is where the Sothic triangle disruption zone interacts with the torus on the D4D ratio above, it bleeds out, but it bleeds out in the case of 4 and above into the overall non-radiating boundary of the subtor at the level below, and this goes on. When you actually go up to 5 and 6, particularly with 6, then the disruption beams that come out of the n-1 or n- whatever, they actually go into the apple, and so it's extremely stable for that reason. You can go and look at that presentation. So this is the tornadic beam on the right here, coming out of one of these structures, which you'll see later in the presentation, and it makes the steel, this is 3 millimeters thick, this mild steel, glow orange and then unglow orange very, very quickly. So it's literally, in my view, massively yanking electrons out right the way through the material. And it's making it glow orange, not necessarily thermally, but it is obviously hot to a degree. And it's making it glow. So basically, the effect of the fractal toroidal moment and this disruption beam on matter is that it changes all forms of electron interactions. And if you get overexcitement of condensed matter, they result in anomalous glowing and transmutations over time. So this is the sort of thing that was happening in the John Hutchison system. You get non-thermal plasticity and material flow. It's not molten, it's cold. You get critical fragmentation, particularly where you've got magnetic materials, iron, for instance, because it's ferromagnetic, the monopoles, they can't move to each other. They grow in situ, and then their non-radiating boundary, intense magnetic fields grow and grow and grow until the non-radiating, there's no electromagnetism, but they are fractally growing. And when this go to the next quantization level, their non-radiating boundaries interact, and there's literally no matter on Earth that can prevent that from pushing that iron, for instance, apart. Okay, so you get critical fragmentation, production, capture, and coherence of matter waves. So we showed some coherent matter waves at the beginning. Go and look at the 2013 patent of Lockheed Martin, systems of methods for producing coherent matter waves. And then you get collapse of matter waves into different configurations. And I've showed you these fractal torus of calcium oxide just recently. Okay. The effect of fractal toroidal motion on moment on electron interactions is to start with, at Casimir forces, they modify a modification of the electromagnetic vacuum fluctuations that's what Casimir forces are. So they modify these. They will reduce van der Waals forces or change them, either strengthening or, some people argue these are similar. Polar bonding, such as between water molecules. So, for instance, a ball lightning going into water can make it boil, in inverted commas, and they do energy calculations on that. But I am of the belief that it actually is interacting with the polar bonding, and it just makes the water fall apart into water gas. It's not thermal boiling. And then you have ionic bonding. We've shown that materials are fall apart, like silicon dioxide and aluminium oxide. Those have ionic bonding. The next one up is covalent bonding in terms of strength. And so diamond is a covalent bond, and also is silicon nitride, carborundum, or silicon carbide rather. And these were the two elements or compounds that Tesla found were most suitable for the carbon button light bulb, and I believe that's because they are covalent. Boron nitride similarly would be most resistant to this, but at some point it would always destroy the matter, and then or disassemble it. And then the last one is metallic. Now this isn't stronger than the other ones, it's just different. It's weird, and this is between crystal grains and electrons shared throughout the metal. So the most weak point is along the crystal grains. So if you look at Jack Houck's telekinesis spoon bending parties, when they analyzed the metal that was bent, they found that the metal had slipped along the crystal grain boundaries, and that is because it's weakest. And so in that way, you can manipulate it that way. But if you pump it up to a certain level, then it'll jellify or fracture, depending on whether it's paramagnetic or ferromagnetic. The material, there will be different behaviors. Okay, so there's some applications here: efficient material processing, cutting, grinding, gasification, cold forming and molding of materials, element creation, transformation, including remediation of nuclear waste, release of hidden energy within matter. This is specific to a 1992 CIA release in 2017 of Russian work, where they're talking about cold fusion being just an aspect of this releasing of hidden energy within matter. We're going to talk about what that is. Condensed matter conversion to other forms of energy, and we're working on a direct matter to energy drive using the disassembly of baryons into electrons and using the energy that comes out of that. Communication without barriers, transmission of large power over thin wires, and I'll show you how that's working, and shielding and propulsion stuff. I could play this clip by Tom Bearden, but he's actually talking about the sample that I want to show you, new analysis that we've done from John Hutchison's 1982 sample. Challenges in LENR in general is that you get non-thermal but yellow-orange glowing reactor containment failures. You get false radiation signals given and warnings given by various people. You get fake neutrons and fake photons, which fool people into thinking they're seeing things which they're not. You get semiconductor interference, specifically on NP junctions. So this affects anything that relies on quantum effects, so it actually affects consciousness as well. And this is probably how John Hutchison, for instance, was able to know that his devices were in the sweet spot, because he's, let's call it electrosensitive, but he's actually sensitive to these toroidal moment, the scalar and vector potentials propagating from these large clusters. And so he knows how to manipulate that. Electromagnetic pulses, EMPs, and traveling cluster damage to electronics. We've seen all of this in our work. And anything using Josephson effects, such as superconducting. So this is basically how you detect these things, squids, quantum qubits, and so on. Okay. In terms of a conversation between Brett Weinstein and Hal Puthoff, this was talking about how you go faster than light, and he's talking about exactly the phase singularity, and that leads to the Aharonov bomb effect, which occurs, and the Aharonov bomb effect you will see occurs in the center of these fractal toroidal structures. Hal responds by not really answering the question. He says, or joining the debate, he just says, and you can go way beyond that. This is the ability to produce this phase singularity that may allow for Aharonov bomb effect and changing the dielectric constant, the physical vacuum. He says, so there are all kinds of toroidal geometries, for example, where you have no electromagnetic fields whatsoever, but you have strong vector scalar fields. And since you have no Lorentz force in the absence of EMB, then how can you detect them? Well, you detect them by any kind of quantum detector. You know, I was kind of annoyed because I kind of worked this out, and then he says that. But to be fair, Alexander Parkhomov was using NP junctions in a certain way to be able to detect that. And also you've got Kozarev's bridge as well. That can detect phase shifts, and can detect the vector and scalar potential. So there's a whole engineering approach concerning which I have 2 patents, by the way, and I've started a new company that involves only dealing with vector and scalar potentials. What are that? Well, just 9 months or so after he handed over the Psychic Spy program to Science Applications International Corporation in 1992, he applies for this patent in 1993, where he has a coil and a countercoil with an electric field, and by oscillating these, he produces what? He produces a toroidal moment, and this is his communication device, and he uses a Josephson junction at the detection end. I have said this affects me, these experiments affect me during experimentation. I've observed that, and I've commented it on live. I suspected whatever was going on before I knew what might be going on was working on the same way that consciousness works. And in June 2000, June the 15th, published in Nature Human Behavior, they showed using functional magnetic resonance imaging that there are magnetic vortices and counter vortices in a brain when it's conscious doing cognitive functions. And if you have a magnetic vortex and an anti-vortex, 100% certainly that produces a toroidal moment. So it is certain that toroidal moments are produced by the brain, which means the brains can be influenced by toroidal moments, which means we can both sense exotic vacuum objects and we can be manipulated by exotic vacuum objects. And this has implications for precisely understanding how John Hutchison did what he did and how you would psychokinetically interact with drive systems and propulsion systems and any other kind of systems that use these fractal toroidal electromagnetic structures. Okay, so the transmission of many kilowatts over 8 micron wire, this was shown also to Tom Beard in 1992. You could call this cold electricity. Matsumoto rediscovered this in his own way, and it's published in his book Steps to the Discovery of Electronuclear Collapse in 2000. But essentially it is exactly this structure, a toroidal moment structure, which carries, because it's fractal, it can carry 1 ion for every 100,000 electrons, and it's just using the potential along the wire as a guide to transmit the energy. And so they showed an 8 micron wire transmitting, I think it was 25 or 40 something, I think it was 25 kilowatts of power down an 8 micron wire. Okay, so it's demonstrated Tom Bearden's team in 1992. It was discovered independently by Matsumoto in 1996. It was published again on a Russian television program in 2000. And Shishkin argues that you could also do this transmission of energy over a laser light, effectively creating a wire in the air. And unfortunately, that allows for ridiculously dangerous weapons. So the vortex spiral that you get, because I believe a tornado is exactly the same toroidal moment structure at the top, the disruption beam comes down. And what you're seeing in this water column, I argue, is the disruption beam interacting with the water here and causing the polar molecules of the water to convert into water gas, and it's lifting the water gas up here. It lifts up here. The reason you see these smoke flares coming off at an angle and they're not representing what you would imagine would be the extremely fast winds represented by the dark water here is because there is possibly relic neutrinos here coming in, and they are effectively affecting the ability of electrons to behave normally, and there is a event horizon here by which there is zero friction between the fast flowing air here and the ordinary flowing air there. And we are currently replicating this device by Frank Polevko, which has a disruption area here, and it will also have disruption areas in the N-1 tour. We haven't really explored what we need to, which is increasing the temperature above the boiling point of water and introducing the charge separation in there. And so that is a work in progress. But this can turn and dehydrate materials with bizarre efficiencies. Okay, so, and this again is exactly the sacred geometry. This is literally the Vesica Pisces, and it is also at this level the Chi, which is the life force, the prana, the spiritual energy, and the Rho coming through the center. Rho is density with torsion. So whoever made those Macedonian coins 400 years before Christ was born and called them Thunderbolt coins because they represented this structure on those coinage. Now, obviously, their means of numeration, the numismic means of trade, knew, or someone knew that informed them what ball lightning was, and this is effectively ball lightning. Okay, in 1979, my father showed me at least 3, maybe 4 lights in the sky going blip, zip, 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 boop, and disappearing. I've discussed this on my blog. You can go and see the interview there. Long before I got to where I am in my understanding now, but I later found that on NASA's actual website, they have a paper from A.C. Holt looking at an interplanetary drive system. And when you look at this, you have a phase singularity in the center where the magnetic reconnection causes a vortex to be centered, okay? And this exactly and precisely is a toroidal moment structure. So they are saying that an interplanetary drive would use exactly this process. It's exactly the same thing. This is an image from Maury King. He said in his work, having met Ken Shoulders, sadly I never got to meet him, but he said that firing an EVO through a hole was produced the most powerful thing that he had ever observed. He called it the EVO water gun. And that's very interesting to me, because if you take this process of wire discharge machining, you actually have not sparks. They don't create an arc. They create it just below an arc. And so my argument was that this is doing exactly the same thing. It's producing these non-radiating boundaries that disrupts the metal. And using a brass wire, you can even cut through silicon carbide. So this is the original 300 or so. This is the scale down here, 300, so it's 250 micron or so wide brass wire. And I went to visit a facility that has this. I took some before material. I took some after material. I've got a lot more to look at. But it literally took me something like 90 seconds to find the same structure. You have a bright sphere here, a dark sphere here. So this is bright, this is heavy, this would be the yin, this would be the yang. They're exactly spheres. And then you have this disruption beam. It's always a wave. And then you have, like you have on the Om symbol, a little curve off to one side representing the structure here. This is the guts of a ball lightning that blew up, but these curved sections taken out here are the result of the interaction, probably of the apple with the cutting wire, but the same thing would be going on with it within the metal. So this is a beautiful demonstration that people can explore the process of how this works, and it effectively is using the principle of exotic vacuum objects going through a capillary, because it basically it's a very fine hole, and that they throw a water jet through there as it's at high pressure as it's doing this discharging, and it's not an arc. It's not an arc. So here the same kind of process is going on with this steel cutting. And it's very good for cutting carbon steel, because carbon doesn't want to transmute and the iron doesn't want to transmute. So this is an HHO generator in China, and you can cut through 0.5 meter or even possibly even 1 meter of steel. And the reason is because of the hydrodynamics. As it's coming in, it produces the toroidal vortex, which starts self-assembling the coherent matter, and then the coherent matter can cut through very, very cleanly. So what we demonstrated here with HHO in form of Mars gas on tungsten, instantaneously transmuting the tungsten here, is what can be achieved also with HHO. So a lot of the magic of HHO is because it produces, in my view, coherent matter, and it uses that. It then leads to this fractal toroidal moment, and the ability of this front end here to literally destroy any matter that it comes into contact with. And in fact, Ken Shoulders said in one specific paper that based on, if you were to try and compress, for instance, alumina or silicon dioxide or whatever, some of these refractory ceramics, it would be the equivalent of a pounds per square inch of 200,000 pounds per square inch. Now, if you put that in context, the Raptor 3 of SpaceX, I think its chamber pressure is 5,100 pounds per square inch. So absolutely massive levels of potential for propulsion. Okay. So here I told you about metal forming. This is what heat does to metal. This is This is what let me see if I can get that right. This is what heat does to metal. This is what compression does to metal, and this is what deformation, bending does to metal. You're shifting the association of an electron in the sea of electrons that moves around between the nuclei, so that the nuclei can shift from one location to another. Well, this is HHO, which you just saw transmuting tungsten. And when it transmuted tungsten's melting at 3,000 and whatever degrees centigrade. Well, I thought I'd try something that doesn't auto burn in air, but has a very low melting point. I chose indium foil with this HHO, which melts at 156.6 degrees centigrade, and it did not melt. No, what happened when I put the jet on there is it turned to a rubber sheet. It turned to a rubber sheet. And what happened then is it started to transmute the material as the clusters built up in there. And when it started to synthesize things like carbon, which we see on the SEM, it then thermally heated up and then melted and dripped down. So I believe that's the same thing that has occurred when when John Hutchison was working with Alec Pizarro, and he was building up the monopoles, the charge clusters inside this aluminium block, which was glowing yellow-orange. And then they turned off the electromagnetics, and he went over and he went to feel it. It wasn't glowing yellow-orange anymore. He went to pick it up, and he could feel that it was cold. And when he went to put his hand in it, he left these fingerprint marks in there. So we've replicated John Hutchison with this experiment by the coherent matter that's produced by HHO, and it's just it's the same phenomena. Just one's kind of like non-contact, and this is a little bit more involved. So you should listen to John Wheeler here. He talks about how when you get these structures, effectively you would create a gravitational wave, and then if you take multiple of these structures and make a fractal structure, you would end up with a gravitational wave that pinches in on itself and then it allows for collapse. So if you just read this listen to this section from John Wheeler, you will have a good understanding of how matter collapse can occur into these situations, but we won't go into that. Don't need to talk about this, but that was what I showed earlier. Oxygen goes into the center, carbon goes on the outside. Oxygen, why? Because it's paramagnetic. Carbon, because it's diamagnetic. The same structure occurs in a collapsing water bubble. As you can see here, this is the non-radiating boundary. The bubble expands to the size of the non-radiating boundary, which is quite wonderful to see, and so on. This is our proposed path to matter to energy conversion. When you look at this with your eyes, all you see at the end of this pipe is a full or nearly a full sphere, like a ball lightning. But because of the sensitivity adjustment on the camera used to look at this, we can look through the outer sphere, the non-radiating boundary, and we can literally see the torus, the torus, and that has this tornadic beam that comes down into the tube, and it's that base of that tornadic beam that is interacting with the metal on the outside where you saw that orange spot moving around. So you can imagine a tornado moving around, and when you see this flash, it's where it's destabilized and it shoots off from this effective cathode to the anode, leaving those different levels of fractal toroidal structures that we observed on the fused quartz in the Henk-Uren experiment. So we will be using this with a method proposed by Mikhail Solin for direct electricity production. It's not that this is spinning itself, it's that it spins at incredible velocities, charged particles around it, and that allows us to produce electricity through induction. So this allows to consume matter and convert the energy contained within that matter into angular momentum, and then to convert that through induction into electricity generation. So this is matter to energy conversion. Okay, so that is our proposed method. We might stress it with a magnetic field like the Chukhanov method, but there we go. So just to clarify here, the toroidal moment produces the Aharonov-Bohm effect. And the mass for this was already done by Afanasyev and Dubovik, the sadly departed researcher that both discovered the toroidal moment and gave us this paper in, I think, 1992 or 3. And this was in a paper called Some Remarkable Charge Current Configurations, published by the Joint Institute for Nuclear Research in Dubna. Okay, it's actually quite embarrassing how far the Russians are ahead of this. But in fact, it says here in Figure 13 in this paper, the magnetic time-dependent Aharonov-Bohm effect for charge configuration discussed in the text. The time-dependent magnetic flux differs from zero only inside the impenetrable torus T. Outside the T, the dependent of time electric strength E differs from zero only inside the torus hole. Okay. So you have something in here which is unique, which is at the n-1 level, and you have also in the hole. Okay, this is entirely consistent with all of the physical observations we have observed. So effectively, spin material is good food for this system, but of course, if you ionize something, it can play a role. Non-spin bosonic nuclei get kicked out, so often in these reactions you see production of Helium, this is the product from stars. I believe stars are using the same process, not the process we've all been led to believe. If you look at most of the interstellar dust, it's carbon, and that's why I think the same process is what's causing that interstellar dust, and that is the product that this process likes to produce most. And oxygen is the most abundant element in the Earth's crust by far. It's like practically half of the Earth's crust, and it's specifically this isotope. And so that's why I believe that's synthesized. Okay, so now Nikola Tesla absolutely, certainly, and clearly knew this. Why? Because this is his photo from the 1930s, where he was promoting the weapon to end all wars. He said it produced an invisible Chinese wall, Chi being the life force, and it's exactly what it really does. And in it, he has a tie with the symbol phi on it, and he has exactly the sacred geometry cut off at the top of the disruption area. So this is another Henk-Uren experiment. It has exactly and precisely the sacred geometry structure on it, and it has a wormhole. The matter is pushed into a wormhole, just as said by Takaaki Matsumoto. Only inside this black circle, which is just outside this white circle, do you see the deformation of the brass here. And the material is punched into a wormhole, comes through and comes out here and punches a hole through here. It has this disruption zone down here, and because of its tornadic structure, it's actually a triangular shape, and we're going to look into that in a minute. And this is the first time this has ever been disclosed. Okay, so thank you for giving me the opportunity here. The material that goes through here, this hole here, gets deposited exactly in the sacred geometry structure with the golden, Sothic triangle going into the center here. This is exactly the structure you get in a tornado, in a vortex soliton like this one here. And again, with Tesla's device here, the bit that gets disrupted, as in our experiments, is where he cut off the top of this flower pot. This is the Visa Capices cut off at the point that the material comes into the bottom. And if you actually look at this going down to the bottom, he's actually got exactly the right proportions, and he has 4 supports. You need a minimum of 4 to make a stable beam that comes down. Absolutely, 100%, Nikola Tesla knew exactly how this works. Okay, now if I go on to the next slide, it's what I call the cardioid infarction. We're looking at what we just showed you here, but just outside with a more crummy camera. You can see the subtors here, and this is where the brass is laid down. The material is taken from here, it goes through a hole, and then comes out of here and gets deposited here. Okay. This is some close-up of part of the structure here. So this little part here is this vortex here. You have a hexagonal or a geometric structure here with a vertical pattern here. That is here. I haven't shared, but will do in the coming months, the SEM analysis of here. Inside certain parts of the sacred geometry structure, you see incredible things, but not outside, only inside. And of course, this is exactly the model of the Great Pyramid. Okay. So here's another close-up, and so on the outside. So what we're going to look at is the disruption on this area here. Now, outside of here, this is literally and precisely and only brushed brass. But inside this triangular area, you're going to see something really, frankly, amazing. Okay, this is it. So in this area here, looking at the SEM in Prague on the 17th of August last year, and this was shared a few days later in my presentation in Szczecin as one of the backgrounds. You've actually already seen this in this presentation. There is a hexagonal array with a point focus, a hexagonal array, okay, exactly and precisely equivalent to that predicted, I think, in the 1873, I think, by James Clerk Maxwell as a model for the ether. And so I believe that what's going through here is coherent matter, but it's more precisely coherent matter constructed of whatever the ether is, and it's producing disruption. This is where the disruption beam is in this triangle. This is where the subterranean unfinished, as it's called, layer of the Great Pyramid is, and that is here. Outside of this area, it's straight brushed aluminium. Inside of this, you have this deposit, whatever that is, and I know what that is when I go back through the data, but you have this hexagonal array. Now, the interesting thing is here, are you ready for this? This is boom 2. This is John Hutchison's sample from 1982. This is another sample, I believe, well, from between 1979 and 1982. This is also a sample that's never been analyzed before, from between 1979 and 1982. This is the end of a sample I asked George Hathaway to let me have. Thank you very much to George Hathaway for both of these samples. I will show you in a presentation specifically on this that we have imaged this and exactly replicated what all other people have observed when they've observed this material from John Hutchison. And it is these black spots. These similar kind of black spots are being seen in other research in Japan in cold fusion reactors. And this is effectively ferrosilicon. It's not so much the silicon content that's so interesting to me. It's the fact that also on this crystal grain here, you actually have regularly spaced, like a sapphire anode, you have these toroidal circular structures where the material is consumed, and it's obviously split. If you look at the Venetian blind-like look of the split of this material, this is exactly and precisely as described by Tom Bearden in a video recorded in the 1990s. 100%. There is no fakery going on with what was observed by multiple labs across the world, but in these samples produced by John Hutchison. In this sample, and I will go into this in more detail with the SEM at a later time, but you see the same kind of thing going on as you see here and here, these cellular-like structures. Now, you do get this with aluminium oxide, and this is an aluminium or alloy. But in the center of these structures, these are iron-rich in the center of each of these structures. That shouldn't happen if you were just getting aluminium oxide. You shouldn't get iron forming in the center of these. And moreover, this structure, which is in the center of lots of other centers, structures, this is copper rich. This is copper rich. Okay, so it would appear that in the center of these smaller structures, it's producing iron, and in the center of a much larger structure, it's producing copper. Copper is heavier than iron. So you can see how, as you build these fractal structures, the bigger they get, the more intense the fractal toroidal phase singularity at the center gets produced, and you end up by producing heavier and heavier elements. And I believe that this is a working model for what actually are black holes. At the same case, we have some structures in the center of these. Now, I want to do a direct comparison between this structure and this structure. This structure produced in 2022, imaged in August 2023. This structure produced circa 1980 and analyzed in the same microscope session. I think it was on the same day I looked at both of these. This is what you see. The distance between the monopole structures on the brass sample from 2022, produced by Henk Uren and imaged on behalf of donors of the MFMP by my good self in Prague, is almost identical to that of the monopole structures on the Hutchison sample produced in ferrosilicon in 1980. I believe that in multiple ways we have replicated effects observed by John Hutchison. Here is a close-up. So these are scaled to exactly the same scale. And this is exactly the same piece of geometry, and I just dragged it down and offset it. Okay? This, the brass here does not look anything like this, but only in this disruptive point, this exact and precise disruption point. And I will come on to describe how the same thing can have a much larger area where you would get these structures forming within material in other work and in a book. Certainly the labs that looked at this, the Max Planck Institute, George Hathaway, some of the national labs, they had not observed this effect before. So, there we go. Here again, this is looking at the brass sample of Henk Uren. And here you can see I noticed this pattern on the top where things seem to be vectoring in with triangular sections. Okay, there's actually multiple of them, and I wanted to compare the size of this vortex structure with the bit in the center in this hexagonal array compared to the deposit that's on the top, and effectively they are the same scale structures. So lastly, I want to refer to the work of Binger and Huang. You can go and look at this, but I image that in the exact place that I am in now on 18th of March 2024. And the idea is that minimally you need a wheel within a wheel within a wheel. Okay, well, the disruption area of this oval structure is exactly at the precise area that you have a hole of material that is consumed here. Okay, the center of the two n-1, sorry, the n-tor level is exactly and precisely where you see these two disks. The apple shape here, this crashed in from the side here, and it's kind of got this distorted like skull shape here. But anyway, it's like a scream. But what happens is that in this is the non-radiating boundary area, and this is the weak point, because this is the area where things come in and come out. I can show you many, many examples of spheres produced where material is ejected from here by both myself and other authors, by Slobodan Stankovic in 2019, and also by Takaaki Matsumoto in the 1990s. Okay, so this is where things come out, and we've seen this in many, many cases, but in this case it's very visceral, because the two wheels that would have been forming this structure in the n-1 have come out, and they are here. Okay, and this one has broken and it's spilled out two wheels. It's left a shadow here on this one, but we've got the sub-tor here. So this is the n-2 tor. This is the n-2 footprint, like the footprints we saw on the Hutchison sample from 2007. This is the n-1, which is ruptured, spilling its guts here. And this is an n-1. And those two were originally here. And those are exactly and precisely the shape of this part of the fractal toroidal structure. Okay, so, and from the top of the apple to the midpoint where the gravitational force is strongest in the center of this toroidal structure. And then from this to the center of the disruption zone, thank you to Tony Yaboni. And this would be true of all fractal Tor substructures. This is the golden ratio. I believe that this is the reason why matter organizes in the way that it does, both in spirals, triangles, and gold ratios. And we see this in almost every experiment we look at. So lastly, the plasmoid. This is the apples, two apples on a very large structure. I've actually got this at 8,000 pixels by 8,000 pixels. So this we can publish this at wall size at very high resolution DPI. But you have the oid spiral anti-vortex here and the oid spiral vortex here. These are a pair, and together they make an n-level torus structure, and there will be a disruption beam coming down here. We have unimaginable numbers of evidence of this. We can share samples with labs that agree to doing material transfer agreements where they say precisely what they're going to do to analyze it, the time frame they're going to do it in it, and commit to being open about all of the analysis. And I will educate them as how to record live their analysis sessions so they can't fake anything, right? So we have many meters of this material in Taiwan, produced by a 50-year professor of the top university in Taiwan, Professor Binger Huang. And he never expected this to be in here. I could not have possibly expected this level of data to verify the effect. This is repeatable. It can be done by children from the age of 3, but I think you'd need to be the age of 5 to repeat this in an ultrasonic tank. And it shows the principle of the yin-yang. This is the yin-yang, and inside the yin-yang you have a yin-yang, and inside that yin-yang you have a yin-yang. So I would encourage everyone to join me at the bit.ly/Cosmic Summit, where you will be able to spend quite a lot of time asking me any questions you like. I hope to bring some samples, and you can see those too. And so this is occurring next month in North Carolina. And with that, I will say thank you very much for your time. And I will say again, thank you for the gift that was given to the world by Vladimirovich Dubovik in 1967 that we are now just starting to understand and utilize in practical technology.
That's amazing. Bob, thank you. Thank you, thank you, thank you. So let me do this. I want to take down the screen presentation for just a moment. I'm going to put everybody on stage. We need to give Mr. Bob Greenyer an enormous applause. Bob, thank you. Thank you. And for those who don't know, Bob, you could probably easily do a presentation 3 times that long, and the amount of data and the quality of data would be just as high all the way through. So you have tons and tons and tons of data going on there.
I could probably do an 8-hour presentation on the stuff that we got the last 2 days.
You know, it's interesting. I'll tell you, if it's okay, I want to put up real quick. I have a few slides. I have some Searl stuff that I wanted to show the audience too. But here, let me present. I wanted to share this one though. So this was when you were talking about things. This is a story. The original was PDF. Proton 21 solid state nuclear fusion. You guys can all look this up. It's on Medium. Just look up Tim Ventura Medium Proton 21. I would urge you to look up everything that Bob has showed you. Look up Bob's thing. I'm going to take that down. So in this one, Proton 21, they found a black spot. They were using a proton beam doing nucleosynthesis work, and they kept putting particles into it, and they said it ate everything they threw at it. It was either protons or electrons. And
so actually, I can speak to that because your interview was absolutely seminal in my understanding. So I have to give you a big shout out, Tim.
Okay.
And I actually presented that data in Russia to the Russians in 2018 in Sochi. And that's when I revealed the first third of my original O-Day slide deck. And essentially what they had is they had a secondary ion mass spectrometer, and they had one of these accretion disks. So if you don't know about the Adamenko experiments, they would take a metal pin that they would made out of ultra pure material. Typically it would be copper, but they tried all of the metals. And then they would have, say, an equivalent disk of, say, copper. And then they would have a 300 joule discharge that they would go through a dielectric barrier discharge. And by that, what you do is you build up the electrostatic pressure behind it, and then it has the breakdown. So you get an instantaneous cascade. And so you get this instant shocking pulse, which was key to Tesla's approach to dealing with matter transformation. And that would hit and condense onto this pin. So all of that instantaneous electron flux would go into the head of the pin of that, and you would literally get it peeling back like a banana. And then you would get these ejecta coming out radially from that pin, and it would interact with the material. Now, in his patent in 2003, he had showed a hollow iron-rich crenellated sphere. And in an interview in Ukrainian news media in 2005, he said that he predicts that the nuclear reactions occur in there and is due to a dense cluster of dark matter that forms in there. But what he said was, in specific reference to that thing that you've just talked about there, under the secondary ion mass spectrometer, what you do is you have a primary ion. You know, it's a heavy ion typically that you don't expect to be in your sample, and you fire that into your sample, and it spillates. It smashes off a load of ions that then come into a drift tube, and you measure the different masses. Well, what he found was he was firing these primary ions in, and he wasn't seeing any secondary ions on. Well, he turned off the power, and there's a photon multiplier on the top. It's like it gives you this green phosphorescent look. And what he saw was in the place that they were firing the ions, there was this exponential decay, and they repeated this something like 12 times. Okay, and then what they found was they weren't even seeing the primary ions. The actual ions they were firing in were disappearing as well. So basically no matter was coming out of this, but light was, a bit like you might have on an event horizon of a black hole. And then they did further experiments around the outside. They found subquanta around the outside where they had the same effect occurring. And this points to a phase singularity in the center and regular phase singularities around the outside. That is a fractal toroidal structure.
Yeah. Yeah. Well, so Bob, actually, why don't is it okay to put the slide back up with the summit? Maybe you should put the slide back up.
Yeah,
just so
sure,
people can see that.
absolutely. Let me get that for you. The discount codes are changed now. It's Cosmic 50. But
Yeah,
I was
and we'll give
originally, and I
people
think
another
I still
minute.
am. Yeah, I'm going to share it now.
Yeah, and EVOs are it's giant. I think a lot of people have difficulty understanding it, right? I have difficulty understanding it. So it's complex. It gets very heavy duty in terms of the physics very rapidly, but
I
there's a
think they've
lot
been well
there.
described by mathematical equations, principally by Dubovik. Now, Dubovik worked with Shishkin and Korols. Both Shishkin and Korols, to the best of my knowledge, are alive. I actually have spoken to Shishkin the last 2 days. He reached out to me after my last presentation on cavitation that we did earlier in the week, and informed me that Dubovik had sadly passed away. But what they found in their team during their work and post their work, working at the All Russian Institute of Nuclear Research in Moscow and in Dubna, the whole city that's dedicated to this stuff, but they found that it would appear that hydrogen isotopes are 2,000 to 4,000 times easier to produce etheric matter clusters than any other element beyond lithium. Now, Tesla found, and you can see this in Secrets of Cold War Technology by George Vassilatos, that Tesla found that it was beryllium, magnesium, and aluminium that were the easiest in his work. But of course, he wouldn't necessarily have had access to hydrogen isotope. Of course, he had hydrogen, but it's not a dense target to smash something towards, So, and so to produce, and what it is, it's proper charge separation, and it's the hidden energy within matter. So the neutral EVO, you could argue, is a fractal toroidal cluster of etheric matter, dark matter, potentially cold relic neutrinos. These are not normal nuclear neutrinos. And so you could imagine that fractal toroid made out of these relic neutrinos, okay, and then they're bound together because the actual relic neutrino has its own toroidal moment, so it can be bound into a fractal cluster by its scaling toroidal moments. Then that structure, because electrons can interact with these things, and they also have their own toroidal moment, they can then become wrapped up and take on like a fossil gets formed, and probably is exactly the same way a fossil gets formed, actually. The electrons become part of the structure, and then they can bring in one ion per 10 to the 5 electrons. And so you can then have things that are both positively and negatively charged, but because the electrons can go in and become Cooper pairs, they can present a charge of only -1, even if you have 10 to the 23 per centimeter squared of electrons in the exotic vacuum object. So they can present as neutral, they can present as positive or negative, they can cluster, the clusters can cluster into bead chains, and so on. It all becomes logical when you understand the toroidal moment, the fractal structures.
Okay. Well, thank you so much. It's, again, truly an honor to have you present today. It's absolutely wonderful.
It's my duty.
Well, so we've got, let me see, we've about 20 minutes before the top of the hour, and I guess we're going into lab time, so we'll probably be a little bit more relaxed. If it's okay, I do want to put up a couple just before I forget, though. I do want to share. Let me see. I will try and share some of these screens. So for the Searl effect, somebody sent this to me during the presentation. I want to say thank you to them. This is a copy of the Godin and Roshan SEG paper. You can look this up. It's online. It's hosted. I'm trying to remember where it is now, but this has been rehosted in several different places. If you just look up Godin and Roshan SEG, it's VV Roshan and SM Godin, right? So Vladimir Roshan and Sergei Godin. There are some schematics and design information there. Again, they did not follow Searl's instructions directly, and that's okay. Very few people have, but so this is kind of an overview of their paper. So you can read more about that as well as some of their results. I did a couple on this as well. So in terms of Morningstar, this is something that Russell referenced. I did an interview with Paul Murad. That was the first. And that's on Medium. It's Searl. Let me see. Sorry about that. Here, I'll share this tab instead. Here, Searl effect generator replication measures 7% reduction in weight. Again, this was originally a PDF. It looked a little bit prettier back then. Paul Murad described the construction. He had images of it. Let me see. I believe some of this, I think that may actually be a someone else's SEG. Yeah, that was Terry Moore, I believe. Fernando Morris, Terry Moore, something like that. So that's Paul's stuff. And then I'm going to share this tab instead. Okay, and this was an interview that I did with John Brandenburg. Brandenburg worked with Paul Murad and tried to explain the effect with kind of his own theory based on the pointing vector. And for anybody who, comes to this frequently, you guys all know John. So John did a very detailed write-up. So I wanted to show those to you guys. So that's Searl effect stuff. And then I want to share this tab. And again, this is on my old American Anti-Gravity channel. There are probably many better Searl effect videos out there. This is an old presentation from Searl. So I guess you add these up and you're talking about, something like 35 minutes or something. This was one video that I split into two parts. This was the VHS that somebody sent me when I was much younger. And this is where Searl describes how he built it, why he built it. He had a lot of the stuff that Russell covered. Although Russell has had many years to kind of perfect his presentation. And then Searl also had a lot on the IGV, which is the anti-gravity vice that he was talking about. So that's Searl stuff. I just wanted to put that out there so that you guys can see it. Then the other thing I wanted to show you, and let me see, I will share this tab instead. I'm going to leave the sound turned off. Okay. And hopefully you guys can see that. I'll put this in theater mode. So somebody emailed me this. This is called the Noonco anti-gravity device. And this device, I've seen this video before. That's why I'm playing it for you. I'll just forward to it. Flight testing day 1. You can see the devices in the air. The whole 9 yards. It does look pretty interesting, doesn't it? Looks like kind of a UFO. This video is several years old now. Okay. So this is from a fellow named Walt Noon. This one was loaded 10 years ago. It was loaded on April 1st, and that was the giveaway. So the reason I wanted to share that with you guys, I'll stop sharing, was I reached out to Walt Noon. And I asked him, I said, was this for real or was this a gag? And he said, he's a science educator. And he said, that was an April Fool's Day gag. He said, I was doing it to publicize an upcoming science conference. He's like, don't take that seriously. Some people do, don't. And so for anybody who is watching, who has wondered about that video, the Walt Noon, the guy who did that video, has said, this is not real. It was a gag to publicize a science education event he was doing at a school. And so hopefully he will be coming on. He's an amateur magician in his spare time. And he has worked a little bit with the Amazing Randy. The Amazing Randy used to do science hoax debunking, right? He offended some people, but a lot of it was pretty credible. And so Walt may come on and describe some of the common hoaxes that are out there, right? Because we've all seen those videos. So so I just wanted to kind of put that out there. So I guess we could kind of go into lab time. Does anybody have updates? You guys, Curtis, Drew, you guys have updates? Drew? Okay. Well, let me do this then. I'll take everybody out. And once again, Bob, thank you again so much. Today, we have had an absolutely tremendous day. Okay. So let me go to Drew. Drew, you have updates for us, sir?
Yeah. Let me see if I can share.
And I'll take myself out here too.
Screen sharing, share screen, share entire screen. Like working Creo. Okay. Can
I'll come back in.
See my computer screen?
Not yet. It looks like it's not sure. So you don't have to share the entire thing. You can share a tab. You can share other.
Sure. That's
Wait
easy
a
for
minute.
you
There
to
we
say,
go.
Tim. You understand how this mess works.
Oh, you know what? I get confused too. I think you have to finish clicking a button of some kind.
Entire screen. There.
There we go. Okay. Perfect.
Magic. Okay. Well, this test, and the only reason I put this up here because I actually have a video, which is very rare because I almost never shoot video anymore. But I wanted to show that this. Let me just start from the beginning. This is the first test of the day, which was at, I don't know, whenever it was this morning, sometime early, 7, 8 o'clock. And the reason it's starting at the 0 point at 1.5 millinewtons is because I ran this thing until, I don't know, 11:30 last night, 12 o'clock last night. And just shutting off one of our warp test plates doesn't actually shut them down. They just kind of go into standby mode. So there was actually 1.5 millinewtons of thrust still in the plate from the night before. Now, this thing sat completely disconnected, hanging out in a vacuum chamber board all night long. And when I plug it all back in this morning, I just start the counter at 1.5 because that's where it is. The program resets to 0, and then you can put in whatever the offset is. So what the point of all this is that when the power comes on, for example, right here, which is 7,500 volts, when the voltage comes on, you can see the current is down around like, I don't know, 5 microamps. 0.5 microamps. I can't even remember where it is, but it's low. And with the voltage on and the microamps almost nothing, this thing jumps down to making 2 millinewtons of thrust. It just happens to be pointed away from the force meter, so when it's on, it's making thrust downwards. If I flip the whole thing 180, it would go up. It doesn't make any difference to the force meter. So as you can see, I would run it for, I don't know, 100 seconds, 200 seconds, and then switch off the power. And of course, it's very obedient. Once you switch off the power, it collapses the field and it goes back up. But notice how it always goes back up a little less. That's because while it's on, it's actually pumping charge into the dielectric. So that's kind of the secret sauce behind how we have perpetual motion, if you will, is we don't ever actually get anything for free. We're actually pumping charge while the thing is on into the structure so that when we turn the thing off, that trapped charge is what we actually make power with. That's what we make field with. And this thing doesn't care where the field comes from. If there's charge and a ground, it sees field and it thinks time to make thrust. So I just want to show you that as the voltage increases, the overall thrust increases all the way down to wherever I was. What is that? 10,500 volts. And it's at around 3 millinewtons. And again, these are, plates about this big. Physically, they weigh about, I don't know, about 360 milligrams. And there's 2 of them. But I have a video. So, and if there's, I like to apologize. I still have to basically black out anything of real interest. But what's important here are the numbers that are going to show up on this thing. So you can't really see the plates because I blacked them out. But I'm going to run this video and then I'll kind of just narrate over it. So what we're doing is we're running now and it's just kind of hanging out doing nothing. And now the voltage is coming up. There's 9,500 and we're making 2,700 for 27, 28, 28, 29. This is in micronewtons, so that's 2.9 millinewtons, and we're at 10.5 and holding steady at around -3 millinewtons. You can see the power supply current is virtually zero. It just doesn't go that low. Or either that or it's disconnected. I don't know which. I think there's a glitch in the software. But the power supply current is like 5 or 0.5 microamps. But you'll notice that when I cut the power, which is coming up here pretty soon, this 10,500 volts is going to just basically drop like a rock to 0. And we're at 3.05. So we're still making thrust continuously, a little tiny bit more as we go up. I think I cut it off when I hit about 100 seconds because there's a problem with the charging curve. And anything after that, and I got drift in the system, and it muddies the waters. But this 10.5, see there, boom, it just went to 0. So the voltage is now 0. The capacitors in the high voltage supply take, I don't know, a couple of seconds to fully discharge. The system takes a couple of seconds to fully discharge because it's basically a capacitor. And you'll notice that the force doesn't just drop to 0. It drops to whatever the charge line is. In this particular case, it's whatever that is, 2 millinewtons, -2 millinewtons. And if I short the plates and give it, I don't know, a week or two, eventually all that charge will bleed out of that plastic, the materials. But if I don't do that, they'll stay in there forever, and it'll make thrust forever. It'll continue to make thrust forever at this 2 millinewton level. This is how basically we've gone above unity. Is I would run one of these thrusters for 20,000 seconds, and this number would be in the off state. This number would be 5 millinewtons, which is well above the unity factor. And it would, basically I could go to bed and come back the next day and it would still be 5 millinewtons. So it takes forever to build up enough charge to get above unity. But when I'm just messing around doing just, efficiency testing, it's pretty quick. You turn on the power, you're rewarded with thrust. You turn off the power, the thing goes to whatever the bleed off charge level is. And I just want to show it that, this is kind of cool, is that when the power goes off, which it's going to do again here in just a second, you can watch the thrust. It drops off in about 5 seconds. And again, what's causing the thrust to take some time to drain off is that there's still an enormous amount of charge in those capacitors. It's absolutely lethal. You can see it drops down pretty quick, though. It loses 1,000 micronewtons in, I don't know, a couple of seconds. And then it'll slowly, asymptotically bleed off to its nominal state. And then it'll sit there forever, excluding drift in the system. There's always drift because, this is a poor boy's setup. If I had millions of dollars like NASA does, I would have a much better, lower drift rate. But I don't. So I thought I would share that with anybody that wanted to see it. That's it. That's all I got.
Drew, thank you, man. Thank you. Yeah, and again, the work you guys are doing is absolutely incredible. Absolutely incredible. And so I'm talking about coming down to, again, dragging the camera down there. We haven't figured anything out yet with that. I have to survive these first couple of conferences first. But again, the work you're doing is absolutely amazing. So let me see if Curtis has anything. Curtis, I see a thumbs up. Is that a yes?
Yeah, I'm uploading it now.
Okay. Oh, okay. Well, Drew, thank you again.
You're welcome.
Okay. Well, let me go over to Curtis then. And I'll bring everybody back in for open discussion if we have any today.
Let's see that. Okay, there we go.
Oh, I see Jeremiah there, so I guess we'll have open discussion. He's hiding in the.
Okay, the slide should be ready to.
Oops. Okay. There we go.
All right. Okay, let me maximize my screen here. So, yeah, so I have some recent runs to show. This is May 9th. Earlier this week, a few days ago, actually now, we were testing a device. It was exhibiting some stickiness, but we went ahead and did some runs. And our goal has been to reproduce things. Now, let me explain all the squiggly lines here. If you concentrate on the right, there's kind of like a greenish turquoise line and a red line. The turquoise line is actually the device itself that moves on bearings, and the red line is the um, frame that it's being held in, and that frame is part of a torsion balance that can move back and forth. So, and the blue or purple is calculated as a center of mass. So when that center of mass line moves, that means there's actually, we think there might actually be momentum or forces or impulse being transferred or created. So you can see here that this run, we got a pretty good momentum. And what we did in the next run is we narrowed down the sweep, because what we're doing is we're sweeping over a range of frequencies, and we narrow down that sweep. Looks like the slide. There we go. I think I goofed up the slides here. So this is it looks like that was goofed up, but anyway. So here's a narrow sweep that was done the next day. In this example, you can see that we're getting quite a bit of push and consistently pushing the device. It was an interesting, and this is a snapshot of a run. I'll show you the video of that. And this is what we want to see. We want to see the devices actually consistently replicable, being able to push and push and push, and keep that going. Now, in terms of forces, we're not ready to reveal the actual magnitudes of the forces. They could be quite high, especially in terms of newtons per kilowatt. We're getting relatively high numbers. But again, we need to, the real work is going to be figuring out the input signal and kind of coaxing the preferred forces from all the ancillary stuff that happens when the piezo stack vibrates. And so I was going to go to a video of recent runs, but let me get back to that. I'll go to the next slide first. So recent directions, we've been talking about what funding sources we want to go after, and after a few, the last couple months, there's been a lot of attention. We've had some discussions with different groups, but so far nothing's come up. I mean, we're still hopeful, but I think what we've been talking about doing is actually pursuing the NSF SBIR. I did a search, and it looks like they have funded propellantless propulsion projects in the last couple years, for phase 1. So that's something that I think that Jim and this group probably has a good shot, because it's based on real physics. At least we think so, right? Now for testing, this is something that I proposed recently, and I'm sure that others have thought about this before, but there's the space thing, which can be quite expensive, unless somebody just gives you a ride out of the kindness of their heart. But then you still have to develop and get things rated for that, versus doing a lighter than air upper atmosphere test. So especially once we saw the numbers for newtons per kilowatt, the fact that nowadays we have thin film solar cells that are very light. You can make a relatively large craft. You can we have materials like carbon fiber that we can actually put stuff up. And so I think that's another good way to consider proving these technologies. If we have something that's propellantless, there's earlier I was talking about there was presentations on other phenomena. So doing something that people can't ignore, like sending something up there and slowly speeding up, getting to escape velocity or to the velocity of orbit, that would be something that would be a significant, like a game changer. So I think that might be an intermediate step. It's probably more attainable at this time anyway than space is. So let's see here. Let me share my screen and I'll go to those videos. Okay. So if you guys can see my screen, here's the video of that specific run. And the center there, that's the device. And you can see it pushes quite a bit and the frame is moving quite a bit.
Curtis, hang on just a sec. Sorry, it's not.
Sure.
Let me see. It looks like it's not sharing. Okay, so there's your slideshow. I'm not seeing your screen.
Okay.
I think
I see. Window. Okay, here we go. Share. Okay. I thought I went too fast.
There
Let me
we go.
start the video
There we
again. Yeah. Okay.
Okay, now it's saying click to exit full screen.
Okay, hold on.
There we go. Okay, now it's back.
And I'll start that again. And I'm going regular speed, and I could slow it down if you guys need to. But here you'll see it. When the blue comes up, that's applied power. That gold color is a accelerometer. Basically, it's a piezoelectric disc in there that provides voltage back to us, so we know it's getting crunched up. And so I turn off the power there for a second, let it rest, and I turn it back on here. And you can see that in this run, this device is kind of getting a little bit tired. You can see the spring there is compressing. It's kind of getting stuck. So this was basically ran to failure. So this is and there it's kind of stuck on the spring. And you can see let me go back to that. You can see that red, where that red line, that's the center point. So it started up here, and you can see that the device shifted over. What that means is this thing is the bearings are kind of like binding, and so it needs to be taken out and given some TLC. So yeah, so that's that run earlier. Like I said, this is one that's been in the chamber for a while. We've been kind of abusing it, seeing how far to go, but it's giving replicable results, so that's good. So let me stop sharing and go back to the slide. Let's see here. Okay. And in terms of physics, I do have a couple new things to talk about. As you guys that have seen my presentations before, I talk about things like matter as a wave, Mach's principles, something that's experimentally proven. We know about parity violation. We know general covariance works, Noether's theorem. We all use the correspondence principle when we do a lot of physics. There's two new things I want to bring up this week. They're kind of new to me in the recent past, so I don't know if they're new to everyone. So 2 points of view to think about. One is a theory that actually treats matter, light. Matter is made of light, so light is fundamental. So it's a theory kind of much like what Bob was talking about, in that it has treats an electron as kind of like a photon, kind of whirling around in momentum space. So I put the website here. Quisicle is the way those guys pronounce it, and they have quite a few claims on their website. I just listed some of them because it goes on. I think there's 17, and there's papers. It's a really interesting. There's a lot of stuff in there, a lot of presentations, hours and hours. I haven't been able to catch up yet to where they're really at. But what I find really interesting is that the stuff that Sachs did and that I talked about before with the spinor quaternion formulations. Of course, these guys are coming at it from a different point of view, which is the particle point of view, but almost arriving at a similar mathematics or similar structure. So that's quite exciting, and maybe we can get one of those guys to come in and give a presentation here one of these days. I think that would be really cool. And then the other thing I wanted to share is somebody named Eric Ryder. I just found his stuff this past week. His website's right there, unquantum.net. And he spent the last 20 years running this experiment where he actually shows, he runs an experiment using gamma rays instead of photons, and shows that the old threshold, before quantum was a thing, people were trying to figure out how light works and matter works. And so, you get, when you get a light absorption, you have this quantum jump up and a quantum jump down, okay? And so what Eric is showing is that with gamma rays, you're not getting a quantum jump, you get actually a threshold event where the thing is, slowly rising. So I would highly recommend. And what's interesting about this is that they're kind of two different points of view about matter and what's really happening. So in some ways they're kind of opposing, but in some ways it may be actually the same thing, but you're just looking at it from the field point of view, right? All these equations have a source term and a field term, right? So if you're all sources and sources interact, what they interact with fields, but the source is a field. What does that really mean, right? So it's kind of I see them as almost complementary type of points of view. So this is something that I wanted to share with you guys, and hopefully we can. And by the way, Eric's work, one of the things that did interest me, as you guys know, I'm really interested in the Brett-Wheeler process and anything that has to do with electrons, positrons, annihilation, and creation. And both of these series have their own different explanations of how that happens. So this is really something for us to explore when we talk about, what the vacuum really is, what mass really is, what inertia really is. So it's very significant. The rest of the slides I have are basically the same stuff I talked about before, so I'll just skip that, and we can go from there.
Awesome, Curtis. Thank you, man. Thank you. That is super awesome. So we're kicking butt. So it's 5 o'clock. Why don't we try and do a little open discussion? I'll just bring everybody in. We'll kick the doors open here, see if anybody has any thoughts and let me see this. Jeremy Riss and Jeremiah Pop. And who else are we missing? Brendan. I think we got the whole gang here. Oh, and it looks like Bob is hiding out. Russell's hiding out. They have their screens off, so we won't bug them unless they turn it back on. Okay.
I want to kick this off with a question, if I could.
Yeah, go for it, man.
Just point blank, I didn't understand any of that Searl stuff because it went way over my head, but it sounded intriguing, and apparently they've gotten all kinds of good results. But what caught my attention is the whole temperature thing. Am I right in somehow all this spinny, magnetic-y, whatever-y thing it's doing, that's one side's getting hot and one side's getting cold? Did I hear that right? Okay,
yeah.
I'm seeing a couple of nods. So, if that's the case, I'm just, because I don't really want to do this, but if it would lead to a step in some overall information, I'm toying with the idea now of maybe measuring the front side of one of my propulsion plates thermally and the back side thermally.
Jeremiah, you could talk
would
about
I
the
be
cold, right?
Is there any possibility that I would see a thermal difference between the front and the back plates?
Bernie?
You
got some? Yeah. Oh, Bernie's in Canada. That's right.
Right. Look, one benefit of being in Canada.
You got lots of benefits.
The forest fire?
No, that's the Aurora last night.
Oh. Yeah, we don't have those in Florida.
Yeah. No.
You guys want to see some freaking Aurora shots? I got some last night.
Team, right?
I saw Aurora Borealis in upstate New York in August of 1972, but we're too far south in Central Florida to see any auroras.
Yeah.
Too close to the center of Earth's magnetic field.
Russell,
I
where
took
in
my
Central
Nikon
Florida
out
are you?
and I took my.
I'm
iPhone. That's
right
only
next
better.
to Orlando. I'm north and east of Orlando in Oviedo.
Yeah, guys, I'm gonna
You're about 20
get off
minutes
in a
away from
sec.
me.
Well, yeah,
Oh,
it's
wow,
it's
cool.
open
We should get
discussion,
together.
So
We should get
Nice,
together.
Jeremiah.
Cool.
Yeah, if you jump on 415, if you take 46 to 415, then you're 5 minutes away from me.
Oh, cool.
You should come by sometime.
Yeah. Send me a text or whatever. Send me your address somehow in the comments section or whatever, however
Yeah, I'm
you
not
like.
doing that, but Tim, is there any way we can connect the dots on that so I can get his address or some way to text him or
My
something?
phone number. Yeah, give me a
Yeah.
call.
You guys can put it in the chat.
There's the private chat.
Okay, I'll put my phone number in the chat.
Yeah,
And by
I
the
was
way,
looking-
Drew, when we Jeremiah was gonna has his hand up to I think he wants to answer your question.
Oh, yeah.
Well, actually, I've got a bit of both. I can address Drew's question first about the thermal differential. So yeah, when you're talking about a system where you have a magnetic field where you have a traveling wave flux, if you think about the basic dynamics of a rotating electromagnetic field motor, basically what Tesla is famous for inventing, his favorite thing that he created, you're dragging around a field flux. And so if you have these magnets on the Searl effect generator that are polarized in such a way that when they rotate around the outside, when these magnets go around the larger cylinder, they're a helix. So their helical fields are acting sort of like a screw pump, like an Alcubierre style pump. And if you think about what they're doing to any kind of charged particles in the atmosphere, they're effectively pulling them down into that. So they're pulling them down from one direction, from the top and into the bottom, depending on the direction of polarization, or if you rotate them in the opposite direction, you get feasibly, the thing to increase weight and flip the polarity of the heat. I heard one thing in the presentations today that I didn't really understand, and it was the claim that, well, the thing was off and there was no motion of the magnetic field fluxes, that there was some kind of thermal differential. And that to me does not make sense, because there should have to be required motion in order to pump any kind of physical amount of MHD or otherwise associated effects. Without a moving magnetic field, you have no way to couple with it. It's like trying to generate eddy currents by just placing a magnet on top of something and then leaving it in place. It's not going to work. So I didn't quite get that, but your thermal differential can be generated by a variety of different mechanisms. You can even use, by consideration, the patents on ionic cooling or ionic heating, where you can use ions in certain environmental conditions. Usually it's pulled in partial vacuum, never complete vacuum, and you can transfer very high temperatures directly to the surface of a material and heat it almost instantly. You can also cool down materials along the conveyor belt just by hitting them with positive ions, which the electrons are the responsible carriers for the thermodynamic motion. So they actually carry the heat. It's the electrons that will transfer heat from one place to the other. So if you take electrons off of one surface, that surface will get cooler because the electrons are stealing the momentum from the vibration of the Brownian motion in the metals. And the highest energy electrons get thrown off first. They're the ones that you have cold cathode emission from. Then, of course, if you have a positive charge, well, the positive charge is going to rip the electrons off the surface, because positive charges can't just flow as raw protons, but they're going to be ions, because you're going to have electrons in the valence shell. So those will allow you to actually add heat to something. There are multiple mechanisms for ionic or high voltage heating when you have a moving magnetic field to pump the charges. But what I actually wanted to ask, and my question was mainly for Curtis. So I wanted to show you this. It's a very nice unit, and let me pop a flashlight here. So Todd Desiadio had this and another one just like it designed. These are basically very large Mach effect thrusters, and they're heavy. Big, thick copper base, very nicely assembled. Total of 12 pass-through bolt holes, only 6 are being used. And my question for you was about the termination to these discs. Now, he specifically ordered the ones that Woodward was originally recommending from the same manufacturer. So these are very hard ceramics, but this is a much larger unit in terms of its diameter compared to the ones that you guys are now testing. And I know the whole issue with the friction and trying to get the thing to slide freely and not interact with the framework is a problem. And even in the core fundamental concept of the Mach effect. The fact that this device has a frame around it means that there's going to be a Mach effect interaction with the framework itself. And so even that has a major influence, the test fixture itself. But what he used to terminate the electrical contact on these plates was this interesting kind of tape material that you can get. It's a weaved metallic shielding material, and it's just slightly barely magnetic. But I'm wondering, do you think that's efficient? Do you think that the compressibility is going to be too soft for good transfer of mechanical waves between the aluminum side here and the copper side?
So, so yeah, that's a good question, and I'll give you a hint. A couple things is the material that's used in between the piezoelectric. We've tried copper and brass. We're currently using brass. So, that's important. Also, what material you use to like glue the stack together. And in addition, the reaction mass itself was something where we had to have different reaction mass thicknesses made to find where the thing would resonate for the materials, basically the speed of sound of the material of the brass. So you may have to have more than one of that brass slug to figure out, where. Now the question, that thing, the way we have it in a frame is that whole device can move freely back and forth. And so the other thing I would warn about is those bolts. We were having bolts fail. And so what we use something where the bolts can like move freely. So there are Belleville washers that you can put on there. You can find. But all that being said, what I'm curious about is how you take that big thing and what you're mounting it on. Is it free to move? Because that's one of the keys.
I've always kind of wondered, in the simplest, I always try to think of the stupidest, simplest thing that could be done in terms of a lab experiment. And you could create a complicated framework and all kinds of slide bushings and many things to connect power. And I get the problem with providing power to these things. That's part of the issue, is that you've actually got to get energy into them. And that has to be connected to something. But
right.
Why not just simply hang this from fishing line? And why not just that was power supply?
That's funny, because that's what we had. We had when it was in air, we had it on basically some fishing line from the ceiling on a frame, and that frame was kind of holding it up, so it was free to kind of move back and forth. But it was still in the frame. It was on the frame, and the frame had bearings.
But you had surrounding matter, right? See, here's the thing. In my thinking, the Mach effect is basically an interaction with any distant matter. And so we're talking about the velocity of C propagation to any surrounding distant matter that might be able to affect it via its mass field interaction. And in this case, I want to try and isolate the effect. So when I'm dealing with this and we're looking at motion back and forth, I don't want some heavy block of metal or aluminum or anything else that's around. I don't want it in a test frame where I have a torsion arm or a fixture or anything else like that, if I can avoid it. If I had to hang it on a torsion scale, I would probably want to suspend this from the arm of the torsion pendulum and keep it away from the physical arm itself, because, again, that's more mass. And I would want to try and isolate out all the nearest mass, because, again, it's the inverse square of your distance from that mass, and I know that it's contributing. So, like, if I were to, say, build a framework of lead, and I were to say this framework is not oscillating, meaning it's not part of the mechanically vibrating circuit, so it doesn't matter how much crap you stick on it. I imagine it could affect the results just because the physical mass is different, not just because the acceleration weight is different, but because there's a different interaction due to the fact that there's more mass. I mean, that is the base principle of the Mach effect. So I would want to get rid of all of that if possible. And I'm wondering if you guys thought about that.
Yeah, so the like I said, the trick is when you get the thing vibrating, and balancing it and how you're going to mount it. So that's why I had that question for you. So you might just put something where it's allows for, like, let's say a speaker, right? If you think about a speaker and you have that element, the inside that can move. Yeah, there you go. So you can take something like that where it's, you know, constraining two parts of the drive, and it's free to move back and forth. See, the thing about this is you want it to have kind of a one-dimensional motion. You don't want it torquing around, because it'll do that, right?
Oh,
it'll violently, you know, thrash everywhere, right? So you want to constrain that.
Oh wow, really? That's actually seriously important. What you just said there. If you're seeing that this thing has a tendency to twist or torque or do anything else when it should be generating only a linear displacement, what that tells me is that you have a noticeable and probably verifiable contribution from the presence of your asymmetric frame being more mass on one side than the other, which I would likely suspect is the production source of your torque.
Well, yeah, that's right. And the thing is, but you need the different masses to get the Mach effect to happen, right? So in our experiment, we have devices that, and we just made these where, okay, so, you know, we're trying to do a verifiable physics experiment that someone can replicate. So we have devices with the piezo stack, a brass mass, an aluminum mass in the frame, and you can take out and swap take out the brass mass and aluminum mass and put a set of brass masses that are equal in weight with that same stack, and show you can do the same experiment with the same stack, basically only changing one factor, the symmetry of the masses, and that shows when you run that, the Mach effect goes away. You don't get the same push. Okay, so if it was an electromagnetic effect, it was something else going on, that null experiment would not work. It would still push, right? If it was some kind of
I understand the delivery time.
That's
right.
The
delivery time of the wave that travels through the back mass, when it actually travels through this mass, it's got to come back through here, and then it's got to bounce back to the other side, and that is going to be transferred through the hardness of these very rigid piezo discs. Specifically, why they need to be such a hard material and so firmly bonded to each other. Right, and then this mass has to reflect that back at a quarter wave, so you get the phase interaction at exactly 1 quarter wave apart in terms of the mechanical oscillation, producing your net force, which is that W waveform that Guy Desiato pointed out in his warp drive papers early on. So it's the same one that you guys got. You know, it's what Woodward was really talking about. It's this very idealized waveform that is asymmetric in terms of its distribution in motion over time.
Right, and that waveform, that acceleration that the discs are undergoing, so in the piezo stack, needs to be timed with the power in and power out, because in the Mach, the derivation is the change in mass is proportional to that dp/dt. Okay, and so you're trying to basically push against the heavy mass when you're heavier, and then push against the light mass when you're lighter, just depending on which direction you're trying to go, right? So you can actually get forces in either direction, you know, depending on, you know, what signal you're putting in and the timing. So the mechanical Q factor, and, you know, how that whole thing is vibrating. So if you could figure out, you know, there is nothing that says you have to put it in a frame like we have it. That's just kind of a, you know, where as found for me.
I see the difference actually in Woodward's opinion, where he's coming from and how I think this thing works. And I guess the difference would be he's trying to consider producing the actual force against the reaction mass. And what I'm considering is the reaction mass is necessary to generate the phonon acoustic oscillation to produce the force within the piezoelectric elements themselves. So in my model, the force is produced in the transducers, and in his model, the force is produced with the transducers against the reaction mass.
So in his model, what's happening is the mass there's a difference in mass with the piezo stack, because the piezo stack is expanding and contracting, so it's pushing against both masses. And so if it pushes against both masses and you have both masses of equal mass, and you're timing that correctly,
no displacement
you get no displacement. But if one is lighter than the other, you'll get a reaction force. And
right.
what
By the
happened,
time the
and
waveform reaches halfway through the
because
big mass,
and
it's already hit the front of the front mass and bounced back to the beginning point. So effectively, that part of the push is done on the front. The push is
yeah,
still happening on the back, though.
so your push, and that's why the frequencies and characterizing your specific drive is important, because that push needs to be the electromagnetic energy you're putting in for the piezo stack, which determines how fast it's needs to be timed with the mechanical properties of both that reaction mass and the aluminum plate. So you're entirely correct. You have to take into account the speed of sound and the bulk mechanical properties of those materials when you're designing this drive.
All that makes sense.
That plays into it.
And then I do have one more sort of impromptu thing just to show off a little bit here, because it's something that I'm working on, and it brings back to Brendo's original opening presentation where he talked about Sarfatti's drive just a little bit. In Sarfatti's drive, he's got a parallel plate cylindrical capacitor. He's got a plate on the top, plate on the bottom. It's wrapped around a cylinder. He's got an electromagnetic coil around the outside. And the idea is that you oscillate these things in sync, because you have this electric field gradient that's going to be reduced in between those two sides. And because you have a difference in mass on the two sides, you have a difference in electric field intensity gradient due to the difference in mass. So your electrons are all pulled to one side, right? It's heavier on that side. But then at the same time, you have this torsion or this twist, which is going to create a differential cross field interaction in space-time. And so through epsilon mu, you have this possibility of producing an actual force and a physical displacement. So here, there's an interesting thing that somebody built recently. Very nice magnet, by the way, Russell. You see you showing that up. Definitely check that thing out.
Yeah, well, that looks like that's a Searl roller, right? So
yeah, that's one of 8 rings that would go on
the
the
Searl rollers are made up of a stack of 8 discs that are joined magnetically, and this is one of those 8 discs.
So, a lot of you guys in the anti-gravity community, you're probably watching most of the channels that exist out there, and let's face it, there are not that many of us. I mean, the numbers are growing, which is really awesome, but we're still sort of a small, tight-knit grassroots community. So most people, you may have been familiar with Helium Physics' recent videos on the anti-gravity stuff, and I have some suspicions about the 2 most recent ones, but anyways, it's
I've seen some debate. Jeremiah, do you want to put up some of the Kedium ones? So I think
I don't know if I don't necessarily want to show them. I don't know if he might have an issue with us showing his videos.
Okay.
It is his original material, and I haven't asked for permission, but I made my own version, and so he kind of assembled this thing. He's in somewhere near Rwanda in Africa, and it's like he doesn't have the resources that I can just pull all of the garbage cans around here. So very easy stuff, right? And it's a total difference, but I've got to be proud of people for pioneering in situations where they don't have as much access to materials. So what we did is 3D print one. So Simon C. and I, which by the way, I just want to mention because Simon did such a good job on this thing. He is taking commissions now, so I'll try to get that set up. But just to mention, he designed this based on my very crude drawings. So I drew these up. I'll pull the notebook here. It's based around this simple principle where you have sort of an enclosure. You have a plate with top holes. You've got a grid that holds a thin ionization wire that sort of wraps around it. You have some kind of enclosure or cavity, and then you have an electromagnetic bobbin that's over here. So, and the idea is to synchronize the phase of all of these systems together. So I'll pop this apart. Inside, and this will be difficult to see. I'm going to try to use my flashlight to see if I can illuminate any of these thin little wires. But you see these little notches, and you might just be able to see, if you're looking at a computer, if you're on a cell phone, you won't be able to. Those thin little lines, looks like a spider web. So that's an extremely thin ionizer. At the top here, positive ions will be produced at an extremely high efficiency. And they'll be pumped down towards the bottom, which contains a set of piezoelectric transducers that are pumped out through those 2 wires here. The basic grid array, they're just glued into place and organized. And then around the outside, of course, you have your coil. Now, altogether, what this does is create a standing wave inside this cavity. And that standing wave has ions that are flowing from the top towards the bottom. And as they travel down to traverse their path, there's an electric field acceleration that's positive on the top, negative on the bottom, and the bottom does not have a collector plate. It actually uses the surfaces, the brass surfaces here of the piezoelectric transducers. And so right at the surface, you have a huge concentration of charged particles, which we oscillated up and down in the vertical plane because of the acoustic sound wave. But at the same time, you also have a circulating magnetic field. And so you will produce cyclotron rotation of the charged particles as they swirl down and swirl back up, being moved up and down by the sound waves. They're going to produce Bremsstrahlung radiation, which will change the refractive index, producing slight exhaust to the side, or you'll get emissions to the side in the EM spectrum in the transverse mode, and you'll get longitudinal mode in the up and down or vertical direction. And together, all these things, they produce a coupling coefficient with our background vacuum through the refractive index. And we could look at Sarfatti's model and see, for the same reason, that this is effectively very much like Lazar's canister gravity wave generator. It's very much like Sarfatti's capacitor warp drive system. It has in common a lot with many patents, and it's something that I thought was rather clever the way that Kedium put it together, and fingers crossed it's actually a real thing that he's got there. But even if it's not, I like the concept of being able to test with a platform that anybody can 3D print. Like, you guys can just print this. You can pop these piezo transducers in there and glue them down. None of this stuff is hard. The bobbin itself to wind the coil makes it super easy. It's 20 gauge wire. I mean, this is all stuff that anybody could replicate. So that's why I think it's rather interesting as a sort of entry-level project, because it doesn't cost a lot to make. It's a rather simple idea. And yeah, my question would be whether or not these piezo discs are they're going to be powerful enough. The way I'm driving them is using this little circuit here. It's a custom wound matching transformer. It's a 2-to-1 ratio. So I can take 12 volts in, and I can step it up to 24 volts directly. But in resonant mode with the piezos, I can get it up to over 120 volts. And so it's driven by this very simple 2 MOSFET circuit using IRFC44 MOSFETs. And it uses a 4452 MOSFET gate driver to drive this 1-to-1 gate drive transformer, which powers the MOSFET gates. Super simple circuit, really easy to drive, and the great thing is you can hook it up to a function generator and control the frequency exactly. So no need for self-oscillation or tuning circuits or tweaking knobs or anything like that. Just run it where you want it to run. So, but that was my update. I may try something like this as my sound source. That's why I pulled it out, to just kind of show there are other options. Now, this one is stock off the shelf. It's not going to go up to the frequencies that we need. But if we replace the windings on the voice coil and tear down the 30-turn windings and replace them with only 5 turns of a thicker conductor, then we can get that same tweeter to perform at from the 40 to 70 kilohertz range, which is where we really want it to work. So that's what I had to show. Just a little update.
Appreciate that, Jeremiah. That was awesome.
I was eating lunch.
Yeah.
It brought me back in and busted with food in my mouth. There we go.
I sort of lurked in Adam's Discord chat and watched this thing being built, and I was like, saw it taking form, and just this little primer is the first time I've really seen it all laid out.
Yeah.
Yeah.
Well, no,
Inkling. I'm really glad to see
today
that.
has been absolutely awesome. So maybe we go until around 6, I guess, tonight, if that's cool, and that's about half an hour from now. And then close
I'll
things
stick around to answer questions. I mean, I don't know if you wanted to, depending on what you guys think, you could open it up to the public. You could pop a link out there on various channels if people wanted to have sort of an open chat.
I don't know. We've got a
in.
collection of esoteric experts in here. I think David.
Yeah, that we do. Maybe you're right.
David
It all goes back to the toroid, doesn't it? It circles back to the toroids in that esoteric circle.
And then Bernie Bernie tonight. So tonight you're gonna have more aurora to get photos of.
I know, right? It's like, I can't believe the quality of some of the colors I'm seeing in these pictures I took last night, just out of my backyard.
Okay, I got a weird question for you. I have a weird question. I went out last night, so I live right on the edge of Canada, right? So I'm a little bit further south, but I went out and looked, and I was out in Blaine, Birch Bay, White Rock area. I looked up and I saw what looked like almost marine layer clouds, except they were little strangely
No, that
striated.
was it. And you had to take your phone out and take pictures of it to actually like start seeing how it changes.
long
and
exposure.
then, like,
So
yeah,
I got in the car and I drove. I went out to actually because I grew up out in the country, and so I went out to tribal land out in the country, and I'm like, no one's out here, right? Out in fields, farm
no
fields.
light pollution.
Well, it turns out that all the tribal people will love that area, and so I was dodging pickup trucks out there all night with my camera. But they were they were really cool. So, so out there I saw the colors, but the thing that got me was with the naked eye, it looked white the whole time.
Right?
The majority
of the time.
Yeah, that's how it started for me where I'm at. I don't know.
And
if
then
you're too
the
close to
longer
city.
I'd watch, the more I would see like a bit of color come out.
Yeah, you have to adjust to the light, and after a little while, especially if you're looking at the zenith, it was shimmering. It was crazy. It was like in real time. It was like somebody was shining a flashlight back and forth across the oily surface of some water, except you're under the water looking up, and you realize that the water shimmering is actually the electromagnetic field.
Okay,
and the
so
beams are the
Yeah,
the
right.
radiation.
And I always see the
Yes.
shimmers. It's so wild.
I think light pollution is a part of this then.
It is a bit, and like you're not alone. My mom literally said the exact same thing that you did. She was like, I couldn't see any colors until I looked into the pictures, like it was all white to her.
Yeah. That was weird. So tonight you're going to get more, and Brendan, you too probably. I mean, anybody who got them last night, supposedly there's more tonight. So
Yeah, I was
which is,
curious
I
about
mean,
the
the
whole
elephant
peaks
in the
in the
room. Are we
pictures, too.
concerned
So
about this?
Tonight I'm
Should
going
we
to
be
take an
concerned?
IR filter and I'm going to block off my camera to see if it cuts off the pinks, because I'm curious why they're so invisible with the eye, but you can see them very, very clearly on the camera, and I'm going to find out what frequency it's at.
So what I
was
can
able
tell you
to
is
see some red with the naked eye last night.
I used 3 cameras. I did test shots with 3 cameras. One of them was my iPhone. I got an iPhone 15. This did the best. And my brother's shooting with an Android, and it was comparable. It was about the same. So I would say compared to that, and I have a really nice Nikon. But the problem with the Nikon is you really have to master the settings to do that.
Nikon, forget about it. Honestly, I'm not gonna. I don't just want to blatantly rip on Nikon because it's not like it's a bad brand for cameras, but Nikon CCDs are extraordinarily good at resolving noise and good lighting conditions. As far as the low light conditions, Fuji is one of the leaders. I mean, you look at Fuji's ISO, and it's like 5 digits or more. I mean, so I've seen 6-digit ISOs on Fuji, and you look at Nikon, and it's like, yeah, good luck.
Yeah,
good luck in video mode. Get good ISO in photo mode, but forget about the video.
And then the other one that I tried was an Insta360, just because I have that, and that was my action cam, right? And that thing, it did not perform. That did the worst in low light, but that's okay. You know, it wasn't designed for that. So
yeah, this is interesting too. This is one of the things that I did. So I modified this Sony Alpha A300. So this is the CCD you're looking at direct here, and then this is the IR filter.
You took
that
the filter
we
off
of it. So what I can do is, and for tonight, I'm going to take this and just set this to the side for now.
Yeah.
And pop back my telephoto lens on here, and so this way, by modifying it that way, you have to take the whole thing apart. I mean, it's a major pain to remove everything and try not to break the damn thing. But you can pop that out of almost any DSLR camera. They'll all have an IR filter in front of the CCD. And so if you remove that, you get something much closer to a full spectrum camera. So now I can see it into the deep IR, and I can see into the UV as well. And I would love to see how this will notice those other spectra.
So Jeremiah, let me put this up real quick. I want to riff on what you've been saying. I think I showed this to you last week, but I want to show the rest of the audience. Now, I am not recommending this brand, but I would say maybe check out this website. There are others out there. This is a company called Kolari. What they do, among other things, is they take cameras, just like Jeremiah just showed you, what they do is take cameras and they take off the IR and the UV filters, right? And they different cameras have different ways to do that. But one of the things that most people aren't aware of is most digital cameras can pick up at least a little bit into the IR, a little bit into the UV spectrum. Now, from the factory, they block that because it makes your pictures a little more cloudy, right? Like if you get a lot of UV coming in, your picture will not be as clear. But if you're trying to do experimental photography, that might be handy. So I wanted to show people this. And
I just want to mention too, with the UV and the IR problem, this is something that you guys have to consider if you're going to do mods to your camera or even buy one of these. That camera as stock, if you get that straight off the website, is probably going to be totally set and ready for you to go. But the problem is the lenses you'll get. If you use classic telephoto lenses, their coatings are not going to be designed for optimizing light frequencies that are in the IR and the UV. So what you'll notice is if you do pixel data analysis from a single light source that's UV, and you have it right next to another light source that's in the visible range, you're going to see the lens will twist that light and push it off to the side. So you'll have an aura or a ring around where you're normally seeing that light. You have to get special lenses if you want good IR and UV clarity.
Okay.
And some of the deeper wavelengths that the CCD can actually see, well, it turns out that they don't ever get to the CCD itself because the lenses block it. And the same thing for the UV. There's actually other wavelengths that once you do this modification, they can get straight to the camera, and there's nothing wrong with the camera body, but the lenses aren't suitable. So
that's a good point. The other thing that's worth consideration, I looked at the FLIR 1, and that's a plug-in for the iPhone. They got a couple of them, but like the older iPhones, right, you plug it right into the bottom, and the new one, it slings over the top. And what I noticed there was the resolution on those is like way, way, way less. And the reason is because you need larger sensors to get those IR frequencies, right? Because the wavelength is longer. So
yeah, I have one of those FLIR ones, and
okay.
It has two cameras. It has the IR and it has a visible light. And what it'll do is it'll kind of like frame the IR in that, so it kind of looks a little bit better.
So it's kind of a blob inside of a frame, sort of a thing.
Yeah, but it blends it in a good way. Like it makes it a little, unless you're doing like some kind of technical measurement, it's not that big of a deal. But they have two models, one that they have different temperature ranges, so just make sure you get the right temperature range. But that is an actual useful tool because you can take it with you and just pop it on when you need it. And the other thing that's
even in your case, Curtis, you see one piezo transducer that's getting really hot with that FLIR, and you're going to know exactly where your problem is. Like you may have a cracked disc and you would never ever know.
Yeah, so you could, there's really good useful things you could use, like electronics, like you could look at that, find hotspots. But the other thing that's really neat is if somebody's walking, because of the heat of their steps, you can actually follow them from behind and they won't even know.
Really?
You can see steps. Yeah, it's really cool.
Yeah, don't say that out loud. We don't want to give people ideas.
Oh, that's kind of scary cool. I like that.
The thing that gets me is, I'm interested in these, like they're useful for experimental work. A lot of people are trying to photograph UFOs and anomalies and things like that. And, it's to me that there's this general interest of like, okay, the more data we can get, the more that we'll know, right? Now, maybe that doesn't help us. Maybe it's not useful, but it would be interesting to see, okay, I got this UFO up in the sky, it's flying around. If I can get some infrared or UV out of that, what is that going to tell me? Does that make it more real or not? I don't know. It's just
more information, the better. Always, right? More.
Yeah, data. I mean that's kind of where I'm at. So. But it is interesting. It's useful, and that was why I put Kalari up. And so Jeremiah, thank you, man, because I think that was really valuable to point that out to people. These things can be converted.
Yeah, it's very cross-transferable data. It's just interesting to kind of see these technologies developing and the various problems that we face, because some of this stuff, it's like you get into it and you would never expect to have the kinds of problems that you're going to have in the field. It might be that you're running a Vega reactor and everything is perfect and you've got high vacuum, you pumped it down, but it turns out that your freaking gasket, your wire is transferring too much heat down to the gasket, and all of a sudden you get a vacuum leak down there and you get a catalytic reaction from it. So all kinds of stuff like that. It pops up, and you wouldn't think about it ahead of time, but once you do enough of it, you kind of see, you know, and you can predict, here's where the problems are going to be, how we can relinquish them ahead of time, and that kind of stuff. So it helps. I mean, that's why APEC is here, right? We're here to tell each other how we screwed it up, so that we don't make the same mistakes again and again.
So by the way, speaking of cameras, so we in the lab we're using a high-speed camera that can get like 520 FPS, and it's actually meant for astronomy. You can get one for microscopy, I should say. So they have, it's a Sony chip. It's a standard definition resolution. That was the video I showed. So that one, it's actually the problem with those high-speed cameras is the actual speed of the bus. So USB 3, you know, is the limiting factor. So as things get faster, we'll be able to get higher speed. So I think Sony makes one that can do like 1500 FPS, a sensor that can do 1500 FPS, but you have to hook up like 10 gig wire or 10 gig Ethernet or 25 gig Ethernet to get the speeds. So we're, you know, I don't know if we need to go that fast with it, but yeah, there is something to be said for like the camera technology that some, you know, that's used in astronomy and also used in microscopy, the stuff that can be low light. So in terms of like, I have one of those Sony A7Ss. That is 12 megapixel. It's a low light camera. They now have the 3 or maybe even the 4. I'm not sure, but yeah, it's you know, can do, I don't know, ISO like 1,000,000 or something. I don't know, it's ridiculous. And I also took off there is no we took out the IR filter is gone. There's a kind of a broad filter. So I use it for astronomy with the telescopes to get live views, and it's ridiculously fast. So there is stuff out there that you can buy and put together and track things. That's very, very doable nowadays.
Yeah. No, so the other one that I was playing with was again that Insta360, and the idea behind that, and it's kind of an interesting idea. It's almost like a Swiss Army knife camera, and so I'm going to take that down and see if we can use that with Jared. It's got some pluses and minuses. It captures kind of a sphere of video. It has a couple of fisheye lenses back to back, right? And it stitches them together, and it does seamless stitching. You can't tell where one picture ends and the other starts. So on that end of things, it's good. I'm using that new X4, which is supposedly 8K, but it wraps it around. So in terms of actual photo quality, it's a little bit less than an iPhone, and that's a little bit of a downer. You know, you're doing 360 photos. You're not going to complain about it, but it's definitely not even, you know, iPhone or Android quality. It's a little bit below, but the advantage to it, I guess, or at least our hope, is that you might be able to stick this thing in, you know, up next to an experiment or into a chamber or whatever, and you don't really have to know exactly where your photo is going to be. It's going to capture everything, and you can reframe after the fact. So
yeah.
So we'll see how that goes.
Yeah, I noticed Bob came back and then went away. So
yeah, well, I think we got probably about 10 minutes left for today. I want to thank all of you guys for joining us. I mean, you know, it was awesome digging into this, especially Brendan. Thank you, man. You had, again, that was like the off-road challenge for presentations. So
that was tough. I wanted to share some of the shots I got from last night.
Yeah, put them up
on big screen really quick if anybody was interested. And this, bringing it back to the Taurus again. My understanding was not just, so somebody, I think it was Russell, said it's because of the thinness of the electromagnetic field up here. I think it's also because the more of the radioactive particles are brought toward the top and bottom of the Taurus, which is part of the reason why you see the Aurora Borealis in the north, which is, you know, it's all coming back to the 0 point. But
I want to mention to you, Brendan, did you see my post on Space Case's server? I did do checks of the radioactive CME burst rate compared to the average during the solar storm while we were actually getting good photos. And it turns out that the background levels were not any higher than normal, but we got quite a few bursts that had as many as 30 counts per second. So The average
Yeah.
level didn't really seem to change. The burst level did increase.
Interesting. Yeah, I don't know what the exact levels are. I'll have to take a look at that. But I saw an image, a visual representation of how much more intense the radiation is right now versus normal background. It was some random example from 2009 or something. But I think we're definitely getting like peak solar activity, but I just wanted to share this.
Hopefully, like
So many
what
people out
happens
there
if
Hopefully
it
we all
gets
stay
more
alive.
intense than this? Like, what if there's still
That's a
a
good
full
question.
year of escalation? Like,
Who knows? And then what does that represent? And the things I was seeing in the sky last night sure looked like the glyphs from the Rongo script in Easter Island, according to Robert Schock. And it's just a
So
little bit
as you pull
concerning.
that up,
It was like
Brandon,
beautiful. I'm like, this might be
Yeah,
a
if you-
harbinger of doom.
did you have some pictures, Brendan?
Yes. Hold on.
yeah, as you pull that up, Brendan, I'll just mention to the audience still listening, like a lot of you have probably been having some pretty crappy sleep lately. It is not you. It is not just you. There are huge studies on this.
But you know what? I want to share with you. I'm the only person with a Y2K prediction that came absolutely true. So far, I predicted when everyone else was doom and gloom, I said, nope, it's going to be another 2,000 years of the same old BS.
I predict we'll get more lights, but we're still going to be able to be here again month after month because the internet won't go down and no doom and gloom.
Those are good. Those are good photos. So it looks like the ambient light looks like you had some problems with that the same way I did. It looks like it
Yeah,
washed.
these are from earlier. I'm showing these backwards in time for some reason, like retrocausality or whatever. But yeah, this is earlier in the evening when the light was still lighter. So what I experienced when I went out at first was kind of like you, which is like I thought it was clouds at first, and I wondered if it was aurora, and it was so. But then I went out because I go out often. A lot of my lifestyle is outdoors here on the farm. But I went out like just an hour later. It was like, whoa! I have to get the kids. Like it was above me. So it was just really. It was especially intense at the zenith, and that's where you got like these bird-like forms as the rays were coming down in your direction. I think it had a lot to do with it. It seemed like more of the rays were coming from the direction of the ecliptic, is what it seemed like, and that's what made the unique forms toward the ecliptic, which is here where I am at.
You saw a lot more red than I did. I saw more green.
And the pictures don't do it justice because they were all moving and it was shimmering in real time like a fish. It was
right. The
really
shimmer
intense.
is just so wild how it happens, and then
it looked like somebody was shining a spotlight around. Yeah, it was
and
nuts.
I tried getting
Very
video,
cosmic
but
experience.
none of my cameras would pick it up on
right.
video.
No video. I got you, Tim. It just goes dark. It doesn't capture it at all.
Yeah,
you have to go in the pro settings. Like pretty much every Android has them, but you have to go in the pro settings of your camera and turn on long exposure. Most of these are 30 seconds at least, so I'd let it sit.
So by the way, for the iPhone, there's an app called Nightcap Pro, which actually is a stacking program that'll actually stack images. So you can do low light stuff. The only thing is it has to be absolutely still. So you'll want it on a tripod or in a stand or something. But yeah, that's something that you can kind of almost turn your iPhone into a kind of like a low level astrophotography type of camera.
That's good advice.
And to be honest, it requires less configuration than a regular camera. So
yeah,
this is the baseline. This is Aurora. This is the baseline. This is Aurora. That's what it looked like
good photos.
Beginning of the night.
I couldn't believe it, Brandon, but even in the washed out light and all of these street lamps and everything in Milwaukee, Wisconsin, we were still able to see it with the naked eye, but we did not see the reds. We had to use our cameras to see the reds.
Lots of purples.
Yeah, yours are intense and very detailed. You got a lot more of the fine detail.
So you'll have another opportunity tonight. So I guess we'll give it a try.
Right, this is just from my little Samsung camera. No overexposure or anything.
Hey, you know what? Again, the smartphone cameras seem like they do better, and I think it's because they require less expertise.
Exactly, right? They just work.
Yeah,
Maybe,
I could not get anything in real
maybe
time.
Mark and
whatsoever.
Michael will be able to actually see these things tonight. You know, it would be a shame if he didn't get to see it because he's a Skywatcher too. So.
Yeah.
It
Well, guys, we got probably about 6 minutes left. So if you have anything to wrap up.
I was wondering if Bob is there. I just had a couple questions for him if he's still there, but I don't see him on the.
Yeah. Well, I think we're probably just about there then. So, you know, why don't I do that? So, why don't I close things down for this evening? I think that we've just kind of it sounds like everybody's going to be going out trying to get more aurora photos, at least everybody who's far enough north. And you know, and then the folks in Florida can benefit from our late nights, hopefully. So
And I recommend going out around 10 to midnight, wherever you are, and just looking and taking at least a few minutes to let your eyes adjust, take photos up, and then majority of the time what you think are clouds are actually clouds of ionized gas showing beautiful colors in the skies above.
Well, guys, let me close things down for today. It has been APEC for Saturday, May 11th, 2024. And I want to thank everybody for joining us and have a wonderful weekend.
And if anyone afterwards has anything to discuss, please do stick around just a bit after we end this.